Hi everyone, welcome to my channel. My name is Saldina. I am a software engineer and I make programming and IT related videos here on YouTube. So if that is something that is of interest to you, consider subscribing to my channel. And this video is going to be all-in-one C++ full course for beginners. And the goal of this video is to take you from that place where you are struggling with programming, where you don't understand how to read code or write code, to a place where you feel really comfortable writing code and reading code and you really understand what the code is doing, because that is the most important part. So this course consists of lectures where I will teach you a specific concept, and then there will be a task, and by solving that task you will get a good understanding of that specific concept. And then the complexity of those tasks will gradually increase so that at the end of this video, if you finish it, you will have a very good understanding of the most important programming concepts, not only in C++, but you will be able to take that knowledge with you to other programming languages as well. And then at the end, after you finish this course, in the description I will leave directions for you on what should be your next step, because I have created a roadmap with steps and directions so that if you follow those, you will be able to build your programming knowledge to a very, very high level. But before we start, I want to ask you one question, and I feel extremely proud and happy that you decided to invest your time to learn programming, and I can personally give you many reasons why that is a great decision. But what I'm more interested in is, what are your reasons? Why would you like to learn programming and be good at it? Is it because you are a very creative person, or you want to get a job and earn a lot of money, or you want to gain those problem-solving skills, or because you think that programming is cool? So any other reason that you might have as well, please write that in the comments down below. And then make a public commitment before you start, because that is something that will motivate you. So write, I will learn programming because, and then put your reason and hold yourself accountable. So I am very much looking forward to reading your answer in the comments down below. So without further ado, I will just roll the intro and let's start with the video. Hi guys, very warm welcome to everyone watching this video, and this video is going to be Introduction to C++ Programming Language and the first video of this course. I was planning on dividing this video into two separate parts, so that in the first part I'm going to explain some basic concepts, some general concepts that are related to C++ and that you need to understand, in my opinion, first before starting to write code. And then in the second part we are going to build our first C++ program. So I'm going to include in the description of this video timestamps so that you can navigate yourself to the coding part if you want. But if you're an absolute beginner, I would recommend you to watch the entire video. Let's explain a couple of concepts before we actually start to write code so that you are familiar with them. You may wonder what kind of applications you can build with C++. Well, C++ is general purpose language. That means that it can be used to build all types of applications. So it is very close to the hardware, and that means that it can manipulate resources easily, so you can build operating systems if you want with it. You can build compilers, browsers, demanding games. So all general purpose software can be built with C++. It is not specific for only one domain, but it can be used to solve and build different types of applications. After that, I would like to mention that C++ is compiled language. That means that the code that you write first has to be compiled or converted, translated into another language that is understandable to your machine, to your computer. So that phase is called compiling code or building code. There are certain errors that can occur in this phase, of course, and those are compile time errors. This type of errors is usually the most common among beginners, among people who are just starting to learn C++, and we are going to demonstrate some of those compile time errors when we start coding. After that, C++ is case-sensitive language. That means that C++ distinguishes between lowercase and uppercase letters. So if you have, for example, a variable all uppercase and then a variable all lowercase, so the same meaning, the same word, those two are going to be treated and understood differently as different variables by C++. So it is case-sensitive language. Why C++ was created? Another question. Because before it, there were other programming languages. Well, yes, they were. And it was created in 1980s. And it was created with two programming languages in mind. One of those two was Simula, and the other one was C. So Simula at the time was great language for human way of understanding and representing things. So it was very understandable and easy to use to humans. But at the same time, it was very, very slow. So they decided to combine it with another programming language, a fast one. And at that time, the best choice for that was C programming language. So they combined the two and they got C++. C++ is very, very understandable language, very easy to use by humans. So you can build and maintain huge projects with C++. But at the same time, because of this C part, it is very close to the hardware, so demanding tasks can be executed fast. And also, well, since it was created from C programming language, you can say that any valid C program is actually valid C++ program. So if you've ever built a C program, you have actually built a C++ program already. As I have already said, the code that you write is not directly understandable to your machine. So first, it has to be converted into another language that is understandable to your computer. But the language that is understandable to you is called source code. I am going to put here an example of source code, and I'm also wondering at this moment, what do you think that this code does? So before we started any programming, any coding at all, what do you think that the result of this program is going to be? So just to check how understandable C++ really is, even for someone who has not have a lot of experience in coding. So write in the comments of the video what you think that this code is going to do, and I'm going to check those. So at the same time, you're going to be doing something called writing pseudocode, which means describing what a program does, but just in plain English, so no C++. So this is the source code. After that, that source code is transferred or translated into another form, another language which is understandable to your computer, and that is object code. That object code is usually in the form of binary numbers, so ones and zeros. And that is the only language that your computer actually understands. And this is an example of your machine language. I'm also not going to ask anyone to describe what this here does, because this is highly unreadable and cannot be understood by humans. But as I said, it is the only language that your machine understands. So algorithm, what is algorithm? Algorithm is nothing more than a recipe. So steps, instructions that you write to your computer, list of ingredients and steps that your computer needs to do in order to perform a certain task, that's algorithm. Now that we have understood these concepts, let's switch to more practical part. So the tool that we are going to use is called Visual Studio 2019, and there is a lot of tutorials on YouTube on how you can download and install the Visual Studio, and you can also use community version for free. So when we open Visual Studio, you can see that here in this left part we have our recent projects. So the project that I have recently created. And this may be empty if you haven't used your Visual Studio. So on the other side there is a menu with multiple options. You have the option to check out your code from GitHub here. You can open existing project from your computer and continue working on that. But the option that we are going to use is called Create New Project. So we are going to click that. So this new window now here appears, and we are going to define what kind of project we want. As beginners, we are going to build a very simple app. So we are going to build a C++ console application. So you can type in C++ and make sure to select C++ console application. So not C#, not Visual Basic, but C++. And when you clicked it, you can now when you selected it, you can now click Next. So this new window now, we get a new window where we have to define our project name, location where our project is going to be saved, and our solution name. As default, our solution is named the same as our project. What solution is just actually a group of projects. So if you had a huge application and you wanted to divide it in smaller parts so that it is easier to maintain, you could divide it in multiple projects, but all of those projects would be part of the same solution. So since we are building a simple app, we have only one project and we will name it My First App. So my first app. And location for our project we can either enter manually or we can do it by clicking this button here. And I want my files to be saved on desktop, so I'm going to select desktop. And now we are done with creating our project, so with configuring our project, so we can click create. So the tool that we are going to use, Visual Studio, is an IDE, or Integrated Development Environment. That means that it has a lot more options than just those that we as beginners are going to need and use. So for now, I'm going to explain only the most basic ones, the ones that we are going to need as beginners. But as we progress along the way, I'm going to explain the new features that we'll use. So the first thing that you can see here is our Solution Explorer. So if you cannot see your Solution Explorer, you can click here to this view and select Solution Explorer, and that should bring your Solution Explorer back to view. So as we said, our Solution Explorer is named My First App, and it has one project inside it. So this project is this one here. And as you can see, when we created our project, it was created with some default folders and files. For now, we are going to use only one file, so you can delete these folders, header files and resource files if you want. Just right click and click delete. So now this source files folder is where we are going to put our source code files. If you remember from before, I have said that source code is the code that we write and that is understandable to us. So this is our source code file. So this with .cpp extension. So when we created our project, this file was created by default. And if you double click it, it opens here. So this part here is nothing more than a text editor. Really, as any text editor, it just has these different colors depending on the purpose or the role of the code, so that you can manage the code easier. If it were all the same color, it would be harder to read. So for example, this green part here is a comment. Comment is just a note for yourself. So compiler will not try to translate commented lines. So if you type, for example, here this // or that means actually begin comment, and then you can explain, for example, what this preceding code does. So you can write, this will output to the console hello world. So this will output to the console hello world, so that when you, for example, come tomorrow to this code and you have forgotten what this code here does, this will remind you, this comment here. And these are some default comments, which I will delete now. We are not going to need this. So just select everything in click delete as you would in any regular text editor. This part here also. Now let's explain what we got here. So this include IO stream is actually a header file. So it is also called a library. And this IO stream is input-output stream. So it allows us to input and output data to and from our program. For example, thanks to this, we can use commands such as this here. So cout or console output. So without having this, we would actually have to program ourselves how we will input and output data in our console. So we will not delete this line here. Now check this code here. It says main. Well, that means that this is our main function. So a main procedure that our program is going to execute. So whatever you put actually in these braces here, your program will execute. And the execution of your program begins here and it ends here. So since this here is the scope of your main function, so you can collapse it by clicking here, and you see that everything is collapsed now. So for now, it's enough for you to know that this is our main method, our main procedure. And later in this course, we are going to learn and understand what methods are used for, what is their purpose, and we are also going to create a lot of our own methods. So now we have this cout or console output, which is the command to output to the console. And then we have it also combined with this std and these redirection signs. So std is the namespace for this cout. So that's how your computer knows what this cout really is. I will show you later how you can get rid of this if you really want. And we also have this hello world in quotation marks. Okay, let's see what we have learned so far. We said that this is our solution. Inside it has one project, and within that project we have this file with extension .cpp, which is our source code. So if we double click this file, it brings us here, so to this text editor. And this is our program. This is the code of our program. Now, how we can run this code? Well, see this green play button here? Well, that's our start button. It's really intuitive. So if I click it, we will get our hello world text here, which I have outputted to the console. And you can also see that we have, besides our hello world, we have gotten some junk text here. So what I'm going to do is show you how you can get rid of this in a moment. So let's close our program for a moment. And what you need to do in order to get rid of this junk text is type this command here. So system pause greater than 0 in quotation marks, and the end of command. You notice that at the end of each command, you have to put this semicolon. And if you didn't, it would result in a compiler error, and I will demonstrate that. Let's run our program now, and you will see that our junk text has disappeared. So as I said, after each command, you have to put this semicolon, and if you didn't do that, it would create a syntactic error, and then your compiler would not be able to understand, and your program would not run. Actually, your program would not start. So if I delete this semicolon here, you see that something has changed in this window here. So you see this error red sign. Well, if I hover over it, you see it here, also here. It says expected a semicolon, which is very clearly says that you are missing a semicolon. And if you see this red underline here, it says also expected a semicolon. So before this, you are missing a semicolon here. So if I add it here, our error will disappear. So if you try to run your program before fixing this error, it would prompt you with a window like this. So it says you have 1 failed project and 0 succeeded projects. So this is the code building that I have mentioned before. So this one project, which is actually the only project that we have, has failed building. So your compiler does not actually understand what you have written since you're missing a semicolon. So another thing how you could know that you have syntax error except from this prompt window that we got is this syntax error, so missing semicolon before this closed brace. And if you click it here, it will take you right where you need to go to fix your error. So it's very useful. And if I press my play button again, it now says hello world. So I will stop the program now. You can do it either by clicking this red sign here which says stop debugging, or you can click this X on the console window. So if some other error has happened to you, which didn't happen to me here, you can write that in the comments down below and I will gladly help you. Also, someone else can help you from the other people learning from this video, and I would highly encourage that, since in my opinion the best way to learn something is to try to reproduce what you've learned and to explain it to someone else. So write in the comments if you got some other error. Now let's see how we can upgrade our program. So let's write something else. Let's add, for example, std to column size, console out. So under quotation marks, I will put something that I want to write out. So let's say, for example, my name is Saldina. You can put your name, of course. And at the end of each command, you put semicolon. And let's add one more. So let's say today is Friday. And also add end of command here. So it should write, when we run our program, it should write these sentences in this order here. So you can run your program. And if you can notice, it has this new line in the first sentence. So this is because of this \n. So that puts whatever text is coming after in a new line. So you can put that text in a new line by either entering a \n or with adding this std end line. So std end line, and I have previously stopped my program. If I run it again, you see that we have gotten a new line here. You see also that this std here is becoming a bit tedious to write again and again. And I've told you that I'm going to show you how you can get rid of this. So what you can do is you can put this std on a global level. So you can say using namespace std, and what will that do is reference this std namespace on a global level, so you don't have to reference it every time that you are using it. And now we can delete all of these. So wherever you have written std, that's going to be referenced here now, and you don't need to write it separately. And if we run our program, here we are going to get our result. So we have also this new line added by either /n or this end line here. Okay, so in this video we have learned how we can output data in a console, and in the next video we are going to see how we can input data into our console. So we can ask user to input data, and we are also going to talk about variables and data types. Another thing that I want to show you before I finish this video is you may be wondering, okay, do I have to start Visual Studio every time that I want to run my program? Is there any other way for me to execute my program? The answer is no, you don't have to start Visual Studio every time. There is another way to start your program from Windows. So let's save all changes that we have made here so far. So you can press Ctrl+S, or if you have made any changes, you see this star here. So it is indicating that you have unsaved changes. So you can right click on that and click Save. And you see that that star disappears now. So let's find a folder where we have created our project. For me, that was desktop. If you followed this tutorial from the beginning, you created it also, and if you followed me, you created it also on desktop. So you can open your folder. You can go to debug, and inside that you see this file here. It says application. So this is your program. So if you right click on that and you check its properties, you will see that it says .exe. That means that it is executable file. So that is your program, that is your application. And if you double click on that, well, you see that it runs same as in Visual Studio. So you can start your program from Windows. Actually, if you want to show it to your friends or someone else, you don't have to open Visual Studio each time that you want to run your program. But one more thing to keep in mind is that if I go to Visual Studio now and I add one more line, let's say we write out "Have a nice day." So, and if I save it, so Ctrl+S, and if I try to open my program from Windows now, what you'll see now is that this new line that I have just added is missing. But why is that so? Well, if you remember, when we were talking about building code, we said that that's the phase of converting source code that you have written into a code that your machine understands. And when you start your code from Visual Studio, it does that process automatically for you. So it builds your code and then it executes your program. But when you are starting your program from Windows, it is missing that phase of building code. So your recent changes, your last changes were not translated. So your computer has the only translated version that it has is the previous one. So without your recently added changes, what you need to do is you either have to run your code from Visual Studio first, or it's enough for you just to build that code inside Visual Studio. And what happens when you do that, so just click here and you can click build, and what happens is your Visual Studio translates this code that you have written and it saves it here. And now when you run it, and when your Windows runs it, it has the latest version, it has the latest changes. So this is the small trick that I wanted to show you. So this would be all for this video, and if you came across to some errors that didn't happen here to me, or you have any questions, you can write those in the comments and I will answer those. And if you watched so far, you can like this video, you can subscribe and share it with someone else who would also like to learn programming, and I will see you in the next video. Hi guys, I hope you are all well, and welcome to the second video of C++ for beginners. In this video we are going to talk about variables, data types, and also I'm going to explain how you can enter data in your program and how that data is encoded into numbers using something called ASCII table. So here I have opened Visual Studio, and if you are not familiar with Visual Studio, or there is some code that you see here but you don't understand it, I would recommend you to watch my first video of this course. The link is going to be in the description of this video, and then come back to this video. So let's talk about variables now. What is variable? Well, I like to explain it through a real life example. For example, you see this glass here. Well, what I can say about this glass is that it is a container for a certain type of liquid. So it can hold water, milk, tea, juice, whatever you want really. And the same way, a variable is a container, but for a certain data type. So you can put whole number inside it, you can put character or a decimal point number or a Boolean value, meaning true or false value. So they are the same in this aspect. Another thing that I can say about this glass is that it defines a maximum amount of liquid that it can hold. So it has a max limit. And if you put too much, it will overflow. The same way with variables. Variables also define a maximum amount of data that they can hold. For example, if you have a whole number variable, well, there is a max number limit for that variable that it can hold. And also, if you put too much, it is going to overflow. It is literally called data type overflow. So it is a container, the same as variable, and also it defines a maximum amount of data that it can hold. But how much data you really put inside that variable? So the same way with the water inside this glass, if you decide to put 1/3 or 1/2 or 2/3 of this glass, the same way is with variables. You can put however much you want as long as you don't put too much, because then it's going to overflow. One thing that is different though between variables and this glass is that you can put one day inside this glass you can put water, the next day you can put juice, the next day you can put milk, then tea, or even you can mix two liquids. But with variables you cannot do that, at least not with ones in C++. There are certain languages that you can do that with, and there is also advantages and disadvantages when it comes to that, but in C++ you cannot put two different data types inside one variables, and you can also not change a data type of variables once you create it. So let me show you what I'm talking about on a practical example. Let's say that you want to create a variable that is going to hold your annual salary. Well, that variable is definitely going to be a decimal point number, or also floating point number. That's how it's called in C++, and the type that is used for that is called float. So I'm going to say float, and then I'm going to give a name to that variable. Since we said that it's going to hold annual salary, we are going to call it annual salary. Okay. And then we are going to assign it a value, and that value is going to be, let's say, 50,000.99. So now what I have done here is I have created a variable called annual salary. I have said that that variable is going to be of type floating point number, and then I have put inside that variable 50,000.99. So now let's see how we can, based on this variable, based on our annual salary, calculate how much our user is earning every month. So what we are going to do is we are going to create another variable. We are going to call it monthly salary, and we are going to assign that variable a result of dividing this annual salary with 12 months. So we are creating a variable of type float also, since the result of division usually can be also floating point number or decimal number, and because of that we are using also float type for our monthly salary variable. So I'm creating monthly salary variable, and I'm going to say that that variable is going to hold result of this expression, annual salary divided by 12 months. And now we have result of this division inside this variable, and what we are left to do is to write that result out to our user. So I'm going to say cout, since that's the command that we use to output data to console, and I'm going to say your monthly salary is, and I'm going to say monthly salary. So one thing to notice here is that when you are writing out strings, or when you're writing out data like this, you use quotation marks. But when you want to write out the value that you are holding inside a variable, well, then you just put the name of your variable. You don't use any quotation marks then. And now we can run our program, and let's see what's the result that we got. You see here your monthly salary is 4,166.75. So if you want to check that out, you can calculate it in your calculator. One thing that that bothers me in this program is that we have hard-coded this value here. So we have hard-coded this 50,000.99. Not everyone's salary is 50,000.99. And what if we wanted our user to enter what his salary is during the execution of our program? So when he runs our program should ask him, what is your annual salary? And then he enters that salary, and then we calculate his monthly salary based on the number that he has entered. So I would like to upgrade this program now to work like I just explained. And how we are going to do that? Well, first I'm going to delete these 50,000.99. Okay. And then we are left with this situation here. So it says float annual salary. That means that I have just created a variable called annual salary, and I have said I'm going to put a floating point number inside that variable, but I have not assigned any value to it yet. So here we have a container for our annual salary, and that container doesn't hold any value. And if we try to run our program now, what do you think that we are going to get? Write that in the comments before I run this program. And now I'm going to, so pause the video and think about it, and then write your answer in the comments. And now I'm going to run the program, and you can see that we have some build errors, as this here, this window here says. So let's see. If we open this part here, it says we have one error, and that error is uninitialized local variable annual salary used. What that means is that this expression here, if you see this green underline, it also says using uninitialized memory annual salary. Well, that means that this expression here, our computer doesn't know how to do this expression, since we haven't assigned any value to our annual salary variable. So it doesn't know how to divide that with 12, since there is no value inside that container, inside that variable. So this causes a compiler error, and whoever has written that compiler error is going to occur, he was right. So what we have to do to correct this is we have to ask our user to enter his annual salary. So what we are going to do now is, let's see first. The command that we use to output data from our program into our console is cout, so console output. And the command that we use to input data is console input, or cin. So I'm going to say cin, and then we use these other redirection signs, and then we say what is the variable that we want to store what our user has entered, and I'm going to say annual salary. So what I have said here is our user is going to console input the data, and then whatever he has inputted, you have to redirect that inside our annual salary variable. So now, if I run my program now, you see that our program runs now, so there is no compile time error. And also our cursor is blinking. Well, it is blinking because it expects here our user to enter annual salary. But this is not really clear to someone who has not made this program. So what we have to do, if I enter some value now, well, it is going to calculate it correctly, but this is not really user-friendly. So what we have to do is we have to write a message to our user before he enters anything so that he knows what he should enter. So before this cin command, I'm going to say cout, and I'm going to say, please enter your annual salary. Okay. And now, if I run my program, you are going to see, please enter your annual salary, and the cursor is blinking, waiting for you to enter the value. And if I say, for example, 40,000, you see that your monthly salary is 33333. So the program has calculated your monthly salary, and the number is based on whatever our user decides to input. So we have upgraded our program. And there is also one more thing that I would like to show you when we are doing this example, and that is, let's say that we want to calculate how much money our user is going to earn in 10 years. So let's say cout, in 10 years you will earn, and now we have to put a value of how much money he is going to earn. And if you look at this situation here, we first created our monthly salary variable, and we then assigned it a value of annual salary divided by 12. But there is another way that we can write out results of expressions without creating any variables, if that is what we need. And that is just here. So in this line, in 10 years you will earn, you add these redirection signs, and then you say expression that you want your computer to calculate. And what we want to calculate is how much our user is going to earn in 10 years. So that is annual salary times 10. And if you do it this way, so if you don't decide to create a variable, then you will not be able to use the result of this expression later in your program. So you don't have a container that holds this 10-year salary, but you have a container that holds annual salary and monthly salary. So each time that you want to write out or do something with your 10-year salary, you will have to write this expression, while if you want to do something with your monthly salary, you have a container that is holding that value directly for you and you can access it. So if we run our program now, you see it expects us to enter our annual salary, let's say 50,000. And you see here your monthly salary is 4,166.67, and then in 10 years you will earn, what is this, 500,000. So okay, one thing that we are missing here and that you can add is end line or \n. So you can add it here, and your program is going to format your text nicely. So this line should go here like this. If I add here one more end line, and if I run my program again, you see enter 50,000, and now we have our text formatted nicely because of this end line that I have just added. Let's now create another variable, and this time we are going to create a variable of type character. So char, that is the type that is used for character variables in C++, it's called char, and let's name our variable character. And when you want to assign a value to a character variable in C++, what you use is these single quotes, like this. If you see this example here, when we are writing out text, so string of text, we use these double quotation marks. But when you want to assign a character value of a character variable, we use these single quotations, like here. And there are also some more rules when it comes to naming your variables. And the most important one, in my opinion, and the most important one to make it easier to you, is to name your variables according to their purpose. So give meaningful names to your variables. That is really, really important. For example, you see this monthly salary variable here. We could have as well named this variable blah, 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 and copy it here also, because we are having compiler error right now, because our compiler does not know what this variable really is. You see, it says identifier is undefined because you have not created this variable here, because it supposes that it is a variable, but it has not been created before, so it does not recognize what this variable is. So we have to copy the new name here also, and now our compile time error disappears. And this here, this name, does not represent anything to your computer. So your computer is now going to run your program, and your program is going to work just the same as it did before. But this is really making it hard for you to understand what your code is doing. And especially if you come to this, for example, in 10 days, or someone else tries to understand your program, this is really hard to read. And he will just try to uncover really what your program is doing without understanding it, because you have used these blah 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 names for your variables. The same situation would be if you, for example, have 3 boxes inside your kitchen, and you use one for storing sugar and flour and salt. And instead of naming those sugar, flour, salt, respectively, you decide to name them red box, green box, and blue box. And then someone else comes to your house, someone else comes to your program, he does not really know where to find sugar, because red does not mean that that box is storing sugar. So you should name that box sugar box, because imagine 3 is easy to remember, but imagine having 10 boxes or 10 variables or 100 of them, or even 1,000, which is very common inside large programs. So what you should do, and I am going to do, is return that previous name. So monthly salary, and here also. So you should give meaningful names to your variables. That is very important. And that is the first rule. The second rule is that, well, the second and third and the fourth are the rules that you will have to obey in most cases, because if you don't, then you are just going to get a compile time error in 99% of the cases, let's say. And I'm not going to say what that 1% is, because I want you to obey these rules. So when it comes to naming your variables, another thing is that your variable names cannot contain any special characters except underscore. So like this. This here is valid name to your variable. But if you try, for example, to name your variable like this, so you say plus character, you see that here in this error window it says expected an identifier. So you cannot use this to name your variable. Or this, you cannot say character with this minus inside it, so character minus ter. So these signs, these special signs, are used for something else. They are operators inside C++, and you are not supposed to use those inside your variable names. If you really want to use some special signs, what you should and can use is underscore, like this. So this is the only sign that is allowed and that I recommend for you to use for naming your variables. That's the second rule. The third rule is that your variable names cannot begin with numbers, like this. So you cannot say 8 character, for example. It also says expected an identifier, but what you can do is you can say, for example, character 8. That is a valid name. So a number can be on any other position except on the first position. So this is a valid name for a variable. So you can put also number here. So you can say, for example, C12 character 8. But again, what does that really mean? That is not a meaningful name for a variable. So again, we come to the first rule. So you should name your variables according to their purpose. So I'm going to return this to character name again. And then we have our third rule, I guess, which is you cannot use space inside your variable names. So for example, this is not valid, and your compiler says it here. So it gives you an error. It does not know what this really is. So you cannot use blank spaces inside your variable names, because you are going to get a compile time error. And if I try to do that and I try to run my program, I get the window. So it says, you cannot run this program. You have syntactic errors. What you should do is you should correct those errors, and then you can really run your program like this. Okay. So let's repeat these rules one more time. The first rule is that you should give meaningful names to your variables. So name them according to their purpose. The second rule is that your variables cannot contain any special characters except underscore. The third rule is that your variables cannot start with numbers. You can put number on any other position, but not on the first one. And the third rule is that, and the fourth rule actually, is that your variables cannot contain blank spaces. So empty spaces, no in a variable name. What you should do is you should name your variables according to their purpose, so meaningfully, and you should also use something called camel casing. What is camel casing? You see how I have named this annual salary here. You see that the first letter of my variable name is small letter, and then the next word starts with capital letter, and that is called camel casing. So for example, you would name your variable like this: first, second, third. So like this. You see that this first, second, third, these are words inside your variable name, and this F is lowercase letter, that's the start letter of your variable, and then each next word begins with capital letter, and all the rest is lowercase letters. That is called camel casing, and that is something that is usually used with C++. Let's talk about data types now. I am going to delete this code, so if you need this code for a bit longer, you can pause the video here. So, what kind of data can we store in our variables? Well, for now we are going to cover only the most basic ones, the ones that we are going to use frequently, and you should know that there are a lot more data types besides from these that we are going to mention here, and more complex ones that we are going to cover later in these videos, in this tutorial. So the first one that I would like to mention is a whole number data type. So integer, a data type that can hold negative whole numbers, 0, and positive whole numbers. So the type that is used for that in C++ is called int. And good example for int variable is, let's say, year of birth. So that is an example of a whole number variable. And let's say that that variable is going to hold 1995. Okay, so that would be an integer variable. After that, we have already seen this. So it is a character variable. So let's say char. And an example of a char variable could be gender, for example. Let's call it gender. And you can store F for female or M for male, for example. So the char variable can store one character. Then the next one is Boolean value, meaning true or false value. This is the simplest one, and the type that is used to store Boolean is called bool. And a good example for a bool value could be, for example, if you want to hold in your program a variable that tells you whether your user is older or younger than 18 years old. So let's call our variable is older than 18. And we can assign to that variable either value of true or false. So I'm going to put true true here. Another variable, another data type is decimal point number, also called floating point number, which we have mentioned before. And let's create a variable of type float. And let's say that that variable is going to hold our average grade. So average grade. And this average grade can also be a whole number, but since it has potential to be also floating point number or a decimal point number, we are going to use a float data type for this average grade. And another data type that I would like to mention for also storing decimal numbers is called double. And the difference between double and float is that double is double size of float. So if you remember when we talked previously about taking memory space that variables take, so float is taking 4 bytes and double is taking double of that, so 8 bytes. So you can put much more data inside your double data type than inside float. And let's say, for example, that if you had a credit card and you had a lot of money, a lot of money, and you want to store that value inside a variable, you would use a double data type. So let's say double balance equals to this large number here, which I'm not going to even try to read. Okay. So these are the most common data types that we are going to use in this tutorial. I have said earlier that each data type takes a certain space in memory, but let's see exactly how much each of these take. For that, we are going to use something called size of operator, and let's see how we use it. So cout size of int is, and then we write this size of. So size of, and in parentheses we pass to it data type that we want to check how much memory it is using. So int. And if I run my program now, you see that it says that int takes 4 bytes of memory. And if you've ever actually studied binary algebra, you would know that 4 bytes of memory is actually 32 bits, since each byte has 8 bits. And as we said, our int can store both positive and negative numbers, and 0 also, remember that. So the first of these 32 bits is used to determine whether the number has plus sign or minus sign, so whether it's a positive or a negative number, and then remaining 31 bits are used for this value itself. So let's check what is min value for our int. Let's write that out. Let's write cout int min value is, and we have a reserved word for minimal amount for int in C++, and that is int underscore min. And if I run my program now, you see that it says this minus 2 billion, extremely hard to read this number, but you see that this is the minimal amount of int. So this number is actually 2 to the power of 31. Let's just quickly write these. So minus 1, minus 2, minus 3, and then minus this number here. So this number, as I said, is 2 to the power of 31. Why not 32? Because this 1 byte is used to represent this minus prefix. Now we should check a positive number range. So we also can write int max value is, and then there is another keyword in C++ for int max, which is int underscore max. And are you expecting to see this same interval but just with plus sign? So write in the comments, what are you expecting to see? And if I run my program, you see that that did not happen. And if some of you know why it did not happen, I would also like to hear what you think, why we have this number here and then this number here for our negative and for our positive range. So different ending number. And I'm going to explain why. Because this positive range here, we have to include 0 also. So in order to include one number here, let's just copy this and paste it. So our positive range is going to from 1 up to, let's say that it is this number, but since it is including 0 also, in order to include one number here, so 0, you have to take one number here. So this here is not 8 anymore, but is 7. So that is why we got, let's say, different number for our positive and negative range, because this here includes 0 also. One thing that I have to mention though is that if you want to use only positive integer numbers, there is a data type for that as well. And the data type that is used for that is called unsigned int. And its size is the same as of int, so 4 bytes or 32 bits. But since it is unsigned, that means that it does not use 1 bit for sign, because the sign is by default plus, but it uses all 32 bits to represent value, and those values go from 0 to, let's see exactly how big of a number, 4 billion and something. So cout size of unsigned int is, and let's see size of unsigned int, this is the data type. And let's also write out what is the max value of unsigned int. So let's say cout uint max value is, and there is also a reserved word for that, and that is uint underscore max. So if I run my program now, you see that we got 4 billion and something number, so double the size of this. And this is actually 2 to the power of 32, but minus 1, because we are also including 0 in this range. So let's check these remaining data types. I'm going to write those out quickly and I will be back. So I have written here the rest of these data types, and as you can see, since our bool is only true or false value, 1 byte is enough for bool. Our char is using also 1 byte, float is using 4 bytes, double is using 8, and I'm also going to include a table with some more data types which we haven't mentioned here, so if you need to check those out, please pause the video. One thing that I promised to show you is data type overflow. Let's see what that is. So let's create a variable of type int and call it int max, and let's say that I want to store inside that variable maximum amount of int, so int underscore max. And I'm going to write that variable out now just to see how big of a value that really is. So cout int max, and if I run my program now, you see that I have gotten here this 2 billion, very large number actually. So that is the max amount of int. Now my question for you is, what is going to happen in this situation? So cout int max plus 1. What is going to be the result of our program now if I run it? So some of you may know this already, some of you may not, but I am very interested in reading your answers. So make sure to write your answers before watching my explanation on this. Write those in the comments down below. And if I run my program now, well, our number has not increased by 1, but it has went to the minimal amount of int. And why has that happened? Well, that is the data type overflow that I was talking about. And how this works actually is it works the same as your clock works. So it goes 9, 10, 11, 12, and then from 12, since that is the max value on your clock, it does not go to 13, but it goes back to min, so 1, 12, and then 1. And that is applicable here. It went from the max value to min value just by adding 1. And that is called data type overflow. I already can see that this video is pretty long, and I'm currently having problems uploading very long videos to YouTube. So I'm going to leave for the next video explanation of ASCII table, and we are also going to do some more examples and practice C++ some more. So make sure to subscribe to my channel and also click the bell icon so that you are first to be notified when I upload my next video, and also like it and share it with anyone who you think could benefit from this video. And I will see you in the next one. Hi guys, welcome to my channel. As I promised in my previous video, in this video I'm going to explain the concept of ASCII table, and then I'm going to give you an idea, an example of a program that is very beginner friendly, very simple, but also very fun, and that you can build only with knowledge from my 2 previous courses and this one. So if you haven't watched those, make sure to watch them. Link is going to be somewhere here and also in description. And also make sure to like this video and to subscribe to my channel for more educational content. And let's begin now. So what is ASCII? Well, ASCII stands for American Standard Code for Information Interchange, and it was first created in order to standardize the way of representing characters in your computer. So in ASCII table, those characters are represented as numbers, numeric codes. And what this means is following. Let me give you an example. When I first learned to read and write, so when I was a little, I decided to, together with my friend, create our special symbol language, where we would exchange each character with a special symbol that only 2 of us could understand, and then we would exchange letters using that symbol language, and no one else could understand those letters. And also, guys, write in the comments down below if you did that. I know you did, so don't make me feel like a weird one. Well, that is exactly what your computer does. It exchanges each character with a number so that it can understand it and it can communicate with other computers. So this means that your computer or ASCII table assigns to each character a unique number. And let's prove that now. So how we can do that is, in my Visual Studio, I'm going to say cout. And then in these parentheses, I'm going to say int, and then these single quotes, and I'm going to say letter A. And let's add end line. So this is one way of doing that, and then there is another way of doing just the same thing, and that is, let's say cout, and then int, and then inside these parentheses, we are going to say our single quotes and our letter A, and also add end line. So this here is called casting operator, and it is the operator that forces one data type to convert into another. And since we said that each character has its numeric pair inside ASCII table, well, we can ask our computer to give us that pair. So here I'm saying, please tell me what is my numeric pair of my letter A. So what number is my letter A? And if I run my program now, you see that I got 97. So our lowercase letter A is 97 in ASCII table. Let's check now a capital letter A. So I'm going to say cout, int off, and let's put our capital letter A and one more end line. So if I run my program now, you see that I'm going to get a different number, so 65. And this is so that your computer can distinguish between lowercase and uppercase letters. So ASCII uses 7 bits to represent each character, and that means that it can represent 2 to the power of 7. That's how much characters it can represent, so 128 characters. And that is enough for all English characters, so all English lowercase and uppercase letters and numbers, and also some special symbols. But there is also a lot more languages, and also languages that have a lot more characters. So there is a lot more standards for representing those characters inside your computer. So this that we have just mentioned is called ASCII, and there is also extended ASCII. That is another standard that can represent more characters. Then there is also UTF-8, UTF-16, and a lot more different standards. So what we should remember for now that is related to ASCII is that ASCII represents each character with a number, so it holds its numeric match, its numeric pair in its table, and then that we can also get that numeric match using our casting operator. So this here is a casting operator. So now you may ask, if we can get a numeric value of our letter, so if we can get our int number of our letter, can we do vice versa. So can we get a character from our numeric value? And the answer is yes, we can convert a number into a letter also, and I'm going to demonstrate how we can do that in a moment. So you can say cout char, and let's say char of 65, and add end line. And if I run my program, you see that I'm going to get a letter A, so capital letter A. And now with this, when you learn this, you can get an idea on how you can build something more useful than just basic Hello World application. So you can, for example, build a program that ciphers words and sentences in an ASCII, and then also a program that deciphers those messages back into English readable characters. So now we are going together to build a program that ciphers words into ASCII codes, and then I'm going to leave to you to build the program that deciphers those words back into English readable characters. So let's say that we want to cipher a 5-letter word. So what I'm going to do is, what I need to do is to create 5 char variables. So I'm going to create 5 char variables, then I'm going to let my user input his letters inside those 5 char variables, and then I'm going to write out encoded words. So I'm going to convert all of these letters in ASCII codes, and then I'm going to write that out to my user. So I'm going to, in a certain way, cipher his word. So I'm going to say here char C1, char C2, and then char C3. And I won't stop here for a moment. I want to explain one thing. When we first were talking about creating variables, we said that this is the way of creating variables. So you say the type of your variable, so char in this case, and then you say what name you are going to give to your variable. So in this case, this is our C1, C2, C3. So this way of creating variables here, it is correct, but it is a bit tedious for this current situation. There is another way of creating more than one variable, and I'm going to demonstrate that now. So what you can say also, what you can do is char C1, C2, C3, C4, and C5, and all separated with this comma sign. So you can create more than one variable in one line like this, but only if all of those variables are of the same type. And in this situation, they are. So all of these variables are of type char. So I've now created 5 variables of type char. And another thing that I want to mention is that in upcoming videos, we are going to learn how we can let our user decide how many characters, how many values he wants to enter during the execution of our program. So now we have hard-coded these 5 values, but we are going to learn more in the following courses. And also another thing is that also in C++, there are a lot of solutions that you can use already made so that you can enter whole words or sentences, so you don't have to enter your word letter by letter, so you don't have to create variable for each letter that you want to enter. But what I'm trying to explain here and what we want to understand here is how it really works in the background, so how it works inside. You have to understand that, and I believe that that will give you a great advantage over those programmers that just know how to use something rather than how to make that something by themselves and then use it. So I have here created 5 variables, and each one to hold a character that we will enter, and let's enter them now. So what I'm going to say is cout, enter 5 letters, and then I'm going to say cin, and I'm going to put all my variables here. So C1, C2, C3, C4, and C5. So if you can see here, I have entered all of my 5 variables in a single line. So you can do this. You can bind these operators like this so that you can enter more than one variable in a single line. The same way that you can bind your cout operator so that you can write out more than just one string. So now what we are left to do is we have to write out our ASCII message. So So what I'm going to say is cout ASCII message, and then I'm going to put int C1. Let me write that out really quickly. So I have written this message here, and what I have said is console output ASCII message, and then I have combined these cout operators so that I can write more than one variable in a single line, so in a single command actually. So I have said give me my int code of my C1, so give me my ASCII code of my C1 variable, and then put a blank space, and then give me my ASCII code of my C2 and also C3, 4, and 5. And I have also used these blank spaces because I don't want to write just a single number in a single line, because I want to know where my first character ends and where my second character begins. That's why I'm going to separate those codes with an empty space. And also there's another thing that I want to mention, and it is that when you want to convert your variable, so the value that you're holding in your variable, and when you use your casting operator on that, you don't put your variable in a single quotation marks, you just put the name of your variable, like this example here. So if I run my program now, you see that I get my message, so enter 5 letters, and I'm going to enter hello, and you see now that I have this output ASCII message is 104, 101, so 108 and 108, so that is our letter L. You see that it has the same code, and now I have gotten this ASCII message which is our ciphered word. And also there is one thing that I want you to keep in mind, and that is that this program here will not take into consideration your enter or your space key as a letter. So if you put your enter or your space key however much times you want, it will not treat it as a character. There are some other functions that you can use in your C++ if you want to capture your enter, for example, or your space key, such as cin.get. If you really want, you can Google that out. But at this point, we are keeping this very beginner friendly, so this will not capture your enter and your space. So let's just prove that. I'm running my program once more, and I'm going to put enters and spaces, and you see nothing is happening. And then if I enter hello once more, you see that I'm going to get the same numbers, so the same message as before. So we have built here a program that ciphers our words into ASCII, and we have built this program after just studying a little bit of coding. So imagine what you can do if you learned more. So stay tuned, make sure to subscribe to my channel, and also like this video if you want to support me in filming these videos. And also I'm going to leave to you to write a program that is going to decipher these messages from ASCII back into readable English words. So you also can put your suggestions of a code in the comments down below. And also what you can do, you can upgrade this program here that we have written so that you can put in more words, more sentences if you want, and then you can put those encoded messages in the comments, and everyone who wants to read those messages is going to have to build a program that is going to decipher those messages into readable English. So subscribe to my channel, like this video, and I'll see you in the next one. Hi guys, welcome to my channel. In today's video, I wanted to show you something that you are going to be using very often if you start on a programming path, and that is if-else statement. So what is if-else statement? Well, if statement is something that is used when you want to execute part of your code, so block of your code, conditionally, which means not always, but only in a certain situation. And then if you add else block to that else block is going to be executed otherwise. So in the situation where your if block is not executed, your else is going to be executed. So let me explain that to you in a simple example. Here I have opened my Visual Studio, and let's quickly paste an exercise that we are going to do in this tutorial. And that is this task here. So let's say that our user has to enter a number, a whole number, integer number, and then after that our program has to check whether that number is even or odd and has to write out that to our user. So how we are going to solve this problem here? Well, I'm going to explain this to you using diagrams, because I believe that that is the best way for you to understand this if you haven't used this if-else statement before. And then what we are going to do after we understand those diagrams, well, we are literally going to just translate that diagram into our C++ code. So let me open my tool. Here I have opened a tool that I'm going to be using for drawing diagrams. It's called blank diagram. You can use whatever tool you want. You can use even a paint or a pen and paper if you want. That will work as well. So here I'm going to draw the flow chart of our program, so how our program is going to be executed. And let me add first here this shape, and we are going to say that this is going to be the start of our program. So I'm going to write out start, and this indicates our main function, let's say the first line of our main function. So here our program starts. And then, as we said in our task, in our exercise, our user has to enter an integer number. And the shape that we are going to be using for that is this shape here. So let me put this shape here. And I'm going to write a text inside, and I'm going to say int number. So this shape here indicates that our user is going to enter some data in our program. And why I'm using this shape? Because it looks like this. It looks like a funnel. So you can clearly visualize that something has to enter inside that shape. So something has to be inputted in your program. So I'm going to use this shape for that. And then I'm going to say that our user has to enter an integer number, which I'm going to call number. So that variable I'm going to call number. And let's quickly add this arrow so that we know that this is the flow of our program. So after it has started, our user enters a number. And then after that, what we have to do is our program has to decide whether that number that user has entered is even number or odd number. So how we are going to do that? Well, the shape that I'm going to be using for that decision, let me find it. Well, it is this shape here, so this diamond shape. And as you can see, it says decision on it. So that's the shape that we are going to be using. And inside this shape here, I'm going to write a condition. So as you can see, our program flows this way. And after it comes here, as you can see, it has one entry point, and then it can have multiple flows that it can go to, depending on this condition that we are going to put inside here. But how we are going to decide whether that number that our user has entered is even or odd? Let me very quickly open my Visual Studio once more. It is here. And let me show you something. I want to introduce you to an operator that is called modulo, and that is used to show what is the remainder of dividing two whole numbers. So I'm going to write out cout, and then what I'm going to write out is, let's say, 2 modulo 2. So this operator here gives you the remainder of dividing these two numbers. And in this situation, we are expecting to see a 0, because 2 divided by 2 is 1, and then what remains after that operation is 0, and that what remains should be shown when we use this operator here. So if I run my program, you can see that we have gotten the expected result, so we have gotten 0 here. But let me show you what happens if I enter, for example, 5. Well, what we are going to get is 1, because 5 divided by 2 is going to be 2, and then that 1 that remains we can get using this operator, and you see that it gives us the expected result. So 5 modulo 2 is equal to 1. So this operator here is what we are going to be using to determine whether our user has entered even number or odd number, because when we get the result of modulating two numbers, when our result is 1, that means that our user has entered odd number, and if we get 0 as a result of this operation, that means that our user has entered even number. So I'm going to switch again to my diagram, and then inside this decision here, we are going to be we are going to write this condition here. So I'm going to say number modulo 2 is equal to 0. So what this means? It means that after our program has started and our user has entered the number that he wants, an integer number, we are coming to a decision point where we have to decide whether this number that he has entered after you modulate it with 0, whether it's a 0 remainder or some other remainder. So in this situation, when this is 0, we are going to execute a certain part of code. And then let me add very quickly, oh, I'm impressed. It already has this yes inside it. And then we also have this no on this other line. So in this situation where this results as an operation that is true, we are going to execute this part code of here. So I'm going to add another shape, which I cannot see. But let me use this shape once more, and I'm only going to rotate this shape like this. And I'm going to delete this text. And what we are going to be using this shape here for is to indicate that we are going to output something from our program. So it looks like this, which is clearly a visual of something is going to be outputted from it. So it is just reverse of this shape here, this funnel shape. And then inside this shape, let me write a text which is going to be, let's say that in the case that this here results as a yes, as a true operation, so our number, when it's modulated by 2, it gives a 0 remainder, we are going to say that that number is even number. So we are going to write that out to our user. And then in the situation where this here results as a no, so as an operation that is false, let me write out that here, and I'm going to say to our user, so I'm going to write out to my user that he has entered odd number. And let's just join this here like this. Okay, so our user enters a number, then we decide if that number modulated by 2 gives us 0, and if yes, we are going to write out to our user that that is an even number. If no, we are going to write out to our user that that number is odd number. And this is here really our program. What I'm going to add is, let's say that after this, our program is going to stop. So I'm going to say here that this is the end of my program, like this. And let's add one more stop of this flow here. So in both of these situations, after we have outputted to our user the result of this program, our program is going to stop. And this here really, like these two stop points, look a bit ugly to me. So what I'm going to do instead of this, I'm going to delete this. You could have as well left it like this, like it was before. But what I'm going to add one more of these diamond shapes, only this time it's going to be smaller. And I'm going to say that in this situation, it is going to be used only to say that this decision here, this decision flow is going to be joined in this point here. So like this, I'm going to say whatever has happened, whether this block of code or this block of code, it has come to an end here. And then after that, from here, I'm going to say, now my program is going to stop, like this. And this, let me remove this yes. And this is going to be the flow chart of our program. So our program starts, then our user enters integer number. Then we decide whether that number modulated by 2 is going to give us 0. If yes, we execute this. Else, we execute this. So if this is no. And then we come to this, which joins our two paths, and then we can say that our program has ended. And now let's translate this to our code. Here I have opened both my Visual Studio, and also I have exported this diagram so that we can translate it literally. We can look at this diagram and then translate that into code. So now I'm going to delete all of this that we have written inside our Visual Studio, and I'm going to look at this picture and just translate it into C++ commands. So the first this first shape here says that user is going to enter integer number inside our program, and we are going to call that variable a number. So I'm going to say int number, and then this here, this funnel shape, really translates into cin command. So user enters something inside our program, and that is cin command, and I'm going to say that user is going to enter a number. Before this, I would like to add one more information to our user so that he knows what he should enter. You could have as well put that to our diagram, but I didn't want it to make that diagram crowded, so I didn't. But what we are going to add here is cout, and then say, please enter whole number, like this. So we write out a message to our user, and after that our user, as you can see here, enters integer number. We had also to declare this int number variable because you can enter the value only for variables that you have previously declared. And then after that our program comes to this decision point. And how we can represent this decision inside our code is using if statement. So we are going to write here if, and then I'm going to put this condition here inside these parentheses. So I'm going to say if number modulo 2 equals 0. This here is operator of equal. So whether this side is equal to this side, since only one of these, so like this operator here is used to assign value to a variable. So that was already taken. So this here, two of these signs are used to check equality of these two sides. So whether this is equal to this. And then what I'm going to say, as you can see from my diagram here, we check this condition here. And if this condition is true, if this condition is yes, we are going to execute a certain block of code. And that is this code here. And how you indicate a block of code in your C++ is using these braces here, like this. So this is your block of code that is going to be executed in this yes situation. And then in case that this no here happens, so in case that this results as false, you are going to execute another block of code, and we represent that block of code using else statement. So we are going to say if this here is true, execute one block of code, else if this here is false, execute another block of code. So here, what our if makes us do? Well, it says that we only have to write out to our user that he has entered even number, because this shape here, as you can see, it looks like this, and it represents that something should be outputted from your program. So we are going to use for that our cout command. So cout, you have entered even number. So like this. And let's add end line. So in case that this here results as true, we are going to output to our user that he has entered even number. Else, if this here results as false, we are going to output to our user, let me copy this, like this, and we are going to change that only to odd. So in case that this here results as false, we are going to output you have entered odd number. So either this here is going to be executed or this here, depending on this condition. And you can see that from diagram clearly. So when your program comes to this decision point, it checks this condition, and if the answer is true or yes, it is going to execute this. Else, if the answer is no, it is going to execute this. And then after that, it really just joins these two flows, and then that is the stop point of your program. So we can write here cout, thanks, bye. Okay, let's say that is the last line of our program. I haven't put this on my diagram. Okay, so I'm going to run my program now, and as you can see, it says please enter a whole number, so this line here. And if I enter, for example, 8, it is going to come to this line here, and it is going to modulate our 8 with 2, and if the result is 0, which it is going to execute this line here and write out you have entered even number. Oh, thanks. We are missing an S here. And then it writes out thanks bye. And let me add an S here. Okay, and if I run my program again, as you can see, it asks me again to enter a number, and this time I'm going to enter 5, which we know that is an odd number. It says you have entered an odd number because it has come to this decision point here. It has tried to modulate 5 with 2, and the result of that was not 0. So it has not executed this, but it has executed this else statement, and it has written you have entered odd number, as you can see here. And then this thanks bye. Okay. So I hope that you have understood this, and if you like me to use these diagrams to explain some more code that we are going to be using, you can write that in the comments down below, and I'm going to try to use more of these diagrams because I know that some people understand it better when there is a visual representation of your code. I was one of those people when I first started learning programming, so if you find it easier to understand when I use these diagrams, I'm going to be using that. So thanks for watching this video. Make sure to like it if you find it any helpful, and also to subscribe to my channel, and I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. In this video I wanted to talk about if-else statements, but a bit more complex if-else statements so that you can get an idea on how they are used in real life. So if you're not familiar with them at all, like you have never heard of if-else statement, then you should probably first watch my first video of this subject, and I'm going to link it somewhere here, and then you can come back to this video. But if you're already familiar with the very basics of if-else statements, then this video is right for you so that you can upgrade your knowledge. So keep watching. So the problem that we are going to solve in this video is the one that students usually get on their exams a lot. And with the knowledge that you get from this video, you are going to be able to recognize and solve other problems of this type. And also, if you don't want to work with C++, this logic that I'm going to teach you today is going to be applicable in other programming languages as well. So here's the text of my problem, and it says that our user should enter the side lengths of a triangle, so A, B, and C. And after that, our program should write out whether that triangle is equilateral, isosceles, or scalene triangle. And as you already may know, equilateral triangle is the one that has all 3 sides of the same length. Isosceles triangle has 2 sides of the same length, and then scalene triangle is the one that has all 3 sides of a different length. So the way that we are going to solve this problem is we are going to really visualize the solution for this problem so that you can really understand it, and that is going to be using diagrams. The tool that I'm going to be using for drawing diagrams is called blank diagram. You can use whatever tool you prefer, even pen and paper if you want. And the first shape that I'm going to put to this diagram is going to be this circle shape here. Let's say that it is going to indicate the start position of our program. So here's where our program starts. And after our program has started, what we want is we want our user to enter side lengths of our triangle. And the shape that we are going to be using for that is this funnel shape here, so that you can clearly visualize, because of this funnel shape, that something should enter inside it, something should be inputted in your program. And what should be inputted is side lengths, so A, B, and C. And the type that I'm going to be using for these 3 variables is float. Why float? Well, because the lengths of sides of a triangle can be decimal point number or floating point number. So float. And then let's put this arrow here so that you can visualize the flow of our program. It goes like this. And then after our user has inputted the side lengths, what we should do is we should determine whether he has entered equilateral triangle, isosceles triangle, or scalene triangle. And what I'm going to do next is I'm going to use this diamond shape here which indicates decision in your program. And what I'm going to put inside this shape here is condition. The first thing that we want to check is whether our user has entered equilateral triangle. So whether these three sides are all of the same length, whether these three variables hold the same value. And let me make this a bit bigger. And inside here, I'm going to say, please check if my A is equal to my B, and also if my B is equal to my C, like this. So let me join these two. And I want to explain two things when it comes to this. First one is this operator here, this AND operator, these two ampersands. This is logical AND operator, and it is used as I'm going to just explain. So this expression here is going to result as true expression only in a situation where this here is true, and also at the same time this here is true. So in that case, this whole expression is going to result as a true operation. That is the logic behind this AND operator. And the second thing that I want to explain is following. So I have said here, please check if my A side length is equal to my B length, and also if my B side length is equal to my C side length. What you can also put here is, you can also say A, because we have determined here that these two are of the same length. So it really doesn't matter if you put here A or B, whichever you prefer. So in this situation where this results as a true operation, we are going this way. And what I'm going to do when this results as a true operation, as a yes operation, I am going to use this shape here. Let me just rotate it. I really don't see a shape that is this one, so that's why I'm using this reverse funnel shape, and I'm rotating it so that you can clearly visualize something that is being outputted from your program. Let me delete this text here and make it a bit wider, and I'm going to put text inside it. And what I want to write out in this situation here, where this results as a true operation, where this condition is fulfilled, is that our user has entered equilateral triangle because all three sides are of the same length. So let me write that out. So in case that this condition here is true, we are going to write out to our user that he has entered equilateral triangle. And then let's check the situation where this here results as a no operation. So in that case, we have to determine whether our user has entered scalene triangle or a isosceles triangle. And for that, I'm going to be using another of these diamond shapes, so another decision that we have to make. And let's put it here. And, oh no. And the next thing that we want to check is following. So I want to check, once I have determined that my user has not entered all three sides of the same length, I want to determine whether he has entered all three sides of a different length. So I'm going to put inside this shape here another condition, and I'm going to say following. So please check if my A is, if my A is not equal to my B, and also at the same time if my A is not equal to my C, and also at the same time if my B is not equal to my C, like this. So this is the next condition that we want to check, and this operator here is called not equal to operator, and it is really reversed from this equal operator. It has reversed logic. So in this condition here, what we want to check is whether my A side length is not equal to my B side length, and also at the same time whether my A side length is not equal to my C side length, and also whether my B is not equal to my C. And if this here results as a true operation, that means that all of these three side lengths are not equal. They all have the different lengths. So in that situation, we are going to go this way. And we are going to write out, let me copy this shape. And here I'm going to say, please write out to my user that he has entered a triangle that has all three different side lengths. And that is going to be our scalene triangle, like this. Okay, so in the situation where this here results as a true operation, it means that all of these three are of a different length, and we write out to our user that he has entered scalene triangle. And then the situation where this here results as a no, because we have previously determined that these three are definitely not of the same length, and then we have in this condition here determined that these three are also not of a different length. What is left is that the two of these three sides are going to be of the same length. And that is going to be the situation where we write out to our user, well, I can copy this, and we write to our user that he has entered isosceles triangle. So let me write that out. Okay. So these three are three potential endpoints of our program. So three potential solutions to our problem. And after we write out to our user this or this or this, I'm going to really put this one diamond shape just to indicate that our decision has now come to an end. We have solved this problem, and we are going to join these paths in this shape here. So I'm going to put this and this, like this. So now, after we have decided whether it's an equilateral triangle or scalene or isosceles, I can now say you can resume the execution of my program normally. So whatever I put after this shape here is going to be executed in either this case or this case or this case. And what is going to be happening after this shape here is just stop. So our program is going to stop, but you can put a lot of code here if you need to. So I'm going to say stop. And let me delete this, really, I don't need it. Okay, let's explain one more time this diagram. So after our program starts, our user should enter A, B, and C, which represent side lengths of a triangle. And I have used this float shape since those side lengths can be decimal point numbers. And after our user has entered that, we come to this decision point here. And what we want to decide here is, first thing, we want to check whether all of these three variables are of the same value. So whether he has entered three same lengths for a triangle sides. And in case that this here results as a true operation, we are going this way. And we write out to our user that he has entered equilateral triangle. And after that, we go this way, and our program stops. In the situation where this here results as a no operation, we want to check something else. So we are going this way, and we come to another decision point. And here we want to decide whether our user has entered a triangle that has all three different side lengths. So after we have checked that they are not equal, we want to check whether all of three variables are of a different value. And in case that this condition here results as a yes operation, that means that he has entered scalene triangle. But in case that this here results as a no operation, we can now clearly say that he has entered isosceles triangle, because we have checked here that these three sides are not the same, and we have checked here that these three sides are not different. So all of them are not different, and that means that two of them have to be equal. And in that situation, we go this way, and we write out to our user that he has entered isosceles triangle. And now we can go this way, and you can see that in this situation as well, our program stops. Here I have opened my flowchart and my Visual Studio so that we can just translate this diagram into our C++ code. So the first thing here is our user enters our A, B, and C side lengths. So let's declare three variables of type float, and let's call them A, B, and C. And now I'm just going to write out a message to my user so that he knows what he should enter. So let's say cout, and please enter A, and then B, and then C, like this. And then let's use our cin command so that he enters his values. Okay, let's say first thing that our user enters is going to be stored inside my A variable. After that, what he enters, please store that inside my B variable, and then the third value that he enters is going to be stored inside my C variable. So now that we have entered our side lengths of a triangle, we come here, so to a decision point, and we said that we represent this with if-else statement. So I'm going to write here if, and then inside these parentheses, I'm going to say this condition here. So please check, like this, please check if my A is equal to my B, and then also check is my B equal to my C, like this. And if this expression here results as true expression, I'm going to execute one block of code. And that block of code is going to be this one here. But if this expression here results as a false expression, okay, I am going to execute another block of code, and that block of code we represent with our else statement, like this, okay. And then let's write this yes situation. So let's write here cout equilateral triangle. So like this. Oops, you should put that not in a quotation marks. Okay, so in this situation where these three side lengths are equal, we write out to our user that he has entered equilateral triangle. But in the situation where this here results as false, we have this else block to execute. And let's find out what is inside our else block. So it is this code here. And that is another if-else statement. So this if-else statement is really nested inside this one here. So it is nested inside this else block. So here in these brackets here, we are going to put another if-else statement. So let me write out if, and then inside these parentheses, we put our condition from this decision here. So from this diamond shape here. And I'm going to write out, please check if my A is not equal to my B, and then is my A not equal to my C also, and then is my B not equal to my C. So in this condition here, we check whether all of these three variables have different values here. And if they do, if this condition results as a true expression, I'm going to write out, let me just copy this, and then we are going to adjust it. I'm going to write out that my user has entered a scalene triangle, as you can see here. So when this goes in a yes way, we write out that message. So if this results as a true, we write out that our user has entered a scalene triangle, but if this here results as a false, then we are going to write out that our user has entered isosceles triangle. And let me copy this, like this. Okay, so we have nested this if-else statement inside this else block. So this if-else statement is going to execute only in a situation where this here results as a false expression. So this code here, if you find it a bit unreadable, I want to show you one trick, so one rule that you can really follow, and that is if you have only one command under this if or else statement, you don't need to use these brackets. So you don't need to say that you are going to execute a block of code, since you are not. You are going to execute only one command. So you can really delete this here, like this. And then also here, since we have only one command, both here and here, we can delete these brackets here, like this. Okay, so now this code is a bit easier to read. Okay, now, as you can see from this diagram here, it is literally translation of this here and vice versa. So this code here is a translation of this diagram here. And what it means is when our user enters 3 values for our sides of a triangle, first we are going to check whether all of these 3 sides are equal. If they are, our program is actually going to say that our user has entered equilateral triangle. But if this here results as false, then we are going to our else block, and then inside that else block we are going to nest another if else. So we are going to check another condition. We are going to execute this if else here, and this if else here is going to check following. So it is going to say, please check if all of these 3 variables are different values. So if all 3 sides of a triangle have different lengths. And if they do, we can say that that is a scalene triangle. But if they don't, then since we have already checked that all of them are not equal, and also we have checked here that all of them are not different, we can say now that definitely 2 of these variables are equal, and that means that our user has entered isosceles triangle. And that is the program that we had here. Okay, so I hope you liked this video, and if you did, this is a strong call to subscribe to my channel and to share it with anyone else who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to another video of C++ for beginners. In this video, I wanted to talk about operators in C++, and we are going to cover the ones that are used most of the time, but I'm also going to make a separate video for certain operators that have specific use in C++. So in this video, we will talk about the ones that are used most of the time and that you really need to know and understand. And also make sure to watch the entire video because I do have some important tips to give you when it comes to this that you really need to understand and that you will find handy for your future progress in learning of programming. The first thing that I wanted to explain is what are operators. You can understand operators as special type of functions that are used to perform certain calculations on arguments or operands, and then based on those arguments and on that calculation, they give you a new value. So the first type of operators that I want to talk about are arithmetic operators. And you are probably familiar with most of these. So there is operator of adding and subtracting, multiplying, dividing, and also one more operator that you may not be familiar with, which is the modulo operator. So all of these are arithmetic operators. And let me give you an example of how these are used. So I'm going to say cout, and then let's write out the result of 5 plus 2. Now let's add one end line. Okay, so this here is the operator of adding, and then these 2 are operands or arguments, and this here is going to perform certain calculation and then write that out to my console. So if I run my program, we get the expected result, which is 7. So these really behave as you would expect them to behave in maths. But there are certain rules that are specific to programming and that I want to mention. So this operator here, operator of dividing. Let me give you a simple example. If I say cout and then 5 divided by 2, and I add end line, what do you expect to see in this line here? Write that in the comments down below. Now I'm going to run my program, and you see that the result that I've gotten from this line here is 2. But why has that happened? We know that 5 divided by 2 is 2.5. Well, there is a certain rule in programming that says that the result of dividing 2 whole numbers like this, so 5 is whole number and then 2 is also whole number, is also going to be represented as whole number. So even though the result of dividing these 2 is 2.5, that 0.5 cannot really be put inside integer variable, so it cannot be put inside integer container. So just 2 can be put here. And that 0.2 is really lost. If you want to show the real result of dividing these 2, what you have to do is you have to make one of these 2 or both of them of a different type, and that type is going to be decimal point number, so float or double. So if you put here 2.0 or you put here 5.0, then in this case, you are going to get the result represented as decimal point number. So you can use it like this, or you can make just one of these of a floating point type. So you can say also like this. And then if I run my program now, you see that now I have got the expected result, so 2.5. That is one rule that you really need to know when it comes to this division operator. And another tip that I want to show you is this operator of modulo. So how do we use this modulo operator? This example here that I've just shown you, let me return this to this situation where I've been dividing two whole numbers, and we've just seen that 5 divided by 2 is going to result as 2. And that 1 that remains, we can get that 1 really with this operator here. So if you say cout and then 5 modulo 2 at end line, this operator here is going to give you the remainder of dividing two whole numbers, which are these two. So the result of this operation is going to be that 1. So let me run my program. And you see that we have gotten that expected result. So 5 divided by 2 when it comes to whole numbers. If you're dividing whole numbers, the result is also going to be whole number. And in this situation, it's going to be 2. And then that remainder after dividing two whole numbers, you can get with this modulo operator. And the remainder after dividing 5 with 2 is 1. And you get it with this operator here. So these 5 are really arithmetic operators, and these are also called binary arithmetic operators. Why binary? Well, because they are all used with two operands. They perform their calculation on two operands. There is also another type of arithmetic operators in C++ that are used or that perform calculations on only one operand, and those are unary operators. The examples of unary operators in C++ are this operator here, which is operator of increment, and then this operator here, which is the operator of decrement. So how these are used? Let me give you an example. So let's create a variable of type int, and let's call it counter. And I'm going to assign to that variable a value of 7, for example. So how this operator of increment works is it really increases the value of your variable by 1. So if I say counter plus plus, what this operator is going to do, it's really going to add +1 to my counter variable. So 7 plus 1, it should in this line here increase value of my counter variable to 8. And let's prove that. Oops, cout counter, and then let's add one end line. Okay, if I run my program, you see that we've got expected result. So 8. We've declared a variable of type int called counter. We've given it a value of 7. And then in the next line, we applied this increment operator to it, which had increased its value +1, so 8. And then after we write out that value of that variable, we got our result. So that is how this increment operator is used. This decrement operator, so counter minus minus, this decrement operator here works reverse. So it really subtracts 1 from this variable here. And if I copy this line here and then paste it, after this line here, our counter should be decreased by 1. So the value of our counter should really again be 7. And if I run my program, oops, like this, you see that we've gotten our 7. So we've gotten the expected result. However, there are specific rules when it comes to these increment and decrement operators. And let me explain what I mean on another example. So I'm going to create another variable of type int, call it counter2, and let's assign it also a value of 7. And what I want to do with this variable here is I want to write out its value, but I want to write out and increment its value in a single line. So I want to do this. So cout counter 2 plus plus. And I'm missing this redirection sign here. Okay, so what are you expecting to see in this line here? We've seen that this line here has resulted with 8, and this line here should also result in 8. Let's see. Okay, run my program. And it didn't. In this line here, we have written out 7, but why has that happened? Well, this operator here is increment operator, but it is really post increment operator. And what that means is that whatever operation needs to be performed on this variable is going to happen first, and then this increment operation is going to happen. So that is called post increment. Another type of increment is pre-increment, and it is used like this. Okay, and this pre-increment means that whatever operation needs to happen on this variable here, first I'm going to increment it, and then I'm going to perform that operation. So if I run my program now, you see that we now get our 8, same as here. And that is because we have used this pre-increment, which first has increased our variable, and then our variable is written out. Okay, and the same is applied for decrement operator. So for example, if I say cout counter 2 minus minus, and then, oh my God, again. Okay, and then if I run my program, you see that we have gotten the same value for this line and this line, so 8. And why that has happened is because we have used this post decrement here. So first our variable has been written out, and after that the value of that variable has been decreased. So just to prove that, I'm going to say one more time cout, and then counter 2 without any increment or decrement, just to prove that the value of this variable has been decremented after it has been written out. So if I run my program again, you see that this line here has resulted in 8, and then this line here has resulted in 7. Okay. So you see that our console now is full of some random numbers, and it's really making it hard to read. So what I want to do is I want to clear out my console, but without deleting this code here. So how I'm going to do that? I'm going to use a command that is called system, and then inside these parentheses I'm going to say cls, which really is going to clear my screen. So if I run my program, you'll see that all of our code is still here, but console has been cleared. So that's because of this command here. That's a quick tip if you need to clear your console. Another type of operators that I want to talk about are relational operators. And these are really used to compare the value of two operands, so two arguments. And relational operators in C++ are following. So we have less than, and then we have greater than, and then less than or equal to, and then greater than or equal to. Then we have just is equal to operator, and then we have not equal to. So these 6 are relational operators in C++. And how these are used, let me show you in an example. So let's say that I'm going to create a variable of type int, call it a, and let's assign it a value of 5, and also create another variable that is called b and assign it a value of 5. So now, if I say cout, and then inside these parentheses, I'm going to say, please write out if my variable a is greater than my variable b. So if my 5 is greater than this another 5. Okay, and I'm using these parentheses because I want my cout command to know that this here is one expression that first should be calculated, and then whatever this expression here results in, I'm going to write that out in my cout command. So if I run my program now, you see that we have gotten 0. And if you know about how computers work, you know that they work on zeros and ones, meaning that 0 represents false and then 1 represents true. So in this situation, we have gotten the result of false. So when I ask my computer, is my A greater than my B? So is 5 greater than 5? It says false. No, it is not. Okay. And the same is going to happen if I put here this other operator of less than, like this. But if I, for example, put less than or equal to, so this operator here, and I run my program again, you see that now we have gotten the result of 1. So that is true. That is what our computer considers as true. So our 5 is less than or equal to 5, which is correct. And even better would be if we say just is equal to, and in this situation also we are going to get true as a result, like this, because 5 is equal to 5. And then how we use this operator here is like this. So you can say, is my A not equal to my B? And your computer really hears, is my 5 not equal to my 5? And the response to that is going to be no. It is false because these two are equal. It's the same number even though it's held by two different variables. Okay, I hope you understood these relational operators. And there is also one tip that I want to give you here, and that is, you see this comma sign here. This is also operator in C++. And it is not relational operator, but it is binary operator. And how this operator is really used, because we have seen it before without knowing that it was an operator, it is used as follows. So in this line here, we have said, please create a variable of type int, call it A, and assign it value of 5. And then also, so that is the purpose of my comma, so also create another variable of type int, call it B, and assign it value of 5. So my comma in this situation is operator and separator as well. So it is pretty intuitive. So before we continue, let's add one more of these clear screen commands here. And the next type of operators that I want to talk about are logical operators. And there are 3 of those. So we have logical and then a logical or, and then also not operator. So these 3 are logical operators. And they are usually used to combine 2 or more conditions into one single condition. And I'm going to show you that on an example. And let's use for that example these variables here. Let's just change the value of our b to 8, for example. So what I want to do is I want to write out following. So is my a equal to 5? And then also is my b equal to 5? I want to write out the result of this expression here. And you see that we have used our AND operator to combine these 2 expressions. So if I run my program, you see that the result of this is false. So that is the nature of our AND operator. It really works like this. It says, please check, is my A equal to 5? Yes, it is. And then also check, is my B equal to 5? No, it is not. It is 8. So then this operator says, okay, whatever, then this whole expression is going to be false. Because this operator here needs both of its operands, so this here, and then this here also, both of these need to be true in order for this whole expression to result as true expression. That's the nature of this AND operator. However, there is one more forgiving operator in C++, and that is this operator here. So this OR operator. And if I paste that here instead of our AND operator, and I run my program again, you see that this time we got different result. Now we have true, and that is the nature of our OR operator. So it says, please check if this is true or this here is true. Whichever of these results as true, then I'm going to be true expression. Only in the situation where this here is false and also this here is false, I'm going to result as false. In any other situation, this here is going to be true. So that is the nature of OR operator. And then we have also this not operator, which really negates whatever comes after it. So if I put it here, for example, you see that you've seen that previously this expression here has resulted as true expression. Now that I negate it, we are going to get false. So that is our not operator here. Okay. And there is also one more thing that I want to explain when it comes to the precedence of these operators, which means priority of these operators. So which operator types have the biggest priority? The biggest priority have arithmetic operators. After that come these relational operators, and then the smallest priority have these logical operators. So let me show you that on an example. Let's just comment this very quickly, and let's add another line, but the previous one that we had. So this here, like this, that is the operation that has resulted as false. So is my A equal to 5, and then is my B also equal to 5? And this has resulted as false. But if we, for example, say it like this, what do you think that this expression here is going to write out? So if I run it, you see that we have gotten 1. Why is that so? Well, as I've said, the biggest priority have arithmetic operators. So this expression here is going to be executed first. So 5 plus 3. After that, priority have these relational operators. So this operator here and this operator here. So after that comes logical operation. So this expression here is going to be really, is my A equal to 5? Yes, it is. And then also, is my B equal to 8? And the answer to that is also yes. So now both of these operands are true, and our AND operator is satisfied now, and it's going to result as true operation, this whole expression. So you need to remember that the biggest priority have arithmetic operators, so these here, binary and unary arithmetic operators. After that, we have our relational operators, and then the least priority have these logical operators here. Let's add one more of these clear screen commands before we talk about the last type of operators that I want to cover in this video, and those are operators of assignment, and there are 6 of those, and they are as follows. So operator that just assigns value, and then operator that adds and assigns, and then operator that subtracts and assigns, multiplies and assigns, divides and assigns, and modulates and assigns. So these 6 are operators of assignment. And let me show you how they work. So first I'm going to create a variable of type int, and let's call it x, and let's assign it a value of, for example, 5. Okay, so this here is example of this assignment operator here. And that is how it works. It assigns whatever is on the right to your variable on the left. So that is the direction of association. It really says whatever is on my right side, please assign that to my left side. And let me show you now how these here work, because they're a bit more complex. So if I say, for example, x plus equals 7, like this, what this expression here is going to do? Well, let me write out one more expression, and that is x equal to x plus 7. So this expression here and this expression here are just the same. This is just shorter way to write this here. And what this here does, well, this is expression that is not valid in mathematics, but in programming it is. And it does following. So it says, please, whatever is on my right side, assign that to my left side. And why it does that? Well, because this arithmetic operator here has priority over this assignment operator. So if you remember when we were talking about priority, these assignment operators have the lowest priority of all. So whatever is on my right side, that is x plus 7, is going to be assigned to my x variable. So 5 plus 7 is going to be equal to 12, and then that is going to be assigned to your x variable in this line here. And this expression here is really short way to write this here. Okay, so I'm going to comment this out, and if I write the value of my x now, we are expecting to see 12, and it is the result that we have gotten. So this x plus equals 7 is just going to do this, so this expression here. So it's going to add to my x this number here. And the same applies to these operators here. So this one that subtracts and then assigns or multiplies and assigns, divides and modulates. So if you say, for example, x minus equal to 7, then that is really going to result as x is equal to x minus 7. And then that right side is going to be assigned to your left variable, because arithmetic operators have priority over these operators of assignment. And if I run my program again, it really sees 5 minus 7, and that is minus 2. So I hope that you have understood these examples that I've just given you, and I'm also going to include some more examples at the end of this video, but tricky ones, so that you can be sure that you have really understood these operators in C++, because they are used very often and you have to understand them in order to continue with your progress on a programming path. So make sure to do those examples on your own, and if you come across any problems or you have any questions that are related to this video, write those in the comments down below and I'm going to answer them. I'm going to help you. And if you liked this video, make sure to subscribe to my channel and also click the bell icon so that you are first to be notified when I publish my next video. And I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. In this video, I wanted to answer a question that I recently got, and that is a question that is often asked on job interviews, and also students get it on their exams. And that is a question on how you can swap the value of two variables. I'm going to give you two ways to solve this problem, but let me just explain what I mean by this. So I'm going to copy the text of this problem here, like this, and let me say that I have one variable which is going to be called a, and that variable is going to hold value of 20, let's say, and then I have another variable which is going to be called b, and that variable holds value of 10. And now I need to switch the value, so to swap the value of these two variables. I want my a to hold whatever my b is holding, and then I want my b to hold whatever my a is holding. So how we are going to do that? For the first explanation, I will need something, so let me get it. So here I have two glasses, and inside this left glass I have my green juice, and then inside this glass I have just plain water. And the question that we have in our Visual Studio is equivalent to a question how we can swap the content of these two glasses. And to solve that problem, I'm going to use another glass, so a temporary glass, and that is this one here. And I'm sorry guys, I know this is not a glass, it's a shaker, but it will do for this explanation. So what I'm going to do is I'm going to take this glass, this variable, and I'm going to put its content inside this third glass, this temporary glass. Okay, and then when I have saved the value of this glass inside this temporary glass, what I can do is I can put my green juice, so the content of this glass, inside here. Okay, this is a bit more complex in real life than in programming. So once you do that, you have saved the value of this glass here, so the content of this glass here inside this glass. And now what we are left to do is just to put whatever our temp variable, our temp glass was holding inside this glass here. And now we have successfully accomplished to solve this problem. So we have switched the content of these two glasses. And let's just translate this into our code. Now that I have explained the algorithm to solve this problem, we are just going to translate that algorithm into C++ code. So the first thing that I'm going to do is I'm going to create a variable, a temporary variable, which I'm going to call temp, and inside that temp variable I'm going to put whatever my a is holding. So I'm going to say that my temp holds now whatever is inside my a variable. And since we have our a variable free now to hold something else, I'm going to put my b value inside my a. So now my a is going to hold whatever my b is holding. And now that we have saved the value of our b inside our a variable, we can put inside our b whatever our temp variable is holding. So that is the value that previously was inside our a variable. And this here is really the algorithm to solve this problem using a third variable. And let's just quickly add a cout so that we can see what we have done. So our a is equal to a, and then our b is equal to our b. And let's add end line like this. And I'm going to add just a comma sign here. Okay, and if I run the program, you see now that here we have a is equal to 20 and b is equal to 10, and now we have successfully swapped the value of these two variables. So now my a is holding 10, and then my b is holding 20, which previously was inside my a variable. And this is a solution for our problem using a third variable. But this question is often asked in another way, and that is how you can swap the value of two variables without using a third variable. And now I'm going to explain that. So let me very quickly delete this until here. Okay. And in order to solve this problem without using third variable, you will have to think in a more mathematical way. And the solution for this is going to be the following. So the first thing that I'm going to do is I'm going to say, okay, let's say that my a variable is going to hold whatever my a is holding, and I'm going to add whatever my b is holding also. And this expression here would be really incorrect in any mathematics, but in programming this is a valid expression. And it means this here, whatever this expression results in, I'm going to assign that to my a variable. And this here is whatever my a is holding plus whatever my b is holding. Assign that to a. So that is going to be a, so 20, plus b, 10. That is equal to 30. So now in this line here, my a is going to hold the value of 30. And then in the next line, let's say now my b is going to hold whatever my a is holding, and then subtract whatever my b is holding from that. So in this line here, I'm going to say store inside my b the result of this expression here. And this expression will result in following. A, so 30, minus b, minus 10. That is going to be 30 minus 10, 20. So in this line here, my b is going to hold the value of 20. And then what we are left to do is just to put the correct value inside our a, and that is going to be a equal to a minus b. This means whatever my a is holding at this very moment, and that is 30, minus whatever my b is holding at this very moment, and that is 20. And guys, 30 minus 20 is going to result in 10, and our a is going to get the value of 10 in this line here. So now if I write out, cout a is equal to a, and let's add end line, and then cout b is equal to b. And if I run my program, you see that I'm going to get the expected result. So my a now is holding whatever my b was holding, so 10, and then my b is holding this value that previously was inside our a variable here. So we have solved this problem in two ways, so with or without a third variable. So if you found this video helpful, make sure to like it and to subscribe to my channel. And also any questions that you have, leave those in the comments down below and share this video with anyone who'd like to learn programming. And I'm going to see you in my next video. And also, guys, one question for you. If you have any recipes, any algorithms on how you can make green juice taste and smell good, please make sure to write those in the comments down below. Bye. Hi guys, welcome to my channel. Welcome to another video of C++ for beginners. I just got an idea of a simple and fun program that I can show you how you can build. And since I'm a bit of a fitness enthusiast myself, if you haven't noticed, I wanted to show you how you can build your own body mass index calculator. So stay tuned, make sure to subscribe, and let's build our own BMI calculator. Okay, so here's the text of my task, and what we are going to build is BMI calculator. So first I want to explain what is BMI calculator. It is body mass index calculator that is going to tell you whether you are underweight or normal weight or you are overweight, depending on your weight and your height. And here I'm going to use weight in kilograms and then height in meters. So if someone else wants to adjust this program so that it can work with pounds, feet, and inches, you can write out that code in the comments down below, and the first one that gets it right, I'm going to pin that comment so that everyone else can use it and see it. Okay, so we are going to use this formula here, which is used to calculating your BMI in metric system. So another thing that I want to mention is these three categories here. There are also some more categories that you can really calculate whether you are extremely underweight or you are extremely overweight, but these three should be enough for us to do now, and these three I'm going to cover in this code. Another disclaimer that I want to make is that this BMI calculator probably should not be used by people that have huge amounts of muscle, so professional bodybuilders, because even though they have muscle, that muscle is still weight. So even though they are not overweight, they will fall in a category of overweight because their BMI is going to be higher. But for most of us that don't have a lot of muscle or are leading normal lives, training a couple of times a week, maybe this is going to be completely okay. So let's build our program now. So here is our tool that we are going to use to draw this diagram. So lucid chart, and let's really develop the algorithm for solving this problem, and then we are going to translate that diagram, that algorithm, into C++ code. So as you may already know, first thing that I'm going to put here is this shape here that is going to indicate the start position of my program, this circle shape here. And after that, we really need two things from our user, so two things that he should enter, and those are his height and his weight. So let's use this funnel shape here that is going to indicate something entering in your program, so visual representation. That's why I'm using that funnel shape. And inside here, I'm going to put two things that my user needs to enter. And those two things are these two things here. So his weight, and he should enter his weight in kilograms, and also his height, and let's say that he should enter his height in meters. So I'm going to use metric system for this problem. Okay, and let's indicate the flow of our program. It should flow like this. And after our user has entered his weight and his height, there is a simple calculation that our program needs to perform. And that calculation is going to be a process for our program. So the shape that I'm going to use for that is this shape here. So this shape that says process on it. And what our program should process, what our program should calculate, is it should calculate BMI. So I'm going to put here BMI is equal to, and then I'm going to put this formula here that is used to calculate BMI. Okay, so it's weight represented in kilograms divided by height to the power of 2. So I'm going to multiply my height with height. Okay, and this is really the calculation of our BMI. And now, after our program has calculated this BMI, what we are left to do is we should, depending on this BMI, really write out to our user whether he's underweight or overweight or of a normal weight. So we should make a decision depending on this BMI. And for that decision, we are using this decision shape, so this diamond shape. And inside this diamond shape, I'm going to put a condition. And that condition is going to be, let's first check whether my BMI is lower than 18.5, like this. And in this situation where our user's BMI is lower than 18.5, so when this condition here results as yes, I am going to write out something to my user. And let me find a shape. Okay, let's rotate this shape and delete is text. Okay, and what I want to write out to my user, I can make this smaller. What I want to write out to my user in the situation where his BMI is lower than 18.5 is I want to write out that he is really underweight. So let's put text inside here and let's write out that he is underweight. So that is going to happen in this situation. Oh my God. That is going to happen in this situation here. Let me just, okay, now it's okay. So in this situation where his BMI is lower than 18.5, we are going to write out that he is underweight. But in the situation where his BMI is not lower than 18.5, we have to check something else. And let's check. So let's add another of these diamond shapes. Where is it? Here. Okay, and let's now check whether his BMI is higher than 25. So I'm going to write out BMI greater than 25. Okay, and that is going to happen in the case that this here results as no. And in the situation where user's BMI is higher than 25, that really means that our user is overweight. So we are going to write out, okay, so we are really going to write out a message to our user. So let's copy this shape here, which we are using to write out a message to our user. So this reversed funnel shape that represents something leaving your program, something being outputted from your program. So in the case where this calculation here results as true, we are going to write out to our user that he is overweight, like this. Okay, and let's really adjust this. Now it looks a bit more presentable. Okay, so first we have checked whether his BMI is lower than 18.5. If yes, we have written out underweight. If no, we have to check whether his BMI is greater than 25, and if it is, it means that he is overweight. But in the situation where this here results as a no, that means that our user's BMI is not lower than 18.5, nor it is greater than 25. So that means that his BMI is really somewhere in between, so between 18.5 and 25, and that is a normal BMI. So that is our last possible situation where we are going to write out to our user that he has a normal weight. So let's write out normal weight. Okay. So after we have covered these three cases, let's just join our flows into one. So I'm looking for this shape here, and I'm going to make it smaller, delete this text from it, and I'm really just going to join these flows inside this shape here. Let's just try to move this here. I'm going to delete it, and let's say that I'm going to, oh no. Okay guys, I had huge problems trying to adjust some arrows, so I had to rewrite this whole diagram, and I believe that I made it a bit prettier. So here we were explaining that in the case that our user has BMI lower than 18.5, we are going to write out this message to him. In the case that his BMI is not lower than 18.5, we are going to check whether it is greater than 25, and If yes, we are going to write out that he's overweight. If no, we are going to write out that he's of normal weight. And in each of these three cases, we are coming here to this diamond shape here, which is just going to join these three potential situations. And after this diamond shape here, we are going to write out to our user what his BMI really is, because I really want my user to know if he's, for example, in this situation here or in this situation here, I want him to know whether his BMI is, let's say, 18.4, so he's not that extremely underweight, but he's just a little bit underweight. Or in this situation here, I want him to know whether his BMI is 25.5, so he's just a little bit overweight, or his BMI is really 35, let's say. That's why I want to write out my BMI to my user, his BMI to my user, okay? So, and then we just really stop our program. So now I'm going to copy this diagram and put it next to my Visual Studio so that we can really translate this diagram here into our code. So here I have put this diagram and then also my Visual Studio. And let's now translate this diagram. Let's translate this algorithm into code, because this here really is an algorithm explanation on how to solve a certain problem. So the first thing that needs to happen is our user should enter his weight and his height. And for that to happen, I first need to declare variables for weight and height. And for that, I'm going to use type float, because his weight and height can be decimal point number. So I'm going to say float, and then I'm going to say weight and height. Okay, like this. And after that, let's put a message out to our user so that he knows that he should enter his weight and height. So I'm going to say cout weight, and let's put that he should enter his weight in kilograms, and then also height, but he should enter his height in meters, like this, so that he knows which system he should use. Okay, after we have written out this message here, what I need to do is I need to use my cin command so that I can allow my user to enter weight and height. And I'm going to say, first thing that my user enters, that's going to be stored inside my weight variable. And then after that, the second value that my user enters is going to be my height. So store that in a height variable, like this. Okay, and after we have entered weight and height, next thing that needs to happen is we need to do this formula here and really calculate our BMI. And in order to store this result, the result of this expression in our BMI, we need a variable for that, and that variable is obviously going to be called BMI. So let's add here, in this line here, let's add BMI. So I'm going to declare another variable, and that variable I'm going to use now, and I'm going to say that my BMI is going to be used as follows. So I'm going to use this formula here, which is our weight divided by our height to the power of 2. For now, I'm going to use it like this. Okay, and in this line here, we have really calculated our BMI, so this code here. And now, after we have calculated our BMI, what we should do is we should really check what is the value of that BMI. And for that, we are using this shape here, which really translates into if-else case. So first I'm going to say if, and then the first thing that I want to check is if my user's BMI is lower than 18.5, like this. And in this situation where his BMI is lower than 18.5, I'm going to execute one line of code, so that's why I don't need to put these brackets. So I'm going to delete them because I just want to execute one line of code, and that line of code is going to be indented here so that it is easier to read. And that line of code is really going to be a message that I want to write out to my user, and that message is going to be that my user is underweight, unfortunately. Okay, and let's add one end line like this. Okay, this is in the situation where his BMI is lower than 18.5. In a situation where his BMI is not lower than 18.5, we are going to execute something else. So that something else we represent with else statement. and I'm going to put that else statement. And what is happening in that else case? It is happening another if else. So here we have a situation where we need to check something else. So here I'm going to put else if. So if this here results as no, please then check something else. And for that we use this else if statement. So I'm going to say else if, please check if my BMI is greater than 25 then. So in this situation, we also want to execute one line of code. And that line of code is going to be to write out to my user that his BMI is greater than 25, which means that he is overweight. So let me copy this message here. And we are just going to adjust it. So I'm just going to say, you are overweight, like this. Okay, so if his BMI is less than 18.5, I'm going to write out that he's underweight. Else, if his BMI is not lower than 18.5, I'm going to check whether his BMI is greater than 25. If yes, I'm going to write out that he's overweight. If no, we are also going to execute something else. And that is this situation here. So in this case, he has a normal weight. So let me again copy this message here. And let's really put here a normal weight like this. Okay, so in this situation where his BMI is not lower than 18.5, nor it's greater than 25, we are going to write out to our user that he has a normal weight. And with this here, with this code here, we have really covered this part of diagram here. Okay, and then after this code here executes, we really want to write out our BMI to the user. So we have to translate this shape here, which really translates into our cout command. And we want to write out your BMI is, and then let's write out BMI like this. Okay, and this line of code, as you may already see from our diagram, is going to execute in either this case or this case or this case, because after we have finished with this decision part, we have executed only this part of code or this part of code or this part of code here. So whichever of these three has been executed, after this code here, we are going to execute this line here in either this situation or this situation or this situation. And that is going to be writing out to my user what his BMI really is. And that is the last thing that we need to put. So the last part of our code. And now if I run my program, okay, it asks me to enter my weight and my height. And my weight is, I believe, 66 kilograms, I think. And then my height is 1.75. So let's press enter. Oh no, I'm overweight. How my BMI is 66? Okay guys, for a moment I thought that I am overweight, but I am not definitely this 66 BMI overweight. So that means that we have a bug. So where are you, sneaky little buggy bug? Well, if you can see where our bug is, then write that in the comments down below. And I already see where potentially our bug could be. So this formula here, it should really go like this. So we should divide our weight with our height to the power of 2, which means that we should put parentheses here, like this. And that is this calculation here. So in this situation, our weight is going to be divided with our height, and after that, that number is going to be multiplied with our height. So we are going to get larger BMI than we should really. So we should put this code here in parentheses. So that was the first bug that really happened in these tutorials. Okay, I'm going to leave this part. I'm not going to edit it out. Okay, and now if I enter my weight, let's see, 66, and then my height 1.75. Okay, So I am 21.5. That is my BMI, and I am of a normal weight. So we have really built our BMI calculator, and this is the formula that you should use for a metric system. And if someone else wants to rewrite this program for pounds and inches and feet, you can write that in the comments down below. And as I said, I'm going to pin that comment up so that everyone can see it, if you of course get it right. I hope you liked this video. If you did, make sure to write it in the comments down below, and I'm going to put more videos like this. And also subscribe to my channel and click the bell icon so that you are first to be notified when I publish a new video. Share this video with anyone who would like to learn programming, or also with fitness people that would just like to use this program. And if you don't know how you can run this program without using Visual Studio, I'm going to link my first video here. And at the end of that video, I'm explaining how you can run the program from Windows, and that should give you an idea on how you can really share your applications with other people. So make sure to subscribe, like, leave a comment, share, whatever you want, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I wanted to explain the concept of ternary operator, also known as conditional operator, and also some people call it shorter version of if-else statement. It is an important concept that you are definitely going to come across in your programming career, and you should understand it. And I'm going to explain this concept through building fun and simple program that is going to be a guessing game. So let's explain the rules of this game. We need to have two users, and our first user, which I'm going to call host user, has to enter a number. After that, we have to delete that number from our console so that our second user cannot see it. And then after that, our second user, which I'm going to call guest user, has to enter his guess so that he can guess what number our first user has entered. So this way we can really make a fun program and learn an important concept at the same time. And at the end of this video, I'm going to give you an idea or multiple ideas how you can really upgrade this program on your own. So make sure to watch the entire video. Now that we have explained the rules of this game, let's start building our program. And the first thing that we need to do is create two variables. Since we said that our user is going to be guessing numbers, those two variables are going to be definitely a number type. And let's say that that type is going to be integer, so integer numbers. And we need two variables. The first one is going to hold our first user number, so our host user number, and then our second variable is going to hold the number that our guest user enters. So let's call those two host user number, like this, and then the second one let's call guest user number, like this. Okay, and now after we have created these two variables, the next thing that we need to do is let's write out a message to our host user so that he knows that he should enter a number. So let's say cout, and let's just say host, like this, so that our host user really knows that he should enter a number. And I'm going to accept that number in my console using the cin command, and I'm going to store that number inside our host user number variable. So with this line here, we have entered our host user number. And what we have said at the beginning of this video is that after our host user enters the number, we really need to delete that number from our console so that our second user is not able to see it. And the command that I'm going to use for that is going to be this command here. So I'm going to say system, and then I'm going to say cls, which is really going to clear our console, so clear our screen. And now if I run my program, let's see how far we have made this program. Here we have this line, this seventh line, which says host user, and it expects our host user to enter a number. So I'm going to say, for example, 7. And then after I press enter, this number here really is deleted. So our console has been cleared. And now after this, we need to ask our guest user to guess the number that our host user has entered. So I'm going to stop the program, and next we need to write out a message to our guest user. So I'm going to say guest, like this. And after that, we need to accept what our guest user enters inside our guest user variable. So I'm going to copy this line here, like this. And instead of accepting that value inside host user number, I'm just going to change this to guest user number. And after this part here, we really have both accepted our host user number and our guest user number. And now we need to compare these two and see whether our guest user has guessed correctly our host user's number. So how we can do that, if you are familiar with if-else statements, and I'm going to link that video here, and if you are familiar with them, that is really one way to solve this problem. So you can solve this problem with if-else statements, and I'm going to do that, and then we are going to really convert that if-else statement into a ternary operator. So how we can solve this with if-else statements? Well, it is quite simple solution. So we have to say if, and then inside these parentheses, I'm going to really compare these two numbers. So host user number and guest user number. So I'm going to say host user number is equal to guest user number, like this. And then if this here results as true, so if these two numbers are the same, we can write out a message to our user, and that message is going to be, let's say, correct, like this. So our user has guessed correctly. But in a situation where this here results as false, we can use our else statement. And in this else situation, let's write out a different message to our user. So let's say cout, and then inside these quotation marks, let's say failed, like this. So that in the case where these two are the same number, we can write out to our user that he has guessed correctly, and then in a situation where these two are not the same, we can write out to our user that he has failed in guessing. So if I run my program now, you see that it expects our host user to enter a number, and I'm going in this situation to take the role of both host and guest user. So I'm going to enter 7, for example, and then you see that that 7 number has been deleted from our console because of this command here. And now our program expects our guest user to enter his number. And I even forgot what number I entered. So let's say that our host user has entered, for example, 11. And you see that our program says you have failed, so you haven't guessed correctly. And one more time, let's enter for our host user number 5, for example, and then let's say that our guest user also says number 5, and our program says you have guessed correctly. So this is one potential solution for this problem, but I wanted to show you how you can solve this problem using ternary operator. And now I'm going to comment this code here, like this. So this is a comment for multiple lines of code. And let's really translate this part of code here into a ternary operator, like this. Okay, so how does the ternary operator work? Well, it is the only operator that takes 3 operands or works on 3 operands. And the first operand is going to be a condition. So I'm going to copy this condition here, which is our host user number equal to our guest user number? So that is going to be the first operand. And after that first operand, we need to put this question mark. And then after this question mark, we have the following behavior. If this expression here, so if this condition here is true, we are going to execute one line of code, or actually one part of code, and that is going to be this line here. But in the situation where this here results as false, we are going to execute whatever we put after this column sign. So that is going to be our cout failed, like this. And this is really the syntax for our ternary operator, and as you can see, it really is a shorter form of if-else statement. So this line of code really means, please check this condition here, And if this condition here results as true, execute this part of code here. But if this code here results as false, please execute whatever I put after my column sign. So that is going to be our cout failed. And now if I run the program, it asks again for our host user to enter the number. Let's enter number 9, for example. And then our guest user has to guess the number. So let's enter, for example, number 3. And you can see that our program says to our guest user that he has failed in guessing. So there are a couple of ways in which you can really upgrade this program, and I'm going to give you a few ideas. And the first one is, for example, you don't have to use int type here. So you can use different data type. You can guess characters, or you can guess even strings if you know how to. And if some of you want to play with that and try that on their own and you get it right, make sure to paste that code in the comments down below, and I'm going to check it. And if you get it right, I'm going to pin that comment up so that everyone else can see it. So that would be one way of upgrading this program. Another way to upgrade this program is to make it easier to your guest user. And how do I mean easier? Well, you can really limit your host user to enter a number that is going to be in a certain interval. For example, you can say to your host user that he can enter only a number that is going to be between, let's say, 1 and 15 or 50. It depends on how difficult you want to make it to your guest user. And that will be one way also of upgrading this program. And another, and the best way of upgrading this program, is going to be when we learn loops. And when we do that, I'm going to link the video here. And how you can upgrade this program using loops. Well, you can give your guest user multiple attempts. So you can say, for example, let my guest user guess 3 times or 5 times before I say game over, you have failed. Okay. So I hope that you have liked this video, and if you did, make sure to subscribe to my channel, share it with your friends and with other people that would like to learn programming, and I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. Welcome to another C++ for Beginners tutorial. And I'm really excited for making this video because this video is going to be a milestone. And in this video, I'm going to show you how you can build your own calculator application. So if you have watched my previous videos and you are also watching this one and you build this application together with me, you should really feel proud of yourself because you have made a great progress. So let's build that application now. Here I have opened my Visual Studio, and let's very quickly explain what we want to do before we start write code. So I want my user to enter 2 numbers and also operation sign, and then depending on those 2 numbers and that operation, we want to calculate the result and then write that result to our user. So the first thing that we need to do is we need to declare variables that are going to hold those numbers and that operation sign. And since we want our user to be able to enter decimal point numbers, so not only integers, but decimal point numbers as well, we are going to declare variables that can hold decimal point numbers, and those can be float and double. So let's declare float variable, for example, and let's call it num1, which is going to hold our first number, and also another one, which is going to be called number2 and hold our second number. And after we have declared these 2, let's also declare a variable that is going to hold our operation sign. And since that is a character, we need to use a character type for that variable. So let's say char, and let's call that variable operation, like this. Okay. And now, after we have created these 3 variables, we can really allow our user to enter his numbers and his operation. And we want to do that in the following order. So we want to say cin, and then first our user has to enter the first number, and then after that we want our user to enter the operation sign. So let's say operation, like this, and after that our user has to enter the second number. And this window here, guys, this is called IntelliSense, and it really makes your code writing easier. So you can navigate this list here using your arrows, and then you can also use tab key so that it finishes your variable name for you if you want that. Okay, So now we have entered our first number, our operation, and then our second number as well, like this. And another thing that I want to write out to my user, because this is going to be the best calculator ever, let's write that title to our user. So let's write here, before he enters anything, a quick title. So let's say Cout, and then let's say that it's going to be called Code Beauty Calculator. You can call yours whatever you want. So like this, and let's add these here so that it looks prettier. Okay, and now if I run my program, well, you see that it really looks like this. And now we are able to enter one number. After that, we want our user to enter operation like this, and then we want to enter the second number like this. And then after we press enter, our program should really calculate the result of this operation. In this current situation, it is not really doing anything else because we haven't written code for that. Okay, so now let's solve this problem that we have here. So at this point, you should really have an idea yourself on how to solve this problem using if-else statements and also nested if-else statements. So if you're not familiar with those, I'm going to link one of my previous videos here. So make sure to watch that video as well. But in this video, I want to show you the more appropriate way for solving this particular problem. And that is going to be using switch case statement. So what is switch case statement? Well, switch case statement is, as well as if-else statement, used when you want to execute a block of code depending on a certain condition, so depending on a value of a certain variable. But switch case statement is particularly used in a situation where that variable can potentially hold a lot of different values. And if you look at our operation variable here, you should really notice that this variable can hold 6 different values. And what are those 6? Well, our user can decide to enter operation for adding, subtracting, multiplying, dividing, modulating, and then what if our user does not really want to use our application, but he wants to hack it? So if he decides that he doesn't want to enter one of these 5, but he really enters some non-valid arithmetic operation, we should also cover that case. So we should really, as programmers, predict all these 6 situations and cover all these 6 cases. I'm going to add one end line here so that my text is formatted nicely. And then let's really show how this switch case statement is used. So the first thing that I want to write is switch, like this. And then if you press tab, you see that you are getting some default syntax for this switch case. For now, I'm going to delete that, and I want to show you how you can really write that yourself. And inside these parentheses here, I want to write out the name of my variable that I want to switch through or switch on. And that is going to be my operation variable, because depending on the value of this operation variable, we are going to perform a different calculation on these 2 number variables. So I'm going to say here operation, and then in these curly brackets here, we really want to cover all our cases. So the first case, let's say that our first case is going to be a situation where our user enters minus operator. So I'm going to use these single quotes, and then inside these single quotes, I'm putting the value that our variable can potentially hold, and that is this minus operator here. And after that, I'm going to add this column sign here, like this. And then after this column sign, I really want to put out whatever code I need to execute in the case that our operation corresponds to this sign here. And what I want to execute in this case is I want to say Cout, and let's write out our first number, and then let's write out our operation, and then let's write out our second number so that our user really gets a nicely formatted text. And after that, I'm going to add this is equal to sign, And here we are going to put really our result. And that result is going to be our first number minus, because our user has entered this minus, so our first number minus our second number. So let's write out number 1 minus number 2, like this. And after we have covered this first case, we need to add one more keyword, and that is going to be break. And this break keyword is really used so that our switch case statement knows where our first case ends. So I'm saying here, whenever my operation is equal to this sign here, you are going to execute this code, and you should really stop executing that case when you come to this break statement. Okay, so this is going to be our first case. Our second case is going to be a situation where our user, let's say, enters this plus sign. And in that situation, we really want to write out to our user this text here. So the same text, we want to really write out our first number plus, in this case, our second number, and then is equal to, and then we are going to add really this calculation here. So number 1 plus number 2, like this. And in this situation as well, we want to add this break statement at the end, like this. Okay, so these are two potential cases. And now I'm going to really write out the rest of them. So I have written out these remaining cases, and in each of these cases we really want to write out to our user his first number, after that his operation, second number, and then this equal sign. And then in each of these cases we are performing adequate calculation, so we are performing that operation that our user has entered and writing that result out to our user. And after each of these cases we really need to put this break statement. And you really have to put this break statement, because if you don't, you are going to get your program to behave as you don't want it to. And as you can see in this situation here, so in this situation where we are trying to modulate two numbers, we are getting an error. And if we hover over this number here, you can see that our error says expression must have integral or unscoped enum type. What does that mean? Well, if you haven't watched my video on operators, I suggest you to do so. I'm going to link it here. And here I'm quickly going to explain what is happening. So this operation here, this modulo operation, is operation that is really going to give you a remainder after dividing two whole numbers. And since this number here and this number here are of type float, we really cannot perform this calculation on these two variables. So what we have to do is we first have to check whether this number is really an integer number, whether it's a whole number, and this number as well. And since our float can hold decimal point numbers and integers as well, we really, in certain situations only, can perform this modulating operation. And let me explain what I mean by this, that our float can hold decimal point numbers and integers as well. Well, this variable here, this number variable, can really have a value of 5.5, for example, but it can hold as well value of 5.0, which is really integer value, so it's 5 only. So now what we have to do is following. I'm going to delete this line here, and we first have to check whether both of these numbers are integers, and in that situation only we can perform this calculation. But in a situation where one of these two or both of them are not integers, we are going to write out to our user that that operation is not valid. So I'm deleting this code here. And then let's create two variables. So let's create a variable of type bool, and let's call it is num1 integer. So this variable is going to hold a value that is going to tell us is our number 1 integer value. And let's also create another variable that is going to be called is num2 int, and as well this variable is going to tell us whether our number 2 is integer. And let's develop now an algorithm so that we can know whether our number 1 or number 2 is integer number. And I'm going to ask you to write your solutions in the comments down below. So pause the video, think about it, and then write your solution. And without using any already made functions, as programmers, as engineers, you should really be able to figure out the solution on your own. So applying the knowledge that you have gotten from my previous videos, or this one, but I'm going to say from my previous videos. So pause the video and write your solution. So this question is not really a question of programming, it's more of a question of thinking in a logical way. And if you remember when we were talking about casting operators, we said that a casting operator is used to convert one data type into the other. And I'm going to link that video here. If you haven't watched it, make sure to do so. And here we are going to try to convert our floating point number, so our number 1 and our number 2, into integer data type, so into integer number. And how we are going to do that? Well, we are really going to say int, so this here is going to cast whatever we put after it into int type. And we are going to say, please try to convert my number 1 into integer. And how does this work? Well, for example, if you have a number 1 that holds value of 5.7, when you try to convert that value into integer, what it does really, it says that 5.7, so that 0.7 part really, bye-bye. I'm going to take only this 5 part, so only this whole part of a number. So in that situation, we are really going to get only 5 from this 5.7 floating point number. So what I'm going to say now is I'm going to say whatever this expression here, this casting operation results with, I'm going to really try to compare that with the initial value of my number 1 variable. So I'm going to say num1 is my converted number 1, so converted to integer, equal to number 1, like this. And how does this calculation here work? Well, as I said, for example, if you have a number 1 that holds a value of 5.0, so 5.0, this part here is really going to take this 0.0 part of a number and delete it. It's going to keep only this 5, so only this whole part of a number. And after that, we have this is equal to operator, and then we are trying to really check whether that is equal to 5.0. And the result of this is going to be true. So with this here, we have checked really whether our number is going to be equal to our floating point number. So this result here, we are going to assign this value to our is number 1 integer variable. So here I'm going to say, please assign the result of this operation to our is number 1 integer variable, like this. And let's put this expression here, so this whole expression inside these parentheses, so that we really can see that this is an expression, and the result of this expression should be assigned to this is number 1 int variable. And now we are going to do the same for our is number 2. So I'm going to say is number 2 integer, and we are going to say that that is equal to, I'm trying to convert my number 2 to int, and then compare that to my float number 2. And after this, we really can now do our algorithm to perform this modulo, where it is this modulo operation on our two numbers in the case where both of them are integers. So here I'm going to say if is my number 1 int, and then also is my number 2 int, like this. In this situation here, I'm going to perform this modulo operation. And as you can see here, I have used only these two Boolean values here in this expression. So I didn't say, please check is my number 1 int equal to true, like this. Nor I have said, please check is my number 2 equal to true, like this. Because this part here, and this part here are really redundant. And what this expression here translates in, it translates in is true equal to true, and that is really redundant. So I'm going to remove this part here and this part here, and it should work fine like this for Boolean values, so Boolean variables. And in this situation here, where both of these are integers, we really can perform this modulo operation. So in this situation here, I'm going to take this code and I'm going to copy it like this. And I'm going to say, please write out my number 1, then my operation, then my number 2 is equal to sign. And then here I'm going to put adequate calculation. So I'm going to say, take my number 1, convert it to int, and then modulate that with my number 2 that is as well converted to int, like this. Okay, so in this situation where both of these are integers, we are going to really write out the result of modulating operation to our user. Let's add empty space here and here as well. But in the situation where one of these two is not integer, or both of them are not integers, I'm going to say else. And in that situation, I'm really going to write out to my user that this operation is not valid. So let's say just not valid, like this. So in any of these two situations, whether we write out this line of code here or this line of code here, after that we are going to come here, and here we have to put our break statement, like this. So after each case comes break. And now we can really test this part of code here that we have written. So if I run my program, the first thing that I want to test is, let's say, 5.5 plus 2.2. And we get the expected result, so 7.7. Let's run our program again. And this time I want to check whether my modulo operation is working as it should, because this code here is really specific. So let's say 5 modulo 2, like this. And as well, we have gotten correct result. And let's run our program one more time. And here I really want to trick my program and try to make it to modulate two numbers that are not whole numbers. So 5.2 modulated by 2. And as well, our program works as it should. So it says not valid operation. Okay. So if you have noticed, in this current situation, I really have to run my program each time that I want to perform a calculation. And that is because we haven't learned anything about iteration or loops so far. And those videos are coming. So make sure to subscribe to my channel and also click the bell icon so that you are notified when I publish those videos. And in that situation where we learn iteration and loops, we are really going to be able to run our programs indefinitely, which means to run our calculator application until we really decide to stop it. Okay, so after we have covered these 5 cases here, there is only one situation left to cover, and that is a situation where our user enters any other sign that is not one of these 5 here. And that situation we are really going to write like this. So we are going to say default. So in the case where our user enters operation that is not going to correspond to any of these 5 signs, we are going to execute our default situation. And here we really want to write out a message to the user that is trying to hack our program. So you can write whatever message you want to the user that is trying to hack the program that you have worked so hard to build. And I'm going to put here okay. You really can write out whatever you want to that type of user, like this. So in the case where our user has not entered this, nor this, nor this, nor this, nor this, which means our user has entered some other sign, we really want to write out not valid operation. And let's test now our default case. So I'm going to run the program. and I'm going to take the role of a malicious user that is going to try to hack your application, and I'm going to say, please try to perform this calculation here. So 5Z9. Not really. You have been smart enough to predict his malicious behavior, and you have said, if you haven't put here a valid arithmetic operation, then no, I cannot help you. This is not a valid operation. And there is really one thing that you have been wondering about for the most part of this video, and that is this break statement here. So why I have said that after each case you have to put break. And now you want me to explain that, do you? Do you really? Wouldn't that be a spoiler for a situation where you decide on your own to delete this break statement here and then run your program, even though I have said not to, and you enter some calculation and you remember that I have said that you are going to get unexpected behavior, but was she lying? Was she not? And then you decide to execute this calculation and boom, here's your unexpected behavior. So what has happened here? Well, your program has really recognized that this operation here that you have entered is this minus operation. And after that, it has written out this number 1, so 7, and then operation minus, and then this number 2, 5, is equal to, and then it has calculated number 1 minus number 2, which is 7 minus 5, and that is equal to 2. And after that, it has really continued executing other cases, which means it has come to this line here, and then it has written one more time your number 1 minus number 2, so 7 minus 5 is equal to, and then it has performed this number 1 plus number 2 calculation, and 7 plus 5 is going to be equal to 12. And then it has come to this first break command, and it has stopped the execution of your switch case. So why has this happened? It has happened because you haven't put this break command here, and in that case your program is really going to be executing your cases until it comes to the first break command. And if you have noticed here, in this default situation I haven't really put any breaks. You can as well put your break statement here. You can say break here, but even if you don't, even if you didn't put your break here, and your program really tries to execute something after this line here, there is really nothing to execute, so you are not going to get a problem in this situation here. I hope that you liked this video and that you have built your own calculator application, and if you did, make sure to subscribe to my channel and click the bell icon as well. Share this video with anyone who would like to learn programming, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And in this video I wanted to deepen your knowledge of switch case. So if you're not familiar with switch case at all, if you haven't watched my previous video, you definitely have to do that. The link is going to be here. And in this video I wanted to give you some more examples that you can practice on and introduce some things that I haven't mentioned in my previous video as well. So in this video we are going to build a program that is going to require from our user to enter a year and a month as well, and then our program has to write out how many days there is in that month. So how we are going to do that, let's see. But first you have to subscribe to my channel and like this video and also share it with your friends. As I explained, there are two things that we need from our user to enter, and those are going to be month and year. So let's create two variables. Let's say year and month, like this. And now I'm going to write out the message to my user so that he knows that he should enter those two values. So year, and after that, please enter month, like this. And let's store now the values that our user enters. So the first one is going to be stored inside our year variable, and then the second one is going to be stored inside our month variable. And now we have really covered everything that we need from our user. Now our program has to check these two variables and then decide how many days there is in that month of that year. And we are going to do that using switch case statement. But there is one thing that I want to mention before we start write our switch case. And that is, you have to take in consideration that there are years that are leap years and that have one day more than the year that is not a leap year. and there is a rule for that. So I'm going to copy the rule that is going to help us to determine whether a year is a leap year or not. And that is this rule here. So any year that when modulated by 4 gives the result of 0, and at the same time that year modulated by 100 is not equal to 0, or a year, so that same year when modulated by 400 is going to give the result of 0. And this here is going to be a definition for our leap year, which means a year that has 366 days, or a February inside this year has 29 days. That's why we need this rule here. So now let's write out our switch case statement. And if you haven't watched my video on switch case statement, I am going to link it here one more time, because you really need to understand the switch case. And then you can come back to this video and deepen your knowledge on switch case. So switch, this is going to be the syntax of our switch case, but I'm going to delete this default syntax. We want to write it ourselves. So inside these parentheses here, I'm going to put the variable that we are going to switch through, and that is going to be our month variable, like this. So whichever value our user has entered for our month, we are going to cover all the potential values that our month can hold in our cases. So the first case that I want to cover is going to be the most specific one, and that is going to be our February, which means second month. So I'm going to say in the case that this month variable is equal to 2, which means that our user is requesting from us to determine how many days our February month has. We really, in this case, need to check whether that year is a leap year or not. And then if that year is a leap year, that means that our February has 29 days. And if not, which means if this condition here is not true, that means that our second month has 28 days. So I'm going to copy this expression here, this condition. And also, if you are not familiar with ternary operator, you have to watch that video, because in this video we are going to use that ternary operator. You can do it as well with if-else statement, but I want you to practice also this, because you are going to actually come across it in your programming career. So here I'm putting this condition for a leap year, and I'm going to say this question mark, and then I'm going to say if this here is true, you have to write out this line of code. So you have to write out cout, and if this condition here is true, that means that our year is a leap year, which means that our February, our second month, has 29 days. So let's say 29 days month, like this. Okay. And so that is in the situation where this here is true. And in the situation where this expression here results as false, I'm going to put here a column sign, and then I'm going to write out a different message, and that is going to be that this second month, in the case where a year is not a leap year, has actually 28 days. So after we have written this expression here, so this ternary operator, we have really written out how many days there is in our February month, and after each case I have to put break. So in this case as well, I'm going to put our break command after it. And with this example, with this case here, we have really covered our second month, which was the most specific one. Now we are left to cover the remaining months, which means ones that have 31 days and also ones that have 30 days. And here I'm going to show you something that I haven't shown you before. Let me scroll this code like this, maybe. Okay. And then there are some months that contain 30 days and some that contain 31 days. And the ones that contain 30 days are following. So I'm going to write out case like this. And then the first month that contains 30 days is going to be April, so fourth month. And then also our sixth month contains 30 days, and then also, let's see, 4th, 6th, 9th, and then November as well, like this. And here we have written out really all the months that contain 30 days. Okay, and now I'm going to, at the end, so at this case here, write out a message. Let me copy this, and I'm going to paste it, and I'm going to say 30 days month, like this. Okay, and I'm going to put break command here as well. So let me explain this part of code here, because we haven't seen this part of code here before. This break statement, what it does is when your program execution actually comes to this case here, it says, okay, my month is equal to 2, so I'm going to execute this part of code here. And then it comes to this break command. And this break command really breaks the execution of your switch, which means that when your program comes to the first break command, it is going to stop the execution of your switch there, which means that it is not going to check any more cases. And because of that, you can really here, so you can put more than 1 month. You can put all the months that have 30 days, like this. And then you can write out the same message and put one break command at the end. And how that is going to really behave inside your program, in the case where a user enters, for example, month 6, your program is going to check whether that month is equal to 2, and it's not going to be. Then it's going to check whether your month is equal to 4, not as well. And then it's going to come here and say, okay, this is 6th month that our user has entered. So please execute whatever code you find until you come to the first break. And that is going to be this here, which is empty, so nothing. And then this here, which is as well empty, so nothing. And then it comes to this code here. And that line, so this code here, contains this cout message, 30 days month. So it is going to write out this. And then it really comes to this first break command, and it breaks your switch, which means that it is not going to check any other cases that come after this break. Okay, so in any case, whether your user enters month 4 or 6 or 9 or 11, your program is going to execute this line here and then break your switch. So with this part of code here, we have really covered all months that have 30 days, and now we are left to cover the ones that have 31 days. And those are months, let's see, that is our January, and then our 3rd month, and our 5th, and our 7th month, like this. Let me scroll it a little bit more. Okay, and then we have as well case 8 and case 10, and as well our December has 31 days. So there are 7 months that have 31 days, 5 months that have 30 days, and 1 month that has 28 or 29 days. And in this line here, we are going to write out a message that is going to say 31 days month. And as well here, we have to put our break command, like this. Okay, so I am going to run my program now and show you how this program behaves. So our program is asking us to enter a year and a month. Let's say the year is going to be 2020, which is current year. And then a month is going to be, let's see, it's April, so 4th. And it says that it is a 30-day month, which is April has 30 days. And let's run our program one more time. And let's say 2020 again, and let's say that we want to check our 2nd month, and it says that February of 2020 has 29 days, which is correct as well. And there is really one more situation that I want to cover, and that is going to be a situation where our user enters a number that is not a valid month number. And that situation I'm going to cover with my default statement. So I'm going to write out default. And in this default case as well, I want to write out a message to my user like this. And inside here, I'm going to say not valid, which means that our user has not entered a valid month number. So let's run our program. And if I enter year 2020, and for a month, let's say -5, for example, you see that our program has written out not valid. Okay, so I hope that you have liked this video, and if you did, make sure to subscribe to my channel and share it with anyone who would like to learn programming as well. And today is May the 2nd. That's when I'm filming this video. I don't know when I'm going to publish it, probably in a couple of days. And currently we are a little bit over 900 people. So let's see how fast this channel can grow. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And in this video I wanted to talk about loops, more specifically about while loop. So what are loops, what are they used for, how they are used? Well, loops are used when you want to execute a block of your code multiple times while a certain condition is true, which means you give a certain condition to your loop and you say you are going to execute this block of code while this condition here is true. So however many times it is necessary. And one thing that I want to mention before we start on our example is the following. So selection, sequencing, and iteration. Those three are three main building blocks of programming languages. And when you really learn and understand those three, you should be able to solve any logical programming problem. And in this video, we are going to talk about iteration. We have already talked about sequencing and selection in my previous videos. So what is sequencing? Well, that means that your code is executed sequentially, which means one line after the other. And then selection, that would be really when you want to select one part of the code rather than the another one, which means you are going to tell to your program under a certain situation it really has to select which block of code it is going to execute. The same would be when you, for example, come to a crossroad and then you have multiple ways in front of you, but you really have to select which one you are going to take, because you cannot take all of them. And then iteration is going to be really iterating or executing multiple times a certain block of code, certain part of code, while a certain condition is true. So while a certain condition is fulfilled, you are going to execute the same block of code. So let's see our example now. So I'm going to paste the text of my program here. And this is our task. So it says that we have to write out all the numbers between 100 and 500 that are divisible by 3 and by 5. And how we are going to do that. First, I want to explain you the algorithm, so how we are going to solve this problem, and then we are going to translate that algorithm into our code. So this interval here, so this 100 to 500 interval, we are really going to iterate through all of the numbers of this interval, and we are going to do that using while loop. And then for each of those numbers, so for each value of our counter, we are going to check whether that counter value can be divided by 3 and by 5. And if yes, we will write out that value. If no, we are just going to continue to the next iteration. So as I already said, we are going to use while loop to solve this problem. And we are going to start our while loop with the counter value of 100, and in each iteration we are going to really increase the value of our counter, so 101, 102, and 3, and we are going to stop the execution of our while loop when this counter value comes from 100 to 501, which means 500 value of counter is going to be our last iteration through our loop. So the first thing that I'm going to do is I'm going to really declare a variable that is going to hold our current counter value. So I'm going to call it int counter like this. And initially, I'm going to set the value of my counter to 100. Okay, so this is our initial value of our counter. And then let's see what is the syntax of our while loop. So we write out while like this, and then in these parentheses we are going to put our condition, so how long our loop is going to execute. And then in these braces here, so in this curly brackets, we are going to put which block of code our while loop is going to execute while this condition here is fulfilled. And let's now fill these parentheses here. So as I've said, our counter has to go from 100 to 500, which means since it starts on 100 here, we have to say to our while loop that the execution of this block of code here really has to stop when our counter comes to 500 or 501. 500 is still valid value. So that we are going to say like this. So we are going to say counter like this. And then we are going to say there are two ways to write this condition. The first one is to say while our counter is less or equal to 500, or you could as well set while our counter is less than 501. So that is a valid situation while you're executing your loop. So while your counter is less than 501, or while your counter is less or equal to 500. I prefer it this way, but whichever way you put it is going to work. So now that we have put this condition here, we really can write out this code that comes in this while loop block. So what we are going to execute while this condition here is true. And that is going to be following. Inside this block of code here, we really have to check whether our current value of our counter is divisible by 3 and by 5. And if it is, we have to write out that number to our user. If no, we just need to continue to our next iteration of our loop. And how we can check whether this counter value can be divided by 3 and by 5. Well, we use modulo operation for that. If you haven't watched my video on operators, I'm going to link it here. Make sure to watch it. And here we really put the following. So we can say if, and also if you're not familiar with if statement, going to link it here. So if our counter value, so our current value of our counter, after you modulate it with 3, if the result of that is 0, that means that our number, so our counter, is divisible by 3. And we also have to check whether our counter is divisible by 5. As well, we use this modulo operation here, and we say whether our counter modulated by 5 is going to equal to 0. And if this condition here is fulfilled, we really have checked this part of our task. And if this part here is true, we have to write out that number. So in this situation here, I'm going to say cout like this, and I'm going to put inside here, let's see, we are going to write out the value of our counter like this, and we are going to write out is divisible like this. And let's put one end line after this line of code here, because we are definitely going to have multiple lines, so we want our lines to be formatted nicely. Okay, so this part of code here has really covered this divisible by 3 and 5, and write out that number if it is divisible by 3 and by 5. And there is really one very important thing that you have to keep in mind each time that you write loops, and that is the following. So you have to give your loop a way so that it can stop executing this block of code here. So under a certain condition, it really needs to leave this block of code here, because if you don't do that, you are going to end up with an infinite loop. You are really going to lock your program in an infinite loop situation. And this code here, this loop here that we have written, this is really an infinite loop. So let me prove that. I'm going to run my program, and as you can see, the console is empty. So I enter any value, enter whatever, it is not really reacting. And why has that happened? Well, your counter value starts with 100, and then it comes to your while loop, and your while loop checks this condition here. So it checks whether your 100 is less or equal to 500, and the answer to that is yes, which means that your program execution can enter this block of code here, so it can start executing your loop. And then it comes here, and it says, please check whether my counter, which is 100, is divisible by 3, and the answer is no. So this part of code here is not even going to be checked because of the nature of this AND operator. It really needs both of these operands to be true in order for this expression here to be true, because this here is not true, it's false. 100 is not divisible by 3. It is not even going to check this condition here, and this line of code here is not ever going to be written. So after that, it comes here to this closed curly brace, and then because of the nature of while loop, when it comes here, it really goes back here. And then it checks again your value of your counter, whether that is less or equal to 500, but nothing has changed. Your counter value is still 100. And then it is going to enter again here, and then really repeat that process over and over again. And your program, because of that, is going to be locked inside an infinite loop. So let me prove that really, because here we have an empty console and you cannot see what is happening in the background. So I'm going to stop my program and I'm going to write out here, let's write out cout like this. And let's write out infinite loop. And if I run my program now, as you can see, your program has really entered in an infinite loop, and it is writing out this infinite loop text for infinite number of times. So as you can see, it says infinite loop. Okay, and this execution here is not really going to stop until your program's memory is full, and then it's going to crash. So whatever code indicates that you had some code here, it is not ever going to be executed. So I'm going to stop this here, and I'm going to delete this part of code here because we don't really need it. What we need is we need to put here a certain code that is going to help our loop to really stop the execution at a certain point. And the code that we need to put here is going to be really following. It's going to be counter plus plus, like this. What this code here is going to do, in each iteration, it is going to check whether this condition here is true. If yes, it is going to write out this part of code here. And then in each iteration, it is going to really increase the value of your counter by 1, which means in your first iteration, it's going to be 100. After that, it's going to be 101, 102, 103, and it is going to really go until it comes to 500. That is going to be the last iteration of your program. And then when it comes to 501, this condition here is not going to be true anymore. And then your loop is going to check really whether 501 is less or equal to 500. And the answer to that is not going to be no. So your program is going to really stop the execution of this loop and come here and then really stop your program. So if I run the program now, I'm going to prove that. Okay, so this has been executed very fast. And as you can see, this is the result of your program. It has really written out all the numbers that are divisible by 3 and by 5. And you can check all of these numbers using your calculator if you want. So with this expression here, with this counter plus plus, we have really both iterated through all the numbers between 100 and 500, because we check our counter value here. And then also we have really given a way to our loop to stop the execution of this block of code here when this counter value comes to 501. And this is the result of our program. Okay, so I hope that you have liked this video. Any questions that you have, write those in the comments down below and I'm going to answer those. Make sure to subscribe to my channel and share it with all your friends, anyone who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. Today I want to talk about while loop, and I have already made one video on this topic, and if you haven't watched that, I'm going to link it here, so make sure to do so. And why I'm making this video, because I really believe that watching one video and doing only one example is not going to be enough for you to really master a certain concept. It wasn't for me, it is not going to be for you as well, and that is completely okay. So we are going to show you how this while loop is used on one more example. And the program that I want to build today is going to be a program that has to count how many digits the number contains. So our user is going to enter a number, and then we are going to write a program that is going to count how many digits there are in that number. So let me copy the text of that program like this, and it says count digits of a number. So let's do the first thing that we know that we have to do and that we know how to do as well. So that is going to be write out a message to our user so that he enters that number, and then also allow him to enter that number. So I'm going to say cout, and then I'm going to say number like this, and then I'm going to allow my user to enter that number. Before I can enter it, I have to really declare a variable that is going to hold that number. So here I'm going to say int number like this, and then here, after we have written out this message to our user, we are going to say cin number like this. So after our user has entered his number, we really have stored it in our number variable, and now we are going to write out the program that is going to count the number of digits of this number here. So let's first see one specific situation that can happen, and that is going to be when our user enters number 0. So this number holds a value of 0. And in that situation, I'm just going to write out a condition. So I'm going to say if my number, like this, is equal to 0, in that situation, please just write out a message to my user like this: you have entered 0. Okay, like this. And I don't need semicolon here. This looks better. So this here is a situation where our user has entered number 0. And in that case, we just want to write out that he has entered 0. And now we are left with the main problem of this task, and that is to count the digits of the number that our user has entered. And that part I'm going to put in my else block, like this. And if you are not familiar with if-else statements, make sure to watch that video. It's going to be linked here. So here in this else block, I want to write the program that is going to count the digits of a number, which is not 0 definitely, because if we come here, then our number is definitely not 0. So how we are going to do that? Well, let me show you the algorithm on an example. Let's say that our user is going to enter a number 1325, for example. That is the number that our user enters. So how we are going to count the digits of this number? Well, first we are going to have a variable that is going to be called counter, like this. And initially we are going to set the value of that counter to 0. So that is initial count of our digits of number. And then we are going to use while loop to iterate through all the digits of this number. And in each iteration, we are going to do following. So we are going to come here, and then we are going to say, okay, take this last digit of my number and really remove it. I don't need it. And as well increase the number that my counter is holding. So increase the number of digits because we have removed one digit. And then in the next iteration, we are coming here and we are as well saying, okay, so take that last digit and increase my counter like this. And then in the next iteration, take the last digit, increase counter, and in the next as well, take last digit, increase counter, and then when we come next time, we really have nothing more to count. So there are no more digits left. Our number at this situation here is going to be equal to 0, and then we are going to know that there is nothing else to count. And then we are really going to leave our while loop, and we are going to write out the value that our counter variable is holding, which is at this situation 4. So let me show you how we can do that in our code. So I'm going to delete this part here. We don't need it anymore. And then here I'm going to write out the following. So as we explained already, first thing that we need to do is we need to create a variable that is going to be called counter, like this, or digits counter, however you prefer. And that variable, I'm going to assign a value of 0 initially. And after we have created this variable here, now we need our while loop. So while, like this, and then inside these parentheses here, we really write out a condition that our while loop is going to check each time that it wants to run, each time that it wants to iterate. And that condition here is really going to be, please check whether my number is greater than 0. Okay, so in any case where our number is greater than 0, our while loop is going to execute this block of code that I put inside these parentheses. And what we are going to put inside these parentheses, well, as we already explained previously, first thing that we need to do is we need to say number is equal to number divided by 10. And what this line of code is going to do, well, let me show you that on an example. Let's say that our number, so our number holds the value of 1, 2, 3, like this. And this line here really says the following. It says, please do this expression here, so calculate it, and whatever this expression here results in, assign that to my number variable. And 1, 2, 3, so 123 divided by 10, because this here is whole number, so it's integer, and this here is whole number as well. The result is going to be whole number, and that is going to be 12. Or 12.3, but because the result has to be the whole number, that 0.3 part is just deleted. Bye-bye. So then this 12 in this situation is going to be assigned to our number variable. Okay, so that means that this number divided by 10 is really going to take away that last digit, which we have previously explained. So I'm going to delete this part here. Okay, and this line of code, there is really one more way to write this. So write the same thing. So I'm going to comment this here, and I'm going to write out number divided equal, so number r, like this, 10. Okay, so this line of code here and this line of code here are exactly the same. This is just a shorter way to write this here, and this looks prettier to me, but you can leave whichever of these two you prefer. Okay, so after we have taken the last digit from our number, what we are left to do is to increase our counter variable by 1. So we can do that using our increment operator here. So this part of code has really, in each iteration, taken away 1 digit and then increased counter variable. So what we should do now, after our while loop finishes, we should really write out how many digits our number contained. So we are going to write out count number contains, like this, and then let's write out the value that our counter variable is holding, like this. What is this? Oh, it says count instead of cout. Okay, and then let's write out just digits, like this. Okay, so our number contains whatever our counter variable is holding, digits. So now I can really run my program, and let's do that. So it asks us to enter a number. Let's enter number 1, 2, 3, for example. and it says that our number contains 3 digits, which is correct. So let's very quickly explain one more time how this has happened. So I'm going to stop my program, and I'm going to say here that our user has entered number, let's say 123. So our program in this situation comes here to our while loop, and it says please check whether the number that our user has entered is greater than 0, and that number is 123, so 123, which is greater than 0. So then our program can really start executing this while loop. So it enters here, and then it comes to the first line of this while loop, and it says please do this expression here. And this expression here really just takes the last digit of our number away, and that is going to be 3, so we are going to take that away. And then the next thing that needs to happen is increase the value of our counter. Since previously the value of our counter was 0, now the value is going to be increased by 1, so that is going to be 1. And after that, our program comes here, and because of the nature of the while loop, it goes back here. It checks again whether our number is greater than 0. Our number is 12 now, so the 1 digit has been taken away. So that is still greater than 0. So then our number really comes here, and then does this line of code again. So it says again, please take away 1 digit from my number. So then it takes away this 2 part. And then it comes here. It says, now increase my counter because you have taken away 1 digit, and that is going to be 2 now. After that, our program comes here and then goes back here, checks whether our number, so whether our 1 is greater than 0. It says yes, and then it comes here and it says, please divide my number by 10, so take away that 1 digit. So that 1 digit is taken away, and we are left with 0, and then our counter is increased by 1, and then we are really going to come here again, and then our program goes back and says, please check whether my number, so whether 0 is greater than 0. And then our program says, no, it is not. So our while loop is not executed anymore. And then it comes here instead, and it writes out that our number contains 3 digits. And there is one more situation that I want to show you, and that is going to be what is going to happen in a situation where our user decides to enter a negative number. So let's run our program and let's see how our program is going to behave in that situation. So now I'm going to enter a number of -335, for example. And you see that our program writes out that our number contains 0 digits. Why has that happened? Because our program has come here, so it has increased our counter. It has actually assigned our counter a value of 0, and then it has come here and it has really tried to check whether our number is greater than 0, but because our number is -335, that is not greater than 0, so our program then really is not going to execute this block here, but it's just going to go here directly. So then it's going to write out that our number contains, and the value that it has assigned to our counter here, which is 0, so our number contains 0 digits, and that's the message that you see here. So that is the explanation of this behavior, and we need to solve that now. How we are going to solve that? Well, it's pretty simple. So here, when we come to this else block, in this situation, in this 14th line of code, we are really sure that our number is not equal to 0 because we have checked that here. But here we really don't know whether our number is less than 0 or greater than 0. So here we really have to check whether our number is less than 0, and if it is, we really need to get the absolute value of our number, which means if it is negative, we have to convert it to the positive number. So here I'm going to write out the following condition. So I'm going to say, please check if my number is less than 0, like this. And then if this here results as true, I'm going to write out here a way for my program to convert this number, in case that it is negative, into a positive number. And how we can do that? Well, we can really multiply that number by -1. So we can say number is equal to -1 times number, like this. Okay, so now if I run my program, And if I enter value of minus 236, for example, our program now writes out that our number contains three digits, which is correct. So how has this happened? Our program has come here. It has really checked that our number is less than 0, and then it has come here and it has said, please do this expression here, and then assign that to my number. So minus 1 times minus 236, those minuses are going to really convert into plus sign, and then 1 times 236 is going to be 236. And after that, we are going to do the same logic here. So we are going to write out that our number contains 3 digits, which is correct answer. Okay, so that is the one situation that I wanted to explain, and there is also another situation that I want to explain to you, and that is what is going to happen in the following situation here. So let's see. Let me enter a number that is very, very, very large. I cannot even read this number here. So how our program is going to behave in this situation here? Write it in the comments down below, please, before I execute this here. And now if I press enter, what is going to happen? Well, our program has glitched a little bit, and after that it has written out that our number contains 10 digits. But this is definitely more than 10. Why has this happened? If you are not familiar with data types and overflow and concepts that I have already talked about in one of my videos, I am going to link that video here, so make sure to watch that video. And now I'm very quickly going to explain what has happened here, but make sure to watch that video. So when we have entered this number here, let me stop this program and let me put a breakpoint here, and now I'm going to run my program. And what this breakpoint is going to do, it's really going to stop the execution of my program at this line here. And we haven't talked about breakpoints or debugging programs previously, but if you want me to include that in one of my next videos, make sure to write it in the comments down below, because I really believe that it is important for you to see how your program is executed line by line, so to be able to follow it. And in that way you can really discover any bugs and any situations that are tricky and that are happening inside your program, so you can see and control that better. So I have put here a breakpoint, and let's now enter a number that is going to be a very large number. Okay, so if I press enter now, you see that my program has really stopped the execution here on this line here. So after I have entered my number, and then even though I have entered a number that is pretty large, let's hover over this number variable. You can see that it is holding a value of 2,147,000,000 and something. So this value here is definitely not equal to this value here. But because our program has really gotten the value that is much larger than the maximum value that our int variable can hold, it has really assigned the maximum amount that our int can hold to our number variable. So that is what has happened in this program. And if I click continue now, you can see that our program writes out that our number contains 10 digits, because it really was holding a 10-digit number. So that is the maximum amount that our int type can hold. Okay, so that is the last situation that I wanted to explain to you, and I hope that you like this video, and if you have learned something new, make sure to subscribe to my channel, share it with all your friends, anyone who would like to learn programming. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And first things first, make sure to subscribe to my channel and hit that bell icon as well, and share this video with everyone. It really helps me to reach a lot more people. And in this video, I want to show you how you can reverse a number. So your user is going to enter a number, and what we want to do is we want to write out that number in reverse. So reverse the order of the digits of that number. And here I have opened my Visual Studio, so let's copy the text of this task like this. And the first thing that we need to do is we need to really create a variable. So let's say int number, like this, so that our user can enter his value in this variable here. So let's write out a message to our user. So let's say cout number, like this, so that our user knows that he should enter a number. And then let's accept that value in our number variable. Oh, number, like this. Now, after our user has entered a number, let's really think about how we are going to solve this problem. Okay, I get it. So the first thing that I notice here is that we are missing a variable, and that variable is going to be the one that is going to hold our reversed number. So let's declare it here. I'm going to add it here, and I'm going to call it, let's say, reversed number, like this. And I'm initially going to assign it a value of 0. Okay, and now the algorithm that we are going to use in order to solve this task, in order to reverse our number. So the algorithm that we are going to use is going to be the following. So this reverse number here, it is holding a value of 0 initially, and this number here is the one that our user enters. So let's say, for example, that our user enters a value of 123, like this, so 123. So how we are going to reverse this number here? The algorithm is going to be following. So we are going to iterate through this number here. So all the digits of this number here, we are going to go through those. And in each iteration, we are going to do the following. So the first thing is we are going to say, please take this reverse number and multiply it by 10. So 0 times 10 is going to stay 0. After that, what we are going to do is we are going to take this last digit of our number that our user has entered, and we are going to add that number to our reverse number. So 0 plus 3, and that is going to be equal to 3. And after that, we are going to really remove that last digit of our number. So I'm going to delete that digit. And then in our next iteration, what we are going to do is the same thing. So we are taking this reverse number, we are going to multiply it by 10. So I'm going to say 3 times 10, that is going to be equal to 30. And after that, we are going to take this last digit of our number, and we are going to add that digit to this number here, so to this reversed number. So 30 plus 2, that is going to be equal to 32. And then we can really remove this last digit here. So I'm going to delete it. After that, we are going to the third iteration, and we are doing the same thing. So we are taking this reversed number, multiplying it by 10. So 32 times 10 is going to be equal to 320. And then we are taking the last digit of our number. This is this one here. And we have to add that digit to our reversed number. So 320 plus 1 is going to be equal to 321. And after that, as we did before, we can really remove this digit here. And then in my next iteration, we are going to come here again, and our loop is really going to see that there is nothing else left to iterate through. So there are no more digits. And then it is really going to leave that loop. And at that moment, we are really going to have our reversed number. So 321, that is reversed number from the one that our user has initially entered. So let's now translate this algorithm into our code. So the loop that we are going to use in order to solve this problem here is going to be while loop. So I'm going to write while, and then in these parentheses here, I'm going to really give it an expression that is going to check each time that it wants to run an iteration. And what we are going to iterate through are the digits of this number here, so the number that our user has entered. So I'm going to say, please iterate through this part here, so execute this block of code here, which is currently empty, while our number, so number, where is it, is different than 0, like this. Okay. And inside here, we are going to write out the algorithm that I just explained. And the first step of that algorithm was really multiplying our reversed number by 10. So I'm going to say reversed number is equal to reversed number times 10, like this. Okay, and the shorter way to write this expression here is going to be like this. So you can really take this part here, delete it, and say it like this. It is going to do absolutely the same thing. So it is going to really multiply our reversed number by 10, and then whatever that results in, it is going to assign that back to our reversed number. So that was the first step. The second step in order to reverse our number is going to be really to take the last digit of this number that our user has entered. So how can we do that? We can do that by modulating this number here by 10. So I'm going to declare a variable. Let's call it last digit, like this. And as we already said, we can get that last digit if we modulate this number here. Where is it? So this number that our user has entered by 10, okay. That is going to give us the last digit of this number here. And then what we really want to do is we really want to add that last digit to our reversed number. That was one part of this algorithm. So the next step. So I'm going to say reversed number plus equal to last digit, like this. Or you can write it a longer way, but this way I prefer to write it this way. But you can as well say reverse number is equal to reverse number plus last digit. And after we have added that last digit to our reverse number, there is one more step left to do, and that is to really take that last digit from our number. And how we can do that? Well, we can really do that by dividing our number by 10. So you can say number is equal to number divided by 10, or number divided equal to 10, whichever way you prefer. Okay, so this is really the algorithm that we explained, and this step here you can really write out the shorter way if you want. So you can say, for example, reverse number plus equal to number modulated by 10, like this. So you can make your code a bit more readable if you prefer it this way, or you can leave this part here and then really add your last digit to your reversed number. So now that we have done this algorithm here, let's write out our reversed number and see what we have done. So I'm going to write out cout, and I'm going to say reversed, like this, okay. And I'm going to write out our reversed number. Okay, let me delete these empty spaces, and if I run my program now, it asks us to enter a number. So let's enter number 1, 2, 3, and now if I press enter, you can see that our program has really reversed this number here. So let's quickly one more time explain how this has happened. So our while loop has really iterated through this number here, so that in each iteration it is going to do the following. So it is going to take our reverse number, and initially that reverse number is equal to 0, so it is going to multiply that by 10, so it stays 0, and after that is going to take that reverse number and add it the last digit of our number that our user has entered. So that is going to be in a first iteration number 3. So our reverse number in that case becomes 3. So 0 plus 3 is equal to 3. And after that, we are going to really take that last digit from our number that our user has entered. So it has taken this 3 part away. And then in the second iteration that's coming here, it is going to check again whether our number is not equal to 0. And our number is going to be 12 in that situation, so that is not equal to 0. So it enters here again. It executes this block of code here. So it says again, please multiply my reverse number by 10 and assign that again to my reverse number. So our reverse number was 3, and if you multiply by 10, if you multiply 3 by 10, you're going to get 30. After that, it is taking the last digit of the number that our user has entered, which is 2 now, because 3 we have taken away in our previous iteration. So it is going to add that 2 to my reversed number. So reverse number is going to become 32 now. And then it is really going to take that last digit from our number away. It is going to divide it by 10. So now we are left with number 1, and our reverse number is equal to 32. And then it goes back to our third iteration. It checks again whether our number, so whether our remaining number is equal to 0, and this 1 here is the value of our number, so that is not equal to 0, so this condition here is fulfilled. It can enter the while loop. So it does this algorithm here again. So it says, please multiply my reversed number by 10. Our reversed number at this point is 32. So when you multiply that by 10, you get 320. And then after that, it takes the last digit of our number, which is going to be this one. So this one here, which is the last one remaining. So it is going to take this one and add it to my reversed number, as you can see here. And then it is really going to take that last digit away. So it is going to take all of these 3 digits away. So it has taken them in the previous iterations, and now it has taken this one away as well. So our number is equal to 0 now. And then it goes back to our fourth iteration. It checks whether our number is not equal to 0, but in this iteration our number is equal to 0. So it really leaves this loop here. So it is not going to enter in this loop anymore, and then it goes here and it really writes out the value of our reversed number, which is this line of code here. So that is how we have reversed our number. So I hope that you like this video and that you understand this explanation. If you have any questions, write those in the comments down below, and also share this video with all your friends, with anyone who would like to learn programming. And thanks for watching. I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. If you are already a subscriber, welcome back. And if you're a new viewer, make sure to subscribe, hit that bell icon as well, and welcome to my channel. So in this video, I want to talk about the while loop. And in my previous videos, we have already talked about while loop and iteration in general. So if you are not familiar with those, make sure to watch that video. I'm going to link it here. But in this video, I want to explain to you how and when is used do while loop. And I'm going to give you an example of a program that is usually used. And for example, applications such as when you try to unlock your phone and then you are given 3 attempts to guess your PIN. And if you guess it correctly, then you can proceed loading your phone's applications further. Or for example, if you want to unlock your credit card, so you put your credit card in ATM and then it gives you 3 attempts to unlock your credit card. If you guess your PIN correctly, you can proceed further. But if you fail, so if you don't guess your PIN correctly in those 3 attempts, your account gets blocked. So that is the application that we are going to make today. And for that, we are going to use do while loop. So there are 3 things that we need, actually 3 variables. So I'm going to declare those 3 here. The first one is going to be our, let's say, the PIN of our user. So let's call it user's PIN, like this, which is going to be really the correct PIN, the one that you want to guess. So I'm going to put here, let's say 1, 2, 3, 4. That is going to be our user's PIN. After that, we need another variable, which is going to be really the PIN that our user enters. So let's call that variable just PIN. Okay, like this. And then the third variable that we need is going to be really counter of our errors. So the counter of the attempts and errors that our user has made. So I'm going to call that variable error counter, like this, and let's set that value initially to 0. Okay, and the next thing that we need to do is we really need to give our user 3 attempts in order to guess this PIN here. And if he guesses it correctly in those 3 attempts, we are going to write out that the application can be loaded further. So we are going to write out application is loading or something like that. But in the case that our user does not guess this pin here, so this pin here correctly, we are going to really write out that the application or credit card, whatever, has been blocked. And how we are going to do that? So we are going to use do while loop. So I'm going to write out do like this. And then here I'm going to put while, because that is the syntax of our do while loop. Okay, and here you need semicolon, because if you don't put it, you are going to get a syntactic error. Now here we put the block of code that we want to execute in each iteration, and here we put the condition that we want to check each time that this code here is executed. We come here and then we check that condition, and if this condition here that we put is correct, we are going to go again here and do one more iteration, and then again check, and then do one more iteration, and we are going to repeat that until this condition that we put here is no longer true. When this condition here, when it becomes false, we are going to leave our do while loop. Okay, so what do we want to enter? So what do we want actually to do in this block of code here? We really want to write out a message to our user so that he knows that he should enter a pin, and then we want to really accept that pin that our user enters in this variable here. So let's do that first. I'm going to write out cout like this, and then let's just write out pin like this. And let's accept the value that our user has entered in our pin variable like this. Okay. And then after we have done this, what we need to do is we really need to check whether this pin here, so this pin that our user has entered, corresponds to this pin here. So whether this value is equal to this value here. And if they are not, that means that our user has failed. So in that case, we are going to increase our errors counter. So I'm going to put here if pin is not equal to user's pin like this. What we want to do is we want to really increase our errors counter variable like this. Okay, and this code here, so we want to give the attempt to our user so that he can enter a pin, and then we want to check whether that pin is correct 3 times, or until this pin here and this pin here are the same. So until they are equal, or until our user has used all of these 3 attempts that we have given to him. Okay, so here I'm going to really put that condition. So here inside these parentheses, I'm going to write out, please do this block of code here while our, let's say, while our errors counter is less than 3, like this, and then also at the same time while our pin is not equal to user's pin, like this, which means that this block of code here is going to be executed while our user has not used all of these 3 attempts that we have given to him, and while this pin here, so this pin here and this pin here are not equal. In a situation where this here results as false, we are going to come here, and after that, when we come here, we really want to check whether we have left this do while loop here because our errors counter has reached 3, or because these 2 were the same. In a situation where our errors counter has reached 3, that means that our user has used 3 attempts and that he has not guessed his pin correctly. So I'm going to put here if our errors counter is less than 3, like this, and this condition here really means that this do while loop has been left in a situation where our user has not used all of these 3 attempts that we have given to him. That means that this while condition has really failed on this part here. So that means that our user has entered 1, 2, 3, 4 as pin, and in that situation 1, 2, 3, 4 is not equal to 1, 2, 3, 4. That results as false. So this whole expression here, this whole condition results in false, and then we leave our do while loop. And in that situation, if our user has not used all of these 3 attempts, that really means that he has guessed his PIN correctly. So here in this if situation, we can write out to our user, cout, you have guessed, or you can proceed with loading of this application. So I'm going to write out just loading, like this. But in a situation where our while loop has been left because this errors counter is greater than 3, actually it is going to be equal to 3, that means that our user has failed in guessing his PIN 3 times, and that means probably that he's not trying to unlock his phone or his credit card. So in that situation, we are really going to block that account. So we can say else cout blocked, like this. Okay, and I'm going to put one more here, like this. So this is going to be a program that we really use to allow our user to enter 3 attempts of his PIN, and in a situation where he guesses that PIN correctly in those 3 attempts, we are going to write out to our user that he has successfully unlocked his phone, for example, and we can proceed with loading of applications. But in a situation where he really uses all of those 3 attempts and fails to guess his PIN, we can write out that the application is blocked. Oh, blocked. Now it's okay. So let me run this program, and let's try to use 3 attempts. So I'm going to say that my first attempt is going to be, for example, 1111, like this. So it says you have not guessed correctly, please enter your PIN again. This is what it means. After that, I'm going to try, for example, 2222. It tries to prompt me to enter my PIN again because I have failed previously. And let's say that my third attempt is going to be 3333, like this. And then it has written out a message that my account has been blocked because I have missed 3 times. Okay, so that is one scenario, and the other scenario is going to be really where we guess, the one where we guess our PIN correctly. So let's say that our first attempt is going to be 1111 again, and after that we really remember what is the correct PIN, and we enter 1234, like this. And then if I press enter, it says really you are loading, you can load your application now, or the further loading of your application is going to begin now, because we have guessed the correct PIN. So let me very quickly explain one more time how has this happened. So this code here, when we come to this do while loop, the first thing that is executed is this line here. So it says, please enter your PIN. And then after your user enters the PIN, your program really checks whether that PIN is equal to user's PIN, so the previous PIN, the one that he needs to guess. And if those 2 are not equal, that means that your user has not guessed correctly, and then you want to increase your errors counter, so the number of attempts that your user has used and failed actually in using. So we increase in our first iteration that errors counter to 1, so from 0 to 1, and then we come here, and then our loop really checks whether that errors counter is less than 3, so 1 is less than 3, that is true. And also it checks whether that PIN here is not equal to the PIN that we need to guess. And in this situation, it is not equal. So it also, this whole expression results as true, and it now can go here again. So it prompts you again to enter the PIN. So you can enter the PIN now. And in this situation, we entered 2222, for example. And then it guesses, it checks again. So it checks whether PIN that you have entered, so 2222, is not equal to 1234. Those 2 are not equal, so it increases the errors counter once more, and it becomes 2 now. Then you go here, and then it says, okay, please check whether my user has used all of these 3 attempts. It says that your errors counter is still less than 3. So you have used only 2 attempts so far. And then this condition here results as true because you have entered 2222, and that is not equal to your PIN, so 1, 2, 3, 4. And then it goes back here, tries to prompt you one more time to enter your PIN. And then if you fail this time, it increases your errors counter to 3, like this, and then it goes here and it checks whether your errors counter is less than 3. Your errors counter in this situation is has become 3, so this condition here results as false, and your do while loop actually is now broken, so you are not going to continue the execution of your do while loop, but you come here and then it checks whether errors counter is less than 3, because this here fails, because this here results as false. You are presented with this message here, so blocked. Your phone, your account has been blocked. Okay, and in a situation where your user guesses correctly, that errors counter is going to be less than 3, and you are going to be presented with a message of loading. And there is one important thing that I want to mention, and that is really the difference between while loop and do while loop. In do while loop, you first do, so you first execute this block of code here, and then you check the condition. And then if that condition results as true, you go back and you again do this block of code here. And then you check, and then you do. But in a situation of while loop, you first check the condition, and then if that condition results as true, then you can really proceed with executing your block of code that comes after your while. But in this situation here, so in the situation of do while loop, you first do this block of code here. So irrelevant whether this condition here is true or not, you are going to do this block of code here at least once. I hope that you liked this video. If you did, make sure to subscribe to my channel and click that bell icon as well. And also, if you want me to post more videos like this, make sure to like this video, because then I will know that you liked it. And, well, that's all. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I want to talk about for loops, but before we start, make sure to subscribe to my channel and hit that bell icon as well. Okay, so what I'm going to explain today, I want to explain to you how for loop works, and I'm going to explain that on a simple example, which is calculating the factorial of a number. So let me copy the text of our task here, like this, and I'm going to comment it out. So what is the factorial of a number? Factorial of a number is usually defined as a product of all numbers between 1 and that number that you want to calculate the factorial of. That means, for example, if your user enters number 6, let's say, and you want to calculate the factorial of number 6, you are going to do that in a following way. So 1 multiplied by 2, multiplied by 3, 4, 5, and 6, okay? And then this here is going to result in 720, so this 720 is really going to be the result of your factorial of 6. And this example here is what we want to really translate in our program. So we want our user to enter a number, and then we want to calculate the factorial of that number and write that result out to our user. And we are going to use for loop for that. So let me quickly declare a variable which is going to be called number, okay, like this. And let's prompt our user that he should enter a number. And then let's really store that number that our user enters in our number variable. Okay, so after we have acquired a number that we want to calculate our factorial of, let's explain how we are going to really do that. So I'm going to do that using for loop. And what is the difference between for loop and while loop and do while loop? Because we have previously talked about while loop and do while loop as well. You can find those videos on my channel if you're interested, and I'm going to link those videos in the description of this video if you want to watch them. So the difference is that usually when you use for loop, beforehand you should know how many iterations that loop is going to make. So for how long your loop is going to run. So let me show you the syntax of our for loop. You say for, and then you use these parentheses here in which we are going to put certain expressions in a moment. And after that you put these curly brackets in which we are going to write out the code that is going to be executed in each iteration of our for loop. So inside these parentheses here we need to put three things. What are those three things? The first one is going to be to set the initial value of our counter variable. That is the first one. After that, the second is going to be to really put the condition that your for loop is going to check each time that it wants to run this block of code here. So before each iteration, it is going to check that condition. So that is going to be the second thing. And after that, the third thing is going to be really a way for your counter value to come to that condition, which means that you have to either increase or decrease your counter variable in order to reach that condition at certain point, and then when that condition results as false, your for loop is not going to be executed anymore. Okay, so those are three things that we need to put in these parentheses here. And let's now look at this example here, because from here we are going to really deduct which conditions, which expressions we are going to put here. So if you notice this algorithm here, because this is really algorithm, nothing else, you see that this is really a counter. This behaves as counter. So it goes 1, 2, 3, 4, and it really starts at 1, and then it goes up to that value that your user has entered. So we can use that for our expression here. The first expression is initial value of our counter. We need to declare that variable, and we are going to call that variable I. You can call it counter or whatever you want. Really, your compiler is not going to give you an error because of that, but the common practice is to use a single letter variable name for this counter that you use in your for loop. So I'm going to use name I for that, and the initial value of my I counter is going to be 1, because as you can see here it really starts on 1, and then after that we need to put the condition that your for loop is going to check each time that it wants to run a new iteration. And that condition, as you can see here, is really this expression here. This algorithm runs until it comes to this 6, until it comes to the value that your user has entered. So we are going to put that here. We are going to say, please run this block of code here until my I is less or equal to number, like this, so whichever number our user enters. And then the third thing is going to be really to give our loop a way to reach this condition here at some point, which means to make this condition here false and then leave our for loop. And again, we look here and you can see that your counter is really increasing in each iteration by 1. Okay, so here we are going to put I++, which is in each iteration going to increase the value of our I counter by 1. Okay, so after we have put these expressions in these parentheses of our for loop, we need to really put a block of code that is going to be executed in each iteration of our for loop. And I'm going to declare, before this for loop here, I'm going to declare another variable, which I'm going to call factorial, and I'm going to give it a type of int. Okay, like this. And I'm going to assign the initial value to my factorial variable, and that is going to be 1. And then how I'm going to use this factorial variable. In each iteration of my for loop, I want to say that my factorial is going to be equal to whatever my factorial was previously holding, multiply that by my current I value, which means by the current value of my counter. And how this is going to behave. So let's say that our user enters, for example, number 3. And then your execution comes here and it says, please declare a variable which is going to be called factorial, and it is going to have a value of 1. So we have assigned that value here. And then it comes to your for loop. The first thing that your for loop is going to do is it is going to declare this I variable here and assign it a value of 1. So we are going to write that here. So we are going to say I is equal to 1. And then it really goes here and checks this condition here before it determines whether it's going to run this block of code here or not. So if this here results as true, it is going to run this block of code here, and if not, it is going to leave your for loop. So is your I less or equal to the number that your user has entered? So your I is going to be 1, and then that is less or equal to 3. So your for loop is going to execute this block of code here, which means that it is going to come here and say factorial multiplied by 1, which is going to be 1 multiplied by 1, and that is going to result as 1. And it is going to assign the result of this here to your factorial variable, which is going to stay 1. After that, your for loop comes here, and at this close bracket here, it really goes here and it increases the value of your I. And this increment operator is going to increase it by 1, so your I now becomes 2. And then after that, it goes back here and checks this condition here. So it says, please check whether my 2 is less or equal to the number that your user has entered. So 2 is less or equal to 3. So it is going to run this block of code here again. And then it is going to do following. So it is going to say, please multiply my factorial value, so the previous value that my factorial was holding, which is 1, by the current value of my I, which is 1 multiplied by 2. That is going to result as 2, and that is going to be assigned to your factorial variable. So we assign 2 here, okay? And then it goes back to these close brackets, and then it goes here, increases the value of your I again. So your I now is 3, and then it really checks this condition here. So whether 3 is less or equal to 3, the result of that is going to be yes. So it is going to do this expression here again. So the current value of your factorial, which is going to be 2, multiplied by the current value of your counter variable, which is going to be 3. So 2 multiplied by 3, that is going to be 6, and that is going to be assigned to your factorial variable. After that, it goes here, and then it really increases again the value of your I variable, so of the counter that you are using in your for loop, and that value becomes 4 now. After that, it is going to try to check this expression here, so this condition here, and 4 is not less or equal to 3, so your for loop is not going to execute anymore, and then your execution comes here, and at this line of code here, it has the value of 6 in your factorial variable, which means that we are left only with the need to write out this to our user. So we need to say, let's say it like this, number, okay, and then let's say factorial of that number is going to be equal to, and then let's write out the result. So the result we are holding in our factorial variable like this. So this should really write out the result of this here. So the factorial of this number that our user has entered. And if I run my program, you can see that it asks us to enter a number. I'm going to say, let's say for example 3. And then if I press enter, it is going to give us the result of 6, which is the correct result, the one that we previously got. Let's run it one more time, just to check this number here. So I'm going to say, please give me a factorial of 6, and it calculates that the factorial of 6 is 720, as we did before. So this is going to be really one way of writing this for loop for this current example. So for calculating factorial, I want to show you another way how you can do exactly the same thing. So I'm going to really comment this part of code here. So I'm going to say comment this block of code here. And then there is another way to write these parentheses here. So as you can see, this example here is what we have used in order to write these expressions inside these parentheses. But there is really one more way to calculate your factorial, and that is going to be to start at this maximum value, which means 6 factorial is equal to 6 multiplied by 5, by 4, 3, 2, 1, and that is going to be equal to 720. So now you start your counter at this maximum value, so this number that your user has entered, and then you really decrease the value of your counter, and you go until your counter value comes to 1, and that is the condition when you stop. So your 1 value of a counter is going to be the last iteration through your for loop. So now we are going to write out, we are going to really write our for loop using this algorithm here. So we are going to say for, and then also put these parentheses, which we are going to use for the block of code that we want to run through in each iteration. And in these parentheses here, I'm going to set the initial value of my counter. That is going to be I is equal to, and as you can see here, our I starts at 6. So I'm going to put here 6, which means a number that our user has entered. In this current situation, it is 6. But since we want to calculate the factorial of whichever number our user decides to enter, I'm going to use that variable here. Okay, and then the condition that your for loop is going to check each time that it wants to make a new iteration, and that is going to be, please run this block of code here until my I is greater than or equal to 1. Okay, and then the last thing that we need to put here is going to be really a way for our for loop to stop at a certain point. And if you look at this example here, you see that your counter is decreasing by 1 in each iteration. So we are going to put that here. We are going to say I minus minus, which means use this decrement operator on our I variable. And then we are going to really use the same expression here. Okay. And this is going to give us the exactly the same result as this code here did. So if I run my program, you can see that it asks number again. So if I enter number 6, for example, it is going to give us 720, as this code here did as well. So let's repeat one more time. There are 3 things that you need to put in these parentheses here in order to set up your for loop. And the first one of those 3 is going to be to set the initial value of your I variable, which means the initial value of your counter. After that, you need to put the condition, which is going to be checked each time that your for loop wants to run an iteration. And if this condition here results as true, your for loop is going to run this block of code here. But if this condition here results as false, your for loop is not going to run this block of code here, but you are really going to leave your for loop and come to the next line after it. And then the third thing that you need to put in these parentheses here is going to be really to either increase or decrease value of your counter variable so that it can reach this condition here at certain point and make it false. So we have decreased it in this example here, and we have increased it in this example here. So those are 3 things that you need to put inside these parentheses here, and you really need to separate those 3 using this semicolon sign. Okay, and there's one more thing that I need to mention, and that is going to be really, you can upgrade this program here so that it checks whether this number here is greater than 0, because you cannot calculate factorial of negative numbers, so our program is not going to behave as expected if you enter negative number. And also the factorial of 0 is going to be equal to 1. So you can put that code here and determine whether your user has entered positive or negative number. And in case that your user has entered negative number, make sure to write out appropriate message to your user. So I think that is all. If you like this video and if you learned something new, make sure to subscribe to my channel and hit that bell icon as well. Share it on your social media because it really helps me to reach a lot more people so that all of us can learn and upgrade our knowledge in programming. And I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video I want to talk about nesting loops. In my previous videos we have talked about while loop, do while loop, and for loop, and now I want to show you the example on how you can really combine and nest those loops. So if you haven't watched my previous videos or you are not familiar with loops at all, I recommend you to watch those. I'm going to link those in the description of this video. And also, before we start, make sure to subscribe to my channel and click that bell icon as well. So what are we going to do in this video? I want to really show you how you can nest for loop and do while loop, and the example that I'm going to use to explain that is going to be following. So I want my user, which is going to be a student, let's say, to enter 3 grades or more. If you want, we are going to use 3 for this example. And I want those grades to be between 1 and 5. And then I want to write out the average grade. So the average grade between those 3 that he has entered. So let's start building our program. The first thing that I need to explain is, since we are going to enter 3 grades, that means that we are going to repeat that entering process 3 times. And for that, I'm going to use for loop. So I'm going to write for, and then in these parentheses here, I'm going to put my initial setup of for loop, which is going to be, the first thing is going to be initial value of our counter. So I'm going to declare a counter, which is going to be called I, and initially I'm going to give it a value of 0. That is the first thing. The second thing that I need to put in these parentheses here is going to be the condition that our loop checks each time that it wants to run a block of code, which is going to be this block of code that we put inside these parentheses. So that condition we put here, and that condition is going to be while our I is less than 3. So we want to make 3 iterations. In the first iteration, our I has the value of 0. In the second iteration, it's going to have the value of 1. And then in our third iteration, it's going to have the value of 2. So we have made 3 iterations. After that, it gets the value of 3. But this condition here is not going to be true anymore. So then our for loop is not going to be executed anymore. So that is the second thing. And then the third thing which we need is going to be really increasing that value of our counter in each iteration, so after each iteration. And I'm going to put here this increment on our I variable. Okay, so in this block of code here, we are going to repeat 3 times something. So what is that something? That is going to be really the process of our user entering the value for his grade. And since we said that that grade needs to be between 1 and 5, I am going to use do while loop for that. How? Well, I'm going to write out do, okay, and then here I'm going to put while, which is going to be the condition. So here we prompt our user to enter the grade, and then we say here, you are going to have to enter that grade while that grade is less than 1 or greater than 5. So since we don't have any variable that we are going to use to enter that grade, I will have to declare it here. So I'm going to say here int grade, like this. Okay, and then let's prompt our user in this block here to enter his grade. So I'm going to write out cout, and let's say enter grade, and I am going to use the current value of my counter so that I can really say which grade my user is entering. So enter first grade, second grade, and third grade. So I'm going to say I plus 1, like this. Why plus 1? Well, because our counter starts at 0, and it wouldn't make much sense to say to our user, please enter grade 0. So that is why I'm increasing this value of my I when I want to write out a message to my user. Okay, like this. So here I'm going to write out, please enter a grade, and after that I need to accept that grade that my user enters in my grade variable. So I'm going to say cin grade, like this. And we are going to repeat this process here for a single grade while our user enters a grade that is less than 1 or grade is greater than 5. Okay, so our program is really going to prompt our user, please enter grade 1, and then he enters 6, for example, and then our program checks this condition here and says, okay, you have missed this part here, so go back and then please enter grade 1, so first grade again. Okay, so if I run my program now, let's just prove that very quickly. So our program says now enter first grade, so enter grade 1, and then let's say that I enter 9, for example. It prompts me again to enter first grade because I have not obeyed this rule here, this part here. So I'm going to say this time, for example, 5. And then it says, okay, you have successfully entered first grade. Let's now enter second grade. So for that second grade, let's enter, for example, 0. And then it prompts me again, you have not entered correct value for grade 2, please enter it again. And let's say that this time I'm going to enter 1, and then it asks for third grade, and let's say that this time third grade is going to be 3. So our program now has successfully accepted this third grade, and now our program is going to really finish its execution because we haven't written anything else after this part here. So there is something else that we need to write. And since we want to calculate the average grade of our user, what we are going to need is going to be really to sum all of these grades that our user enters. So I am going to declare a variable which is going to really hold that sum of our user's grades. So I am going to put it here. I'm going to call it sum. And initially I'm going to assign it a value of 0. And later I'm going to explain why. So I have declared a variable that is going to be of type int, and I have called it sum and assigned it a value of 0. So this sum here is going to, each time that our user enters a grade, and we really check that that grade is valid grade. After that, we want our sum to hold whatever it was previously holding plus the value of our grade, like this. Okay, so why I have assigned a value of 0 to my sum? Because 0 is a neutral value when it comes to adding numbers. You add 0 to whichever number and then you get that same number. And in a situation where we didn't assign any value to our sum, we would get really an error. So if I try to run my program now, you see that it prompts me with an error and it says uninitialized local variable sum used because it does not have any value assigned to this variable here. It is going to say really that it does not know how to add the value, so the value of our grade, to our sum. So that is why we need to assign some value to our sum variable. Okay, so and that value is going to be 0 because 0 is neutral when it comes to adding numbers. Okay, so now I can really run my program, and as you can see, that error has disappeared. So I'm going to stop my program, and let's very quickly write out this sum that we have calculated here. So I'm going to say cout, and I'm going to write out sum like this. Sum is equal to, and then let's write out the value of our sum, and let's add end line like this. So I am going to run my program once more. It prompts me to enter first grade. I'm going to say that my first grade is going to be, for example, 5, and then my second grade is going to be, for example, 6. That's an error, so please enter your second grade again. So I'm going to enter this time 2, let's say, And then for my third grade, let's enter 1, for example. And it says that the sum of my grades is equal to 8, which is correct. So 1 plus 2 plus 5, that is going to equal to 8. So what we are left to do, now we should only really divide our sum by the count of our grades, which is 3, because we have hard-coded this value here to 3. So our user can enter only 3 grades. You can really use a variable for this, or you can hard-code it to any other value that you want and need. So here, after this line of code here, what I need to do is following. So I'm going to say cout, and then let's say average is equal to, let's say average grade is equal to, and let's write out the result. So that is going to be sum divided by 3. Okay, is it though? So I'm going to run my program, and let's enter, for example, value 2, and then again value 2, and then let's enter, for example, value 4, and then it says that average grade is equal to 2, which is not correct. But why has this happened? So as you can see here, we have used 2 integer variables. So our sum is integer value, and then 3 is integer value as well. So when you divide 2 integer values, the result is also going to be integer value. So in order to get a floating point, a decimal point number, you really need to convert one of these 2 into a float type. So you can say either here, you can say float. So please convert my sum variable into float and then divide, or you can put here this 0.0, or you can leave both of these, whichever you prefer. So I'm going to leave both of these like this. So if I run my program once more, it prompts me again to enter first grade. So I'm going to say that my first grade is equal to 5, and then my second grade is also 5. And then let's say that the third grade of our user is going to be 9. So our program prompts us again to enter the third grade because it needs to be in this interval here. So I'm going to say now that the value of my third grade is going to be 3, which is correct value. And after that, as you can see, it writes out that the sum of these 3 grades is 13, and then average grade is 4.33333. So that was an example on how you can really combine and nest loops in order to solve complex problems. And thanks for watching. Make sure to subscribe to my channel, click the bell icon, also share it with anyone who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video I want to talk about nesting for loops. So I want to show you how you can solve more complex problems using nested for loop. But before we start, please subscribe to my channel and click the bell icon as well, and also like this video. So this example that we are going to do today is going to be really multiplications table. So I'm going to show you the example that I want to program. So that would be this here. And if you look at this multiplication table that we want to make, you can really start to notice a pattern. And what pattern I mean? You see here, this first operand in this first part of my multiplication table, so in this first table, as you can see, this first operand is 1, and it stays 1 in this table here. After that, you can look at this second table, you see that this operand is now 2, and then in my third table, it has increased to 3, 4, 5, and it really increases, so it increments by 1, and it goes up to 10. Okay, so that is the first operand, so this first part of my multiplication. After that, we can look at this second operand, and you can really notice that it increases in each iteration by 1. So it goes 1, 2, 3, 4, 5, up to 10. And then it does the same thing in this second table. So it goes from 1 to 10 again. And then the same in my third table, fourth, fifth, and it really behaves the same in this 10th table as well. So that is the pattern that I want you to notice. So this first operand can be really represented using one for loop. So let's say that that is going to be outer for loop, and it is going to increase each time that my second operand counts from 1 to 10, and that second operand we can really represent using another for loop, which is going to be really inner for loop. So the program, the algorithm for solving this problem is going to go like this. You have outer for loop, which is going to count from 1, 2, 3, 4, up to 10. So it is going to count from 1 to 10. And then you are going to have inner for loop, which is also going to count from 1 to 10, but for each value of my counter of my outer loop. Okay, so that means that my outer loop counter changes only after my inner loop has counted from 1 to 10. So let's copy the text of our task here. I'm going to say multiplication table, and let's comment that text out. So as we said, in order to solve this problem, we are going to use nested for loops. So I'm going to add empty space here, and then the first thing that I need is going to be my outer loop. So I'm going to really set up my outer loop. I'm going to say for, and then we need to declare a counter, which I'm going to call I. So I'm going to say int I is equal to, and then since our outer, let me show you this image one more time, since it goes from 1 to 10, I'm really going to set its initial value to 1. So I'm going to say I is equal to 1, and then I'm going to write the condition, so how long this for loop is going to run, and that is going to be while this I is less than or equal to 10, like this, and then each iteration it is going to increase by 1, so that is going to be I plus plus. Okay, and then I'm going to put this block of code here that is going to be executed in each iteration of this for loop. So what we need to do in each iteration of our for loop, let's look at our image one more time, and as you can see, it really says that in each iteration of this outer for loop, you need to count from 1 to 10. So in this iteration here, some other counter really counts from 1 to 10, and then new iteration, so our I is now 2, and then counter counts again from 1 to 10, and then 3, but also we have this inner counter that counts from 1 to 10. Okay, so let's really write that code. So that inner counter that counts from 1 to 10 for each value of our I, we are going to represent with another for loop. And that is going to be really that nested or that inner for loop. So I'm going to write for, and that inner counter I'm going to call j. So I'm going to write int j. And since our j also counts from 1 to 10, I'm going to set its initial value to 1. And I'm also going to say, please iterate through this for loop while our j is less than or equal to 10 as well. And then in each iteration, please increase the value of j by 1. So do this increment operation. And then in each iteration of our j loop, we are going to execute this block of code here. So what we are going to do in this block of code here? Well, let me look at that image once more. And as you can see, in each iteration of our j, so this is one iteration of our j, this is second, third, fourth, fifth, and then 10th iteration of our j. After that, we change our I counter value, so we increment that, and then our j starts one more to count from 1 to 10. So in each of these iterations, as you can see, really we have to multiply our I value counter with our j value counter and write the result of that. So I am going to write that here. I am going to write cout like this, and then let's write out the value of our I counter like this, and then let's write out this multiplication operation, and then let's write out j like this. This is just formatting our text, so I'm going to put this equal sign, And then I really want to multiply those two counters like this. And let's also add one end line here so that our text is formatted nicely, because we are going to have multiple lines. So with this, we have really covered this multiplication part. And there is only one more thing left to do, and that is to add one more end line, because I really want to make separation between these. So I want to make separation between these tables. This is going to be one logical part. After that, this is going to be another, then third, fourth, and I want to put empty space between those two so that I can group them. So I'm going to add here cout end line like this, and that should be it pretty much. So if I run my program now, as you can see, it has generated this multiplication table from 1 to 10. Okay, and it has done that in a matter of less than a second. So as you can see here, we have this outer counter. Oh, I cannot mark that only. So we have this outer counter, which is going to be our I, that counts from 1 to 10. But for each value of our outer counter, for each value of our I, we have to really count from 1 to 10 with our inner counter, which is going to be our J, as you can see here. Okay, so these are the results of our multiplication operation. And I hope that you have seen now how you can really use programming to your advantage, how you can use it to solve not really complex, but tedious tasks. You would really need 20 or 30 minutes in order to write this yourself, and you can now generate it with just a couple of lines of code and less than a second of your computer's power to really execute this code here that you have written. And the most amazing part is that you don't really have to put 10 here. So we have put 10 here because I want to make this example manageable for this video, but you don't have to hard code these values here. You can really use whatever values you want. You can say, for example, let's say 2000. Okay, so I want to generate multiplications table up to 2000. How long would that take in real life? So without programming. Okay, now you see.
A few moments later.
Okay, so it is still running, and it is going to generate around 4 million records, which is a lot, and it is going to do that in a matter of minutes. So how long would it take for you to even just count from 1 to 4 million? It would take you probably days, if not months. And also there were a lot of errors that you would probably make in that process. So I hope that now you can really recognize the power of programming. Now, if you needed to do this task, you would really program your computer to do it, and now you can just go take a break and your computer is going to finish that task for you. So I hope that you can recognize now how you can use programming in order to solve different types of tasks that you can come across in your school, in your job, or life in general. And if you like this video, make sure to subscribe to my channel. Also click the bell icon and share it with anyone who would like to learn programming. And I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I want to show you how you can draw shapes using C++. So before we start, make sure to subscribe to my channel and also hit that bell icon as well, so that you are notified when I publish my next video. And let me show you now what we are going to do in this video. So here, where is it? Here I have image of the task that we are going to do today, and that is going to be really to draw this rectangle shape with the desired height and width and a symbol that our user enters. Okay, so that is the task that we are going to do in this video. And let's very quickly analyze this problem and see how we are going to solve it. So the first thing that we need is for our user to enter height, width, and then symbol. And after that, we will really need to figure out a way, so figure out the algorithm on how we are going to draw this rectangle shape here. So if you look at this rectangle shape, you can really notice that it has the height that is going to be 3 of these symbols that our user has entered. And then it has the width that is going to take 4 of these symbols that our user has entered for width. Okay, so we are going to use nested for loop in order to solve this problem here. And if you're not familiar with nested for loop, I am going to link that video here because I have already made one video with nested for loops, so make sure to watch that video. And in this video, I am going to really use that nested for loop in order to control height and width of our rectangle shape. So we are going to have outer for loop, which is going to really control this height. And then for each iteration of our outer for loop, we are really going to control this width with another loop, and we are going to count from 1 up to 4, because 4 is the width that our user has entered, and draw that shape in each iteration of our inner for loop. Okay, so that is what we are going to do. So let's now translate that into code. I'm going to say here, first thing that we need is going to be from our user to enter width and height. So I'm going to declare 2 variables. The first one is going to be height, like this, and then width. Okay, so let's write out a message to our user so that he knows that he should enter height. Okay, now let's accept that height value in our height variable. And after that, let's really copy this and do the same thing for our width, like this, and accept that value in our width variable. So that is the first step. The second step is going to be to declare another variable which is going to hold the symbol that our user wants to use for drawing that shape. So I'm going to declare a variable of type char, and I'm going to call it symbol, like this. And let's write out a message to the user so that he knows that he should enter that symbol, like this. And let's say C in symbol. So after we have acquired all the necessary inputs from our user, which are height, width, and symbol that we are going to use to draw our shape, now we are left to write the algorithm that is going to draw that rectangle shape. So as I already said, for that we are going to use nested for loop. So I am going to set up my outer loop, the first loop, and I'm going to say for, and then I'm going to declare the counter, which is going to count the iterations of my outer loop. Since that outer loop is going to control the height of our rectangle, I'm going to say int age. So I'm going to give the age name to our outer counter, and I'm going to set its initial value to 0, like this. And then we are going to put the condition how long our outer loop is going to run. So while our age is less than height that our user has entered, like this. And then after each iteration of my outer loop, we have to increment the value of our age counter. So that would be the setup of our outer loop. And let's now set up our inner loop. So I'm going to write for, and for this inner loop, I'm going to declare another counter, which I'm going to call W, like this, because this inner loop is going to control the width of rectangle shape. So I'm going to set its initial value to 0 as well. And then I'm going to say that it is going to run while this W is less than width that our user has entered, like this. And also after each iteration, we really need to increment the value of this W. Okay, so what we are going to do in this loop, so in this inner loop, if you look at this image here, where is it? Okay, here, you can really notice that in each iteration of our inner loop, it just draws this symbol that our user has entered. So I am going to very quickly just see out. So write that symbol out. I'm going to say see out and then write out that symbol like this. And there is really one more thing that we need to put, and that is going to be after this for loop. So this outer for loop finishes single iteration. We really need to put something else at the end. So here, at the end of our outer for loop. And let's look at our image. So as you can see here, after each iteration of our outer for loop, because it is controlling height and it is really iterating through this inner for loop in each iteration of our outer for loop, at the end of that iteration of outer for loop, we really need to put empty space. So here I need to put empty space, and that corresponds to this line here. So here I'm going to write out cout end line like this. And now if I run my program, we should really expect to see the shape, that rectangle shape of dimensions that our user defines. So let's say for height 4, and then for width, let's say for example 6. And the symbol that we want to use to draw that shape, let's say that that is going to be this plus symbol. Okay, so as you can see, our rectangle has the height of 4, and then it has the width of 2, 4, 6. So it has the width of 6 of these symbols that our user has entered. Okay, so there is one more thing that I notice here, and that is going to be really to format this shape to be a bit more pretty. So for that, we are going to use the library, which is called iomanip. So I am going to include that library here. I have to say include iomanip like this. And this library here really contains a function that is called setW, which means set width, which is really going to set the width of the field that comes after it. So I'm going to put here that function. I'm going to put these redirection signs here, and then in this space here, I'm going to write out set v, so set w actually. And then here I want to put what is the width of the field that comes after this function. So what is going to be the width of our symbol field? And let's use 3 for that, for example. So if I run my program again, but let me stop it first. And if I run it again, oh no, I haven't stopped my program, so I'm going to close it. Okay, and now if I run my program, you can see that it asks height and width again. So previously we have entered 4 and 6, and then for the symbol, let's enter plus again. And now, as you can see, our shape looks much nicer because of this set width function, because it has really assigned to each symbol, to each character that our user has entered, the width of 3 fields. Okay, so let's run our program one more time, and let's say that height is going to be 5 and width is going to be 7, and let's enter another shape. So let's say, for example, minus, and as you can see, it has written out the shape, so the rectangle shape of these dimensions that our user has entered, and it has used this symbol that our user also has entered. So I hope that you enjoyed this video. If you did, make sure to subscribe to my channel and click the bell icon as well. Also, if you want me to make more videos like this, so if you want me to use programming to draw more shapes, make sure to write that in the comments down below so that I can know that you really enjoyed this video and like it as well. And thanks for watching. I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And this video is going to be sort of a continuation to my previous video in which I showed you how you can draw rectangle shape using C++. And in this video I want to show you how you can draw triangle and reversed triangle shapes using C++ as well. So if you're not familiar with how you can draw rectangle, I would suggest you to watch that video first. I'm going to link it here, because in my opinion it is a bit more difficult to draw triangle than it is to draw rectangle shapes. So one more thing, I have also created Instagram and Twitter accounts, so if you're interested in how developer life looks like. And also, if you're interested in behind the scenes of these videos that I post on YouTube, make sure to follow me on my other social media. So at True Code Beauty, Instagram and Twitter accounts. I'm going to put the link to those in the description of this video. So without further ado, let's start drawing our triangle shape. So here I have the shape that we are going to draw in this video, and that is going to be this equilateral triangle shape that I have here. And there is a couple of things that I want to explain before we start to write code. The first thing is going to be that this height, our user really has to enter this height. So we are going to let our user decide how many of these symbols are going to be on this side and this side and this side as well. And the second thing is going to be that our user defines this symbol. So whichever symbol our user wants to use in order to draw this shape, we are going to use that symbol that he enters. Those are two things that we need from our user. And then it is up to us to really think and figure out the algorithm that we are going to use in order to draw this triangle shape here. So let me explain to you how we are going to do that. So we are going to have two for loops, and those are going to be nested for loops. So if you're not familiar with for loop nesting, I'm going to link my video on that here, so make sure to watch it. So our outer for loop is the one that is going to control this height of a triangle. So in this particular case, it is going to have 5 iterations, 1, 2, 3, 4, 5. And then our inner for loop is the one that is going to control the width of this triangle. And if you really look at this triangle, you can notice that our outer for loop really goes from 1 up to the number that our user has entered. So it has 5 iterations in this particular case because our user has entered 5 for the length of this triangle, so for the length of its sides. So that is the behavior of our outer for loop. It goes from 1 up to 5 in this particular case. And then the behavior of our inner for loop is going to be the following. So in the first iteration of our outer for loop, our inner for loop has only 1 iteration. After that, in the second iteration of outer for loop, inner for loop has 2 iterations. Then in the third iteration of outer for loop, inner for loop has 3. In a fourth iteration of outer for loop, inner for loop has 4, and so on. So that means that our inner for loop goes from 1 up to the current value of the counter of outer for loop. So let's translate that into our C++ code. Let me return this picture here. Okay, so before we start to write that algorithm, I am going to create a variable which is going to hold the length that our user enters. So I'm going to call that variable length. Okay, and then let's write out a message to the user so that he knows that he should enter length like this. And let's store the value in our length variable. So that is the first thing that we need from our user. And then the second thing is going to be a symbol. So that is going to be of type char, like this. So I'm going to write out, cout symbol, like this, so that our user knows that he should enter symbol as well. And let's store that symbol in our symbol variable. So after we have acquired these two things from our user, let's translate the algorithm that I just explained into C++ code. So as I said, we are going to have two for loops. Outer for loop, which is going to have counter that I'm going to call, let's say, I. And that outer for loop, its counter goes from 1 up to the value that our user has entered, and it increases by 1 in each iteration. Okay, so I'm going to say I is equal to 1, and then I is less than or equal to length, so the length that our user has entered, and then please increment that I in each iteration. So that is going to be outer for loop, and then inner for loop is going to go from 1 up to the current value of outer for loop's counter. So in the first iteration, it is going to execute only once, so it is going to have only one iteration. In the second iteration of outer for loop, it is going to execute twice. In the third, it is going to execute 3 times, 4 times, 5 times. So how we are going to write that? We are going to say for int, and then our inner for loops counter I'm going to call j, and j goes from 1 up to the value of our I, so up to the value of outer for loops counter, and it increases by 1 as well in each iteration, and in each iteration it has to write out this symbol that our user has entered. So let's say cout symbol, like this. Okay, and then there is one more thing that I want to explain, and that is going to be after each iteration of outer for loop, really the next iteration starts in a new line. So we are going to write that here, I'm sorry. So at the end of our for loop, our outer for loop, we are going to say cout end line. Okay, and now if I run this program, it asks for length. I'm going to say that length is, let's say, 5, and then symbol is going to be star symbol. And as you can see, it has really written out a triangle that has the length 5 of these symbols that our user has entered. And there is one more thing that I want to do in order to format this shape here to be a bit prettier, and that is going to be really to add a function here which is going to assign to each of these symbols that our user enters, so that our for loop writes out width of 2 fields, and that is going to be done using a function that is called setW, meaning set width. And this function here is going to give the space of 2 fields to the symbol that comes after it. And in order to use this function here, we have to include its library, and that is going to be iomanip library. So I'm going to say include, like this, iomanip. Oh, okay. And now this underline has went away. So if I run my program once more, and I enter, let's say, for length 6, and then for symbol, I enter this symbol here. As you can see, our triangle shape looks better now. So it has the height, or actually the length, of 6 of these symbols that our user has entered, and it has also used this symbol here in order to draw this triangle shape. And there is one more thing that I want to show you. So at the beginning of this video, I promised that I'm going to teach you how you can draw triangle shape and then reversed triangle shape as well. So there is one very beautiful thing about programming, and that is going to be code reusability. And about real code reusability, you are going to learn when we learn about classes and functions. And when I make my videos on functions, I'm going to link that video here, so make sure to watch it, because functions really are one of the most important things that you have to understand, not only for C++ programming, but for programming in general. So make sure to watch that video. And let's say that for now we are only going to really adjust this code here. So we are going to modify it a little bit in order to draw this shape here. So if you look at these two shapes, you can really notice similarities. And what are those? So this inner for loop behaves about the same in both of these triangles. But there is one key difference, and that is going to be that in this triangle shape, our outer for loop counts from 1 to 5, and then in this reverse triangle, our outer for loop really counts from 5 to 1. So if we modify that, we are going to have this reversed triangle. So let me move these, and then I'm going to really copy this here. So I'm going to use Control-C and then Control-V. And then let's really add a couple of end lines between these two. Okay, like this. And then let's really modify this triangle shape that we have just explained and drawn. And as you could see on this image here, our outer for loop counts from 5 to 1, which means from the size that our user has entered from 1. So that means that if we change our outer for loop, we should get that reverse triangle shape. So it goes from length like this, and it really goes while our I is greater than or equal to 1, and then our I decreases in each iteration, so it decrements. And now if I run my program, it asks me for length. Let's say that length is going to be 5, and then symbol is going to be, let's say, this plus symbol. And when I pressed enter, we have gotten both of these triangle shapes. So this one that we have drawn first, and then this reversed triangle shape as well. I hope that now you have really seen the real beauty of programming. You learn some basics, and then you can use those basics in the most creative ways that you can think of. So I hope that you liked this video. If you did, make sure to subscribe to my channel, click the bell icon as well, so that you are notified when I publish my next video, and a lot more great videos are coming. Thanks for watching. I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to the first video of C++ functions. If you're a beginner at C++, make sure to check out my playlist on C++ for beginners, and there you can find some of the most important concepts that you will need to understand and know in order to work with C++. And in this video we are going to talk about C++ functions. So functions are one of the most important concepts that you will need to understand and use in order to be a good programmer. And that is not only the case in C++, but in most programming languages as well. The first thing that I want to explain is what is function. Function is a block of code that is grouped together, and usually that block of code solves a specific problem, meaning it performs a specific task, and that block of code is executed only when you call that function, meaning only when you invoke the function, the body of that function is going to be executed. And each C++ program contains at least one function, and that is going to be main function. So this here, and the execution of your program starts on the first line of your main function, and then it ends when it comes to this last line, so this close bracket of your main function. And also it can end when it comes to return statement, but we are going to talk about return statements later in this course. So main function is the main one, so the first one that is executed, and whatever code you put in your main function, that code is going to be executed as part of your program. So if I say here, for example, cout, and I say hello from main function like this, and let's add a new line like this, and now if I run my program, you can see that our program has written out hello from main, and that is the first function that our program starts executing. Besides from main function, you can also create your own functions, and let's explain how you can do that. So there are a couple of things that you need to know in order to create your own function, and that is going to be following. So the first thing that you need to really write when you create your own function is going to be return type of your function, and that is going to be void for now, which means that this function is not going to return anything. And we are going to talk about return types more in detail later in this course. So for now, we are going to use void return type, meaning that this function that we declare in this line is not going to return anything. And then you write out the name for your function, and let's call it function, like this. And then in these parentheses, you can put arguments or parameters that your function really receives. And for now, these parentheses are going to be empty, meaning that this function does not receive any arguments. And then in these curly brackets, we are going to put the body of our function. So this here is going to be the function that we created ourselves. and you have to specify the return type of your function. After that, you write out the name of your function. Then in these parentheses, you can put any arguments that your function receives. In this particular case, these are empty, and we are not going to send any parameters to our function. And then here is going to be the body of your function. And what we are going to put in this body, let's say cout hello from function, like this. And let's also add end line at the end of this function. So now we have really created our own function, which is called function. And if I run my program now, what do you think that is going to happen? Write that in the comments down below. So I am going to run this program. And as you can see, nothing has changed really. Our program has written out hello from main as it did before. So before we created this function. That is because, as I explained, your function is not going to execute until you call that function. So until you invoke it, it is not going to execute. So in order for our function to be executed, we need to invoke that function. And how that is done? So here in this line after hello from main, we are going to put function and then these parentheses. So this here is the invocation of our function. And now our function is going to be executed. So now if I press this play button, you can see that now our console has changed. So now we have hello from main and then also hello from function. So that is because we have invoked this function here. And you can invoke this function wherever you need it. So you can, I have invoked it after this line here, but you can invoke it as well before this line here if you need to and if you want to. So now if I run my program, you can see that it first says hello from function and then it says hello from main, because this function has been invoked first and then we have written out this line of code here. And that you can see in this console window. And let me show you one thing. So I'm going to return this after this line of code, the invocation of our function. I'm going to return here. And now I'm going to take this code here, so this definition of our function, and I'm going to paste it after our main function. And let's see what is going to happen now. So let me delete these blank lines. And now if I run my program, you can see that our program has failed to build. So we have compile time errors. And in this window here, in this error list, you can see that it says function identifier not found, which means that this function here is really, our compiler does not understand what this function is, because C++ code is executed from top to bottom. And when it comes to this line here, so when it comes to the invocation of your function, it is really not familiar with this function. It does not know what this function is. So you have to either put this code before your main function, as we did before, or you have to do other thing, which is really the recommended way to create your functions, and that would be to create definition and declaration of your function. So what are definition and declaration of function? Declaration of function is going to be really this here. So I'm going to copy this and put it before our main function. And this declaration of function is going to tell to your compiler what is going to be the return type of your function, what is the name of your function, and then if there are any parameters that your function really receives, you are going to put those in these parentheses here. So that is going to be declaration of your function. And that part, declaration of your function, goes before your main function. And after that, you are going to write the definition of your function, and the definition of your function is going to go after your main function. And in that way, you are going to make your code more readable, meaning that when someone else comes to your code, and if your code had 200 or 300 or 400 lines of code, then it would be really hard to read that code. And for someone it would be really hard to manage and go through your code. So he is going to find it much easier if he has all the declarations of your functions before your main function. And then if he needs to read a specific definition of a function, he can right-click the name of that function and click Go to Definition. And then he is going to be taken to the definition of your function, so the specific one that he needs to read, so that you don't bombard that user with all the functions, all the definitions of the functions that you have in your program. And in this particular situation, it is only one function, but your program is going to consist usually of more than one function, and that is really unreadable when you find a lot of definitions of a functions before your main. So you can right click on your function and say go to definition, or you can press F12. So you can click on your function and then press F12, and you are going to be taken to the definition of your function. Okay, so this here is the recommended way to create functions. And now if I press play button, you can see that our program has executed, actually has written out the same as it did before. So we have really removed that error that we had when we moved this definition of a function after our main, because we have added this declaration of a function before our main function. And there is really the most important thing that I want to mention in this video, and that is going to be what is the reason why functions exist. Okay, so we have seen that they make your code a bit more readable, so they group the parts of your code together so that you can manage your code easier. And the most important characteristic of functions is that they make your code reusable, meaning that you can write a specific code once, so you can solve a specific problem once, put the solution, the algorithm, the code for that problem in a function, and then you can really invoke that function however many times you need it. So here I can really copy this and then paste it, let's say 3 times if I needed it. And then if I run my program, you can see that this function has been executed 3 times here. And that is really the most important thing about functions, which means functions make your code reusable. You don't have to write the same code over and over again. And you should really try to group your code in functions so that each function does a specific task, nothing more than that. And in that way, you are going to make your code easier for yourself and for other people as well that are going to read your code. So I hope that you understood what functions are and how they are used. And we are going to talk about functions in more detail in my later videos. So make sure to subscribe to my channel and click the bell icon, because only then you are going to be notified when I publish my next video. And also follow me on my other social media platforms, so Instagram and Twitter accounts through Code Beauty. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ functions. In this video I wanted to talk about function parameters or arguments. And the first thing that I want to explain is what are parameters, so what are arguments. Sometimes a function needs to receive a certain value, a certain variable, and then perform a certain task on that value, so on that variable, or it really needs the value of that variable in order to perform a certain task. So let's explain how we are going to create a function that receives a parameter in C++. So here I'm going to add a function of return type void, and I'm going to say that that function is going to be called, let's say, introduce me, like this. And then in these parentheses here, we can put parameters that our function is going to receive. And after that, in these curly brackets, we are going to put the body of our function. So, as I said, in these parentheses here, we are going to put parameters, and they are specified in the following way. So first, you are going to write out the type of your parameter, and that is going to be string, like this. And then we are going to specify the name of our parameter, and that is going to be, let's say, name. So we want to pass in this function that is going to introduce our user, we want to really pass the name of our user. And then what our function is going to do, we are going to put in these curly brackets here. And that is going to be really to introduce our user. So our function is going to write out cout, let's say my name is, and then let's write out this name that we have received in this function. So I'm going to say name, and I'm going to add end line like this. Okay, so this is the way to pass a parameter, so to pass a value to your function. And as I said in my previous video, you can really separate this declaration and definition of a function. So you can put really declaration of your function here, so before your main function, and then you can put definition of your function after your main function. And if you don't know how to do that, make sure to watch my first video of this playlist. Okay, so now I want to invoke this function here. And how we do that? Well, we specify the name of my function. So I'm going to say introduce me, and then since this function receives argument, so since this function receives a parameter here, we really have to pass that parameter to our function, and that I'm going to put here. So here I'm going to pass an argument to my function. So I'm going to say Saldina like this, and this here really is called argument, so it is a value that we pass to our function, and then here it is called parameter. Okay, so now if I run my program, you can see that my function has successfully introduced me. So it says my name is Saldina like this. Okay, so here we have really defined our function. So the parameters that our function receives, name, return type, and then the block of code that our function is going to execute. And then here we have invoked our function and passed an argument, which is this string of text here, to our function, which is going to be received in this name variable. And then our function is going to really treat it as a variable, which means that it is going to write that value here. Okay, and now if I try to invoke this function once more, so I'm going to copy this line and then paste it here, and let's say that I'm going to pass it a different value. So I'm going to say, for example, Anna. Okay, you can see that now our function has successfully introduced two users. So it has said my name is Saldina, and then my name is Anna. And there is also another thing that I want to explain, and that is going to be how you can pass multiple arguments to your function, and that is going to be in a following way. So here in these parentheses where I have specified my first parameter, you can put comma sign, and then you specify your second, third, fourth, fifth, and your other parameters. So you specify the type, which is also going to be string in this particular case. And let's say that my second parameter is going to be called city, like this. And let's add another one. So let's say int age, like this. So now in this function, I'm going to write out also where is my user from, and also how old my user is. So I'm going to write out cout, I am from, and then let's write out this city that we have passed in this function, and add also end line, and let's write out also I am age, so I am however many years we have passed in this function, and then let's say years old, like this. Okay, so now we have really introduced our user in more detail, and we have passed to this function name, city, and age information for our user. But as you can see here, our function, so our compiler really says that this function is not valid. It has too few arguments in a function call, meaning that this invocation, this call of a function, does not really contain all the necessary parameters or all the necessary arguments that we need to pass to our function, which means that it really lacks this city and age parameter. So here I'm going to put comma as well, and then I'm going to specify my city. This here is bolded, so it is bold, and that means that we have to really pass a city value to our function. So I'm going to write out Mostar like this, and then I am also going to specify age. So I'm going to say 25. And let's do the same for our Anna user. So I'm going to say that our Anna is from New York, and let's say that she has 27 years old, for example. So now when I run my program, you can see that we have successfully introduced two users. So my name is Saldina, I am from Mostar, I am 25 years old, and then also my name is Anna, I'm from New York, and I'm 27 years old. Okay, so, and we have really written this code only once, and then we can reuse it however many times we need to. So in this particular case, we have used it 2 times. Okay, and another thing that I want to explain is going to be a default parameter. So what is default parameter? Sometimes you really don't want to pass a value to your function, meaning that in a specific situation you don't have that value or you don't want to pass it, and in that case you want to define default value for your parameter. So in the case where your user does not pass that argument to your function, for example, you can say that your age parameter here has the default value of 0, okay, and that means that you don't really have to pass this age parameter anymore. So here I'm going to delete this age for my Anna user, and let's run our program now in order to see how this function is going to behave for this first user, and then also to see how it is going to behave for this second user which did not specify this age parameter, so this age argument. And when I run it, you can see that my first user has been introduced as it was previously, so I am 25 years old, and then the second user, which did not specify age argument, it really said I am 0 years old, meaning that our function has really taken this default value and it has written out I am and then this default value and then years old. Oh, we are missing S here. Okay, so I'm going to add S, and I want to do a following thing. So in the case where our user does not pass this value for our age parameter, I'm going to really check whether we have that value or we have this default value. And then in the case where we have only this default value, I don't want to write this line of code here. So I am going to say here, if age is not equal to 0, meaning that our user has specified some other value which is not 0, then and only then we are going to write this line of code. But in the case where we have only this default value, we do not really want to write out that our user has 0 years old, because that does not make sense. Okay, so as you can see now, my first user has been introduced as I am 25 years old, and then my name is Anna, I am from New York. Since Anna did not specify how old she is, we haven't written out her age here because of this check that we have added. Okay, so that was about default parameter, and there is one thing also that I want to say about this default parameter, and that is going to be really, if I delete this is equal to 0 and then I try to assign default value to this city parameter, so I say, let's say that city is equal to default like this, you can see that the compiler is really underlying this function, and it says, okay, it says default argument not at end of parameter list, meaning that you can specify default argument only at the end of this list. So if you want to specify default value for this parameter, you will have to specify a default value for this one as well. So if I add default value here, so I have added 0, then we can really add a default value for this second parameter, and then we can add default value for this one as well. And now we are really left with, so our compiler is not underlying this introduce me function name anymore. Okay, and this does not make sense, so I'm going to delete it, but I wanted to explain that you cannot specify default value for your middle parameter if you did not specify a default value at the end of your parameters list. And there is one more thing that I want to show you, and that is going to be that you don't have to hard code these values as we did here. So I'm going to comment these out, and then I'm going to let my user define his own values for these three variables. So I am going to declare two variables of type string, which are going to be name and city. And then also I'm going to declare a variable of type int, which is going to be called age. And then I'm going to say cout, so please enter a name, like this. It's not capital letter, okay. And then cin name, and then cout city. So after my user has entered name, I want him to enter city. So cin city, like this. And then also I want to enter age and cin age, like this. So now after my user has specified these three variables, so name, city, and age, I can pass these three in my introduce me function. So I can say introduce me and then pass name and city and age, like this. And if I run my program now, as you can see, my program really asks me to enter a name. So let's say that name is going to be Tom, for example. And then let's say that city is going to be London. And age, let's say 32. Okay. And now, as you can see, my function has successfully introduced Tom. So it says, my name is Tom, I am from London, and I am 32 years old. Okay. And you don't really have to use these names for the variables in your main function. So the names of these variables here do not have to be the same as these names here. So you can call these, for example, name 1, city 1, age 1, but you are going to have to use these names in your main function. So you will have to say name 1, city 1, age 1, and here as well. But these names do not have to be the same as these names here. Your program is going to work correctly. You have to, however, have the same type here and here. So this here has to be string if it has been declared as string here, and this one as well. And then age also has to be of type int if it has been declared as int here. And once more, if I run my program, you can see that it asks for name, so Tom, New York, and then age is going to be 22. And as you can see, my name is Tom, I'm from New York, I am 22 years old. So your program works just fine. So I hope that you have understood how parameters behave in a function and how you can pass multiple parameters to your function, and also how you can specify a default parameter in your function. And if you enjoyed this video, if you learned something new, make sure to subscribe to my channel, click the bell icon so that you are notified when I publish my next video. Also like it and share it with your friends. And follow me on my other social media, so Instagram and Twitter accounts, True Code Beauty. Thanks for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel, welcome to another video of C++ functions. In this video I wanted to talk about return statements and return types of a function. So what is return type of a function? Well, return type of a function can be any data type that can be used in order to declare variable. So it can be int, float, bool, char, double. It can be any user-created data type, and it can be void as well, which means that that function is not going to return anything. And as we explained in one of my previous videos, function is a block of code. It is a code that is grouped together, and that code is going to perform a specific task. And here I want to make a difference between functions that return value and functions that don't return value. And functions that don't return value can be, for example, an example of a function that does not return value can be a function that writes out a menu to your user. So you call that function writes out a menu to your user, and the job of that function is done there. So you are not expecting any value to be returned from that function. But an example of a function that returns a value can be a function that performs a specific calculation, let's say on arguments that you pass to that function, and after that calculation is performed, you are expecting a certain value, so result of that calculation, to be returned from that function. And an important thing is that function can return only one value. So only one return statement inside your function is going to be executed. And I'm going to show that on the example that we are going to do in this video. And now I'm going to show you really how functions make your code easier to read, easier to understand, and how they make your code reusable. So we are going to show that on an example, which we are going to first make without using a function. So we are going to make a program that is going to determine whether a number is prime number or not, and we are going to do that first without using functions, and then I'm going to refactor that program so that it uses functions, and then I'm going to show you how that program becomes instantly more readable, more understandable, and also how that makes your code reusable. So as I said, we are going to create a program that is going to determine whether our number is prime number or not. And the definition of a prime number is a number that is divisible only by itself and by 1. So if that number is divisible by any other number, so not 1 and not itself, but any other number, that means that that number is not prime number. So the first thing that I'm going to do here is I'm going to declare a variable of type int, call it number, and then I'm going to let my user enter that number. So I'm going to write out the message to my user and then use the cin command in order to get that number and store it in my number variable. And then let's explain the algorithm that we are going to use in order to determine whether that number is prime number or not. The definition of a prime number is a number that is divisible only by 1 and by itself, which means that if you can find any other number besides 1 and that number itself that you can use to divide it by this number that our user has entered and get the remainder of 0, that means that this number is not prime number. So how we are going to solve this problem? Well, we are going to iterate through all the numbers between 2 and this number minus 1, and then we are going to check whether this number is divisible by that counter value. So I'm going to write out for int I is equal to 2, and then I is less than number, and in each iteration I want to increase the value of my I counter. So why haven't I used 1 here, and why haven't I said here that this I is less than or equal to the number? Because every number can be divided by 1, so we do not need really to check that. And also every number can be divided by itself, and we do not need to check that as well. So here we are going to iterate through this interval, so between 2 and while I is less than that number that our user has entered. And here we are going to check whether this number that our user has entered can be divided by any value of our I, so in any iteration which we are going to go through. And in the situation where it can be divided, we are going to use a flag, which I'm going to declare here. And that flag is going to be of type bool, and let's call it is prime flag, like this, okay? And this flag is initially going to be assigned a value of true. So we are going to initially say that all the numbers are prime numbers, and then we want to prove that wrong for the numbers that are not. So we are going to use this flag in a following way. Here I'm going to check in each iteration if our number that our user has entered can be divided by that current counter, so by the current value of I. So I'm going to use this modulo operation, and I'm going to say if this number modulated by I is going to give us the result of 0. So when you divide this number by I, do you get the remainder of 0? And if this operation here results as true, we are going to say that our is prime flag is going to be false. So we are going to assign the false value to our is prime flag, because we have clearly found one number which is not 1, and that number itself that can be used in order to make this condition true. So here I'm going to write out is prime flag, and then I'm going to assign it a value of false. And then another thing is going to be really if we find one number, so even one number is enough to find that really fulfills this condition here in order to say that our number is not prime number. And in that situation, we do not really need to check any more numbers, because we have determined that our number is not prime number. So here I can use break statement. So I can say, if you find only one number, please do not iterate through this for loop anymore, because we do not need to find any more numbers. So in this situation here, we have iterated through all the numbers between 2 and that number that our user has entered. We have checked whether that number can be divided by any value of our I counter. And if it can be divided, meaning that it gives the remainder of 0 after that division, we are going to set our prime flag to false, and we are going to break from our for loop. And after we have successfully fulfilled this, so after we have successfully iterated through this for loop, or we have fulfilled this condition in one iteration, we are going to leave our for loop, and we are going to come to this line of code here. And here I want to check what has happened with my is prime flag, meaning I want to check whether this is prime flag has stayed true, which means that our for loop has executed all of its iterations, and it has not found any number that can be really used to fulfill this condition here. And in that particular situation, that flag is going to stay true, and that is going to mean that our number is prime number. So here I'm going to write out if is prime flag, meaning if this value here, if this variable here holds the value of true, we are going to write out cout like this, and we are going to write out prime number like this. Okay, and let's also add end line here. But in a situation where this here does not hold a value of true, that means that in one iteration, so it can be the first one, it can be the last one, it can be any in between, we have really found at least one number that can be used to fulfill this condition and that has set our is prime flag to false. And in that situation, we are going to use our else statement, and we are going to copy this, and we are going to really modify it to say not prime number, like this. Okay, so now if I run this program, you can see that it asks us to enter a number. I'm going to enter a number, let's say 5, for example, and it says that 5 is prime number, which is correct. 5 is a prime number. And let's run it one more time, and let's say that we want to check 6 this time, and as you can see, our program has written out that 6 is not prime number. And 6 really is not prime number because it is divisible by 2 and by 3, besides from 1 and itself. Okay, so now you have seen how we can really solve this problem, and let's try to refactor this program here in order to use functions. So how we are going to do that? Well, the first thing that we need to do is we need to create a function, and I'm going to do that here. And since this part of code here, this is the part of code that we are going to move to our function, and since this part of code here determines really whether our number is prime number or not, and then sets this flag to true or false, let's say that we are going to create a function which is going to check as well whether the number is prime number or not, and then it is going to return a value true or false meaning the number is prime number or the number is not prime number. And that we are going to write here. So here I'm going to put the return type of my function, and that is going to be bool. So that is the return type of my function. And then the name for my function is going to be is prime number, like this. And then let's say that we want to pass an argument to that function, and that argument is going to be of type int. And that argument is going to be really the number that we want to, check. So we are going to pass the number to our function. That function is going to, in this body here, check whether that number is prime number or not, and then it is going to return bool value, meaning true or false. So if the number is prime number, it is going to return true, and if the number is not prime number, it is going to return the value of false. And how we are going to do that? Very simple. So you see this code here. I'm going to comment this code here, and I'm going to really, no, I should have copied it before. So I'm going to copy this code here, and I'm going to move it to my function, okay? And we have previously explained this code here, so we do not need to explain it again. But what I'm going to say here is after this algorithm is done, so after we have really stored the value of true or false, so we have stored the value of false in our isPrime flag, or we have really kept this true value inside our isPrime flag, what we need to do is we really just need to say return isPrime flag, like this. So after we have checked whether our number is prime or not, we can really just return that value from our function. Okay, so we can now, after we have moved this code to our function, we can delete it from here, like this. Okay, and then as you can see, we have been left with this isPrime flag, which is not declared now. So identifier isPrime flag is undefined, meaning that now we have to really declare it, and we have to assign it a value. So I'm going to say here bool is prime flag, like this, and then the value that I'm going to assign to my isPrime flag variable is going to be whatever value our function returns. So here I'm going to say please call my function is prime number, is prime number, like this. Okay, and then pass to that function this argument here. So our function expects a value, and that is going to be this number that we want to check whether it's prime or not. And then after this function here is done, it is going to return a value of either true or false, and that value is going to be stored inside our isPrime flag variable. Okay, so now if I run my program, you can see that it asks us again to enter a number. So I'm going to say let's check number 9, for example, and it says that number 9 is not prime number, which is not, because it is divisible by 3. And let's check number 13, for example, and 13 is prime number. Okay, so after we have really used this function in order to perform this particular task, I want to show you one more thing, and that is going to be how we can refactor this function here in order to make it even more simple. And if you look at this function here, you can see that this isPrime flag is set to true here, and then in this situation where we find number that can be used to fulfill this condition here, we set that isPrime flag to false, and then we use this break statement in order to break our for loop. So we are not going to iterate anymore through our for loop when we come to this break statement. And then we really go here, and then we return that isPrime flag. But we can do that in a more simple manner, and that is going to be really here. So here, in a situation where we find number that is really fulfilling this condition here, we can say at this very line of code, we can say return false, like this, because this and this code here we can delete. And why I can use this return statement? Because this return statement is going to really break our for loop, and it is going to return the value from our is prime number function, meaning it is going to do two things. So we do not really need to set the flag and then return the value of that flag at the end, but we can really say, if you find any number that can fulfill this condition, return false immediately. So break for loop and also return the value from our function, meaning end the execution of that function because we have found our result. And then here as well, we do not really need to declare this is prime flag to true and then return it because it is clearly true. So we can say here, return true, and then remove this flag from here, like this. And then as well, I can remove these curly brackets and make my code even more readable. So now I want to explain what we have done. So here we are passing a number to our is prime number function. Then we are iterating through all the numbers between 2 and that number. We have skipped 1 and that number itself because all the numbers are divisible by 1 and by that number itself. And then we are checking whether any of these I values between 2 and number fulfill this condition here. That would mean that that number is divisible by that current value of I, and that would mean that our number is not prime number. So at that very moment we can say, please return false, because this number is clearly not prime number. But in a situation where this for loop has really iterated through all of its iterations and it has not found any number that fulfills this condition here, that means that this return false statement has not been executed. And then in that particular situation, this return statement here is going to be executed, and this return statement here says return true. Okay, so this part of code here has not changed, nor it is going to change. And if I run it again, you can see it asks me to enter a number. I'm going to enter number 7. Then it is going to check whether that number is prime number. So it is going to call our function and assign the result of that to our is prime flag variable. And I press enter here. You can see that we get the result prime number because 7 is prime number. Okay. And that is really making your code much more readable and reusable as well. So this main function here is much more clean than it was before. And now I want to show you the most beautiful thing, and that is going to be how we can make this is prime number function reusable. So let's say that I am going to delete all of this code here. So I'm going to delete it. And now I know that I have written out this is prime number function, and I know that I can really invoke this function and use it whenever I need to determine whether some number is prime number or not. So let's say that now we want to check all the prime numbers between 1 and 1,000, for example. So how we are going to do that? Well, we are going to iterate through all the numbers between 1, so I is equal to 1, and then I is less than or equal to 1,000, and increase our I in each iteration by 1, like this. And then in each iteration, I really am going to just send this I to my function, and I'm going to really get the result from this function. So this function is going to tell me whether that I is prime number or not. So here I'm going to declare a variable of type bool, and I'm going to call it is prime. And I'm going to assign to that variable a value of is prime number when I pass it the value of I. So whatever this function here returns, whatever this function here results in, I'm going to assign that result to my is prime variable. Okay, and now what I want to write out is all the numbers that are prime numbers between 1 and this 1,000 value. So I'm going to say if is prime, like this. I'm going to write out cout, and then I want to write out the current value of my I counter, because that is a number that we are talking about. So I is prime number, like this. Okay, and I'm going to add a new line at the end. So this code here is really going to check all the prime numbers between 1 and 1000, and it is going to write out all the prime numbers in that interval. And for solving this particular problem, so whether the number is prime number or not, we have used this is prime number function, which we have written once, and we have really tested it once. We know that it works as it should, and now we can really close it. We do not need to really think about how we are going to perform this task, never again. So we have written it, we have tested it, and now we have this algorithm stored in our is prime number function, and we know that this function works in a following way. So we pass it a value, and then this function returns us true or false variable, meaning that the number is prime number or not. So once more, if I run my program, you can see that we have gotten the expected result. So we have gotten all the prime numbers between 1 and 1000, okay, and there are a lot of numbers, okay. So you can check these numbers on your calculator if you want. And let's say now that we really want to check all the numbers between not just 1 and 1000, but let's say 1 and 10,000 or 100,000. Okay, we can call just this is prime number function, pass it the value of our I, and then check the value that this function has returned. And this function has really told us whether the number is prime number or not, and if the number is prime number, we just want to write that number out to our user. So if I run this function again, you can see that it is writing out all the prime numbers between 1 and 100,000, and there is a lot of numbers again. So you can even count how many prime numbers there are in this interval, so between 1 and 100,000, and let's say that I'm going to leave that part to you. So if you want to really upgrade this program so that it counts how many prime numbers there are in this interval, you can write that code in the comments down below, and I'm going to check it, and as well you can leave it for other people to see and use if they need it. So I hope that you have understood this return type of a function, and in this particular situation it was bool type, but you can have as a return type from your function, you can have any other data type. So you can have float, char, int, string, whichever data type you can really use in order to create a variable. You can use that data type in order to be a return type of your function. So in this particular situation, I wanted to show you an example of a bit of a more complex function, let's say, that is going to determine whether your number is prime number or not, and it is going to really receive that number that you want to check as an argument, as parameter, and then it is going to return only true or false, meaning that number is prime number or that number is not prime number. And once you have written this code and once you have tested it, you do not really need to bother with this function anymore. You do not need to remember this code, nor read it, nor even understand it in order to use this function. Only in a situation where you have a bug, and that bug is in this particular function, only in that situation you are going to need to really reread this function and fix that bug. In any other situation, you can really just use this is prime number function. And as well, we could have made other functions with other return types. We could have created, for example, a function that is going to sum two numbers. So you are going to pass to a function two numbers, let's say number A and number B, which your user enters, and then that function is going to sum those two numbers, and it is going to return the result to your main function from where you are going to invoke that function. And as well, I can leave that to you, so you can really practice writing functions on that example, for example, and you can put the code for that exercise in the comments down below as well, and I'm going to check it. And in this particular example, as I said, I wanted to show you a bit more complex example so that you can really understand why we need functions and why they make our code understandable and reusable. And if someone else comes to your code now and he sees that he has is prime number function, he does not really need to open this function and read how this function works. It is pretty clear from this declaration itself that this function receives a number and determines whether that number is prime number or not, and returns that true or false back to the invoker, back to the function that called, that invoked this is prime number. Okay, so I hope that you liked this video. I hope that you enjoyed watching this video. If you did, make sure to like it, and also subscribe to my channel and follow me on my other social media. So Instagram, Twitter account at TrueCodeBeauty. The link is going to be in the description, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another C++ functions video. And in this video I want to talk about a concept that is related to functions, which is function overloading. So I want to first explain what function overloading is. It means that you can create multiple functions with the same name, but those functions are going to have different parameters. So here I have opened my Visual Studio, and let's create a function which is going to be called, for example, sum, and I'm going to put the return type of that function to be int, so integer. If you're not familiar with function return types, I'm going to link that video here, so make sure to watch it. So first thing, we write the return type of our function, and then we write the name of our function, and as I said, our function is going to be called sum, and then I want to pass parameters to this function, so I really want to declare which parameters this function is going to receive, and those are going to be two parameters. The first one is going to be integer, and I'm going to call it a, and then the second one is also going to be integer, and I'm going to call it b, like this. So this is going to be our first function, and let's also say that we want to create another function which is also going to be called sum, but this time it is going to be of return type double, like this, and then I'm going to call it sum, as I already said, and this function is going to receive two parameters as well, but those are going to be of type double. So I'm going to say double a and then double b, like this. Okay, and as you can see, these functions are underlined because it says function definition for sum not found, meaning we have declared our functions here, but these functions are missing the definition. So definition is missing for this function and then this function as well. And let's also create one more function. So I'm going to say, for example, float, and then I'm also going to call it sum. And let's say that this time I'm going to give it three parameters. So I'm going to say float, let's say float a, and then float b, and then float c, like this. Okay, and then what I want to do is I want to create definitions for these functions, which I'm going to do here. So the first one that I want to define is going to be this one here. So I'm going to copy its declaration, and then I'm going to add these curly brackets, and here I'm going to put a definition for this function. So let's say that I'm going to create a variable of type int, and I'm going to call that variable result, like this, and I'm going to assign it the result of a plus b, like this. And then what I want to do is return this result from my function. So here I'm going to say return result, like this. So this would be one way of returning the result from your function. And then another way to do the same thing is going to be to say really return here. So instead of creating a variable that is going to hold this result, you can really return this result itself from your function. So you can say here return a plus b, and now we can delete this line, and as you can see, this function became shorter and more readable. So now I want to define this function here, so I'm going to say double, okay, I should have copied this, and then double b as well, like this. So here I want to put the definition for this function here, and this function, oh, I'm missing the name for my function. It is called sum. So this is return type, this is the name of our function, and then these are parameters of our function. And here I want to say return a plus b as well. But this time our a and our b are going to be of type double. So in this situation there were integers, and then in this situation there are decimal numbers. Okay, and let's also create a definition for this function here, so this float function, and this time I'm going to copy it, Okay, and I'm going to add these curly brackets, and here I want to write return and then a plus b plus c, like this. Okay, so now how we are going to test this, we can call these functions, we can invoke these functions here in our main function. And the first one that I want to invoke is going to be our end function. So I'm going to say cout, and then this line of code is going to really write out whatever our function returns. So I'm going to say, please write out whatever my sum function returns. And then I want to pass to my sum function two numbers. And those two numbers are going to be two integers. And as you can see here, we have really help from our IntelliSense, which says you have three possible functions that you can call. So you have overloaded three functions, and you can navigate through these using your arrows. So the first one is going to be our function that has float return type, and that function receives three parameters of type float. And then the second one is going to be the one that has return type double, and that function receives two double parameters. And then the third one is going to be the one that returns integer, and that function receives two integer values. So here I want to call our integer function, and I want to pass to that function 4 and 3, for example. And let's also add end line like this. And now if I run my program, we can expect to see the result of this line of code here. And as you can see, the result is 7, meaning that our function has been invoked, and then this line of code has received the result of summing these two numbers, and that has been written out in our console, and the result of summing 4 and 3 is 7. Okay, so now I'm going to stop this console, and I want to test these other two functions. So I'm going to say cout, and let's test our sum function that receives two double parameters. So it is going to be this one here. So I'm going to say 4.4 and then 3.3, for example, and I'm going to add end line at the end as well. Okay, and now if I run this program, you can see that our second line is 7.7, meaning 4.4 plus 3.3 is going to be 7.7, which is correct. So we have successfully tested this function here, so this double function that returns double and receives also two double parameters. And then let's also test this third function. So here I want to say cout sum, and then here I want to pass three parameters. The first one is going to be, let's say, 4.4, and then the second one is going to be 3.3, and then 3 decimal point 3.3, and then the third one is going to be 2.2, for example. Okay, now this invocation should invoke this float function. So when I run my program, as you can see here, this third line contains the result of summing these three numbers, and you can check this out using a calculator, but this is the correct result. So as I already explained, this represents function overloading, and we have created three functions. The first one is the one that receives int types and returns int type as well. Then the second one receives double, so two double variables, two double parameters, and returns double as well. And then the third one really contains three arguments, so three parameters, but it has the same name as these previous two. And then it returns float type as well. And then now when we invoke those functions, we can really pass different data types, and depending on those data types, we are going to call adequate functions. So in this first line, we are going to invoke this, and then in this second line, we are going to invoke this, and then in our third line, we are going to invoke this. Okay, so I hope that you understood what function overloading is, and also I hope that you have understood that you don't have to create functions with different names when they are doing almost the same thing. So these three functions, these three are doing the same thing. They are summing the numbers that we pass to them. Only in this particular situation, the first one is summing integers, the second one is summing decimal point numbers, and then this third one really sums three numbers. And we have overloaded this sum function, And we didn't have to create functions that are, for example, some int and then some double, and then some float, like this. So we didn't have to name these like some int, some double, and some float, but we can use the same name as long as we have different parameters, different number of parameters, different return type, or something similar. In that particular situation, our compiler is going to decide on its own which function it should call. I hope that you have understood what function overloading is and how you can use that. Thanks for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. Now in this video, I want to show you how you can build an ATM application. And the first thing that I want to do in order to build this application is going to be to plan the functionalities that this application is going to have. So I'm going to put a comment here, and then here we are going to write all the functionalities that our ATM is going to have. So the first one is going to be to check the balance. So I'm going to write that. So check balance. And then another functionality is going to be to deposit money. So let's say deposit like this. Okay. And then what else? Well, we should be able to withdraw money as well. So let's write that. Okay. And I definitely want to show the menu to my user. So I'm going to write that as well. So I'm going to say show menu like this. Okay. Now, after we have written these functionalities that we want to implement, the first one that I want to implement is going to be this show menu function. So I'm going to put the code for this show menu functionality in a function, and let's create that function here. So I'm going to say void. It is going to be of void return type. Let's call it show menu like this. Oh, like this. Okay. And then what I want to do here is I want to write out the menu to my user. So I'm going to say cout, and then let's add these star symbols. 4, 5, 6, 7, 8, 9, 10. That is going to be enough. Like this. And then I'm going to copy this on the other side so that it looks proportional. Okay. And then the first option that I want to write out to my user is going to be, let's add first and then check balance. So that is going to be the first option that our user can choose. And then let's add a couple more of these. So the second option is going to be deposit. So I'm going to write that like this. And then the third option is going to be to withdraw. So I'm going to copy this here and then paste it here. Okay, and then let's add these star symbols at the end of our menu like this. Okay, now after we have created this show menu function, what I want to do is I want to invoke this function. So here I'm going to say show menu like this. Okay, and if I run my program, as you can see, we have this menu shown to our user. Now, what should happen next is we should allow our user to choose one of these three options. So the next thing that I will do is I will create a variable. So let's create it here. Let's say int, and that variable is going to store the option that our user chooses. So I'm going to call it option like this. And then here, after I have written out this menu, so this menu here to my user, I'm going to say cout, and then please choose an option or whatever message you want to show. So option like this. And then I want to accept the value that my user enters in this option variable. So I'm going to say cin option. like this. Okay, now if I run this program again, as you can see, it asks for option, and if I select any of these three options, if I press 3, for example, you can see that my program closes because we haven't written any code after this line here. So what I want to do now is I want to handle these three options, and I'm going to handle these three options using a switch case. So I'm going to write switch, okay, and then here I want to put this option variable, so that is going to be the value that I want to check. So I'm going to say switch option, and then in the case that our user has entered option 1, what I want to do is I want to write out the balance to my user. And in order to do that, I'm going to create a balance variable because we do not have a balance variable yet. So I'm going to give it a type double, like this, and call it balance. Okay, and let's assign it initial value of, for example, 500. Okay, so that is going to be the initial value of our balance variable. So here I'm going to say cout, and then let's say balance is, okay, and then let's write out this balance variable, and I'm going to add this dollar symbol at the end, and I'm going to add end line as well. Okay, so that is going to happen in the case that our user enters value or option 1, and I'm going to add break at the end of each case, so here as well. Okay, now our second case is going to be when our user enters option 2, like this. So in that second case, we should allow our user to deposit money. So here I'm going to say cout, and then let's write out deposit amount. So we want to ask our user how much money he wants to deposit. So in order to accept the value that our user enters, I'm going to create a variable which I'm going to call deposit amount. So let's create that variable. It's going to be of type double, and it is going to be called deposit amount, like this. And then I'm going to accept the value that our user enters here in my deposit amount variable, like this. Okay, and now what I want to do with this deposit amount is I want to add it to my balance. So I'm going to say balance is now going to be equal to whatever my balance was previously holding plus this deposit amount, like this. And then let's add break at the end as well. Okay, and then our third option, our third case is going to be when our user wants to withdraw money. So I'm going to copy this case here and then paste it here. And here I want to write out a different message to my user. So I'm going to say withdraw amount. Let's copy this. Okay, and then this variable, I'm going to call it withdraw amount, like this. Okay, and then here I want to enter that withdraw amount. And what I'm going to do with my balance in that situation is going to be I want to subtract that withdraw amount from my balance. But I want to subtract that withdraw amount only in a situation where this withdraw amount is equal to or less than this balance. So I'm going to say here if withdraw, where it is, withdraw amount is less than or equal to balance, like this, then I want to give that money to my user. Else, meaning if our user has requested more money than he has, I'm going to write out a message. So I'm going to say not enough money, like this. Okay, and that is going to happen, so this code here is going to happen in the case that our user enters option 3, which is this one here. Okay, so now if I run my program, you can see that it asks option, and let's say that we want this first option, so this check balance, and it says that balance is 500. And if I press anything else, as you can see, my program is going to close. And that is because we haven't implemented any loop that is going to iterate this code here. So let's add that loop now. So here I'm going to say do. So do while loop is the one that I want to use. And then inside my do while loop, I'm going to put all of this code here. So let's add a curly bracket, close curly bracket at the end, like this. And then I'm going to say, please do this block of code here, while, and then I want to do this code here while the option that my user has that my user has entered is not equal to 4. And when my user enters option 4, we should stop the execution of our program. So in order for our user to know that 4 means exit, we are going to write that here in our show menu function. So here I'm going to add this fourth option, which is going to exit our program like this. Okay, now if I run this code, you can see that it says that it has this menu here, and then it asks for option. So I'm going to enter option 1, for example. Okay, and this option 1 says that balance is $500. Now let's enter this second option. Let's enter this deposit option. So I'm going to press 2, and as you can see, it says please enter deposit amount. So let's say that I want to deposit $700, for example. Okay, now if I check my balance again, so I have entered this option 1, and then I press enter, as you can see, it says that my balance is $1,200. And there's one thing that I want to do with this program, because I don't like the way that this looks. It is not really readable. So I'm going to add clear screen, so clear console command, and I'm going to add that here. So after my user chooses his option, I want to clear the console. So I'm going to say system, and then let's add CLS, which is a command that is going to clear my console, clear my window. So if I run my program again, as you can see, again, we have this menu, and then it asks us for the option. So let's say that I want to check my balance. It says that my balance is $500. Now let's try to withdraw money. Let's say that I want to withdraw money, and I want to withdraw $600, for example. And then it says not enough money because we had $500 on our account. So now what I want to do is, let's say, for example, that I want to deposit $100, okay, and then I want to withdraw $600. Okay, and if I check my balance now, as you can see, balance is 0. And in order to test this exit functionality, let's press 4, and then if I press enter, as you can see, my application is going to close. Now another thing that I want to check is going to be what is going to happen if our user enters option that is not valid, meaning an option that is not any of these 4 that we have covered here. So if I run my program again, as you can see, it asks us to enter options. So I'm going to enter option 5, for example, which is not valid, and nothing has happened. If I enter option 9, nothing has happened again. 99. Okay, now you get the point. What is happening here is our program tries to find this adequate option. So option 5, option 9, whichever one we have selected. And since that option does not exist in these cases here, our program continues to this while check, and then it checks that the option is not equal to 4, and because our option is 5 or 9 or 99, which is not equal to 4, then our do while iterates again, and then it writes this show menu again, and then it asks us to enter this option again. So these 3 options are the only valid options that you can select, and then 4 means that you are going to exit your program. Now here we have created this show menu function that has check balance, deposit, withdraw and then this exit option. And what I want to suggest to you is how you can upgrade this program on your own. So for example, you can create two users, two accounts. And what you can do with those two users is you can implement transfer option, meaning transfer money from one account to the other account. And I'm going to leave that up to you. And if some of you decide to write that code, make sure to paste it in the comments down below. And I'm going to review that code, and some other people may find it useful as well. So I hope that you enjoyed this video. If you did, give it a thumbs up. Don't forget to subscribe to my channel and hit that bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if you're interested in those, please subscribe to my channel and give this video a thumbs up, because that helps me a lot to reach more people and spread programming knowledge. And in this video, I want to talk about generics and templates in C++. So what are generics? The idea of generics was born when programmers decided that they want to be able to use the same code but with different data types. So the logic is the same, but data types are different. Or if you want another explanation, when we talked about functions, we said that we can pass parameters to functions. And what we said as well is that types of those parameters had to be known beforehand. So you had to hard code types of those parameters, whether it is int or char or float or any other data type, that had to be known beforehand. But with this idea of generics, what we should be able to do is we should be able to pass that type itself to a function. So we should be able to determine which type we want that function to operate on. And the best way for you to understand this will be on an example. So that is exactly what I will do. So let's say that in my Visual Studio, I want to create a function that will swap the values of two variables. And if you don't have an idea how you can swap values of two variables, I have a video where I explain that in a very visual way, so you can use that video. I will link it here. So here I will just type very quickly the code for that, and if you need explanation again, you can watch that video. So I will say that that function will be of return type void, and I will call it swap. And then what I want to pass to this function will be two integer variables. So I will say int a and then int b, like this. Okay, but because I want to have both of these variables available in my main function, which will invoke my swap function, I will have to pass these two variables using a reference. And again, if you're not familiar with passing parameters by a reference, I will link another video here where I talk about that. And I think that I made more than one video on my channel talking about passing variables by a reference to a function, so I will put those in the description as well. So the code for this swap function will be the following. So I will say int temp, I will create a temporary variable, and to that temporary variable I will assign the value that my variable a is holding, and then I will assign to my variable a the value that my b is holding, like this, and then to my b I will assign whatever my temp variable is holding. Again, if you need to understand this in more detail, I will put video in the description of this logic here. Okay, so now this function should give us the ability to swap values of two variables, and the way to test this function is the following. So I will say, please create two variables, call them a and b, like this, and to my a variable I will assign the value of 5, for example, and then b will have the value of 7. So let's write out values of these two variables. Let's say a, and then just make a separation, and then value of b, like this. Okay, so now what I want to do is I want to invoke this swap function. I will say swap, and then I will pass my a and then b, like this. And if I copy this line after the invocation of my swap function, we will see if the values had indeed been changed. So if I run my program, as you can see, this line of code here has resulted with this output, so 5, 7, and then after invoking our swap function, the values inside these two variables, so a and b, have successfully been swapped. So now it is 7, 5. Okay, excellent. So that means that this function does what it should do. Now, what happens if I want to swap values of two char variables, for example? What I would have to do is I would have to copy this function, paste it here, and then I will adjust it to be able to work with char variables. So I will say char, and then I will change this with char as well, and then here I will put char as well. Now this swap function should work with char parameters, and this is called function overloading. If you're not familiar with function overloading, I made that video explaining how it works, so I will link it here if you want to watch it, and I will put it in the description as well. So this function should be able to work with char parameters now. And in order to test this function, let's create two variables of type char. So char c and then d as well. And to my c variable, I will assign the value of letter c, and then to d, I will assign the value of letter d. Excellent. So I will copy this line of code here, and I will just adjust it so that now we write out the value of our c variable, and then here we write out the value of my d variable, like this. And then after this line of code here, I want to invoke this swap function. So I will say swap, and then pass it c and d, like this. And I want to write out my c and d variables after this line of code here. So after I have swapped the values, just to check that they successfully have been swapped. So if I run my code, as you can see, we have this output here, so c and d. And then after swapping the values inside these two variables, we have this output here, which means that they have been swapped successfully. Now, I see a problem with this approach here, and the problem is following. What happens if I want, for example, to swap values of two float variables, and then two doubles, and then two booleans, and so on? Well, I would have to create this swap function for each data type. And that is repeating code, and we shouldn't really be repeating code unless we really need to, and in this particular situation we don't. So there is a simple solution for this problem, and that simple solution will be using generics. And the idea is to be able to use the same function, the same logic, but with different data types. So again, we will be solving this problem using generics. And the way that generics are implemented is using templates. So how do you make a template in C++? Well, you use keyword that is template, like this, and then inside these angled brackets, you will put the name of your type. So you will say type name, and most common type name that is used is called T, but you can use whichever type name you want. You can say type as well if you want, that should work, but I will use T because that is the recommended way. So now that I have created a template and I have said I want to create a new type, which is called T, I will have to use this T in my swap function. So now I will change this int with my T. So I will say T here, and then T here, and I will create T here as well. Okay, now this T is called generic data type, and this swap function is now a generic function, which means that this swap function can be used on any data type whose variables can be swapped using this logic here. So in one invocation it can be swapping integer variables, and then in another it can be swapping characters, and then in the next one floats, and then doubles and booleans, and so on. So now that means that we can really remove this swap function because we do not need it, because as we said, this function here is a generic function and it can be used with different data types. So now I will delete this swap function here, and if I run this code should work as it did before. So let's press this button. Okay, and as you can see, 5, 7, and then 7, 5. This function indeed works for integers, and then CD, and then DC, so it works for characters as well. And let's close this. Okay, now what you can do here as well, here in the invocation, in this 15th line, invoking this function for two integer variables, what you can do is you can specify the type itself as well. So you can say, I am invoking this swap function for my integer type. So now when this function is invoked, it will go here, and this t keyword will be changed with this int. So it will be int here, and then int here, and then int here, and it will do the swapping. This function here will do the swapping for int data type. And then in this 20th line here, you can say as well char if you want. You don't have to. That process will happen automatically because you have declared C and D as char type. So those C and D of type char will be passed here, and then char will be here, and char will be here, and then char will be here as well. So what we have acquired with this template function here is to be able to use the same code with different data types. We have just demonstrated how that can be invoked for integer data type, and then how we can use it for character, and you can do on your own float or double or bool and so on. Okay, and then what you can do as well is you can use any other name for your generic type. T is something that is used commonly in literature, but you can use type as well if you want. So you can say you can say type, and then you would have to say type here, and then type here, and here as well. Okay, that should work the same way that it did previously. And then another thing that you will find in literature is instead of this type name keyword, you can use class. It really depends on you. Whichever one you want to use, you can. And again, if you know what classes are, class is a type as well, so it is user-defined type. So this should work as well, the same way that type name keyword did. And if you're not familiar with classes and objects and object-oriented programming, I have a course which I will link here, so make sure to watch that. So I hope that this video helped you understand what are generics and templates and what is the main idea behind them. And we will be talking about this, of course, in my future videos and in more depth. So make sure to subscribe to my channel and hit that bell icon as well, so that you don't miss a video that I publish. And if you like this one, please give it a thumbs up. That helps me to reach more people and help more people with programming. So thank you very much for watching, and I am going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if that is something that is of interest to you, consider subscribing to my channel. And in this video I want to talk about recursion and recursive functions. In my previous videos we already talked about functions in general, so you should be familiar with that. And then in this video I want to show you on an example what is recursion and how it works. So what is recursion? Recursion is a process where a function invokes itself, and that function that invokes itself is called recursive function. That is pretty simple definition. So let's show that on an example. And the example that I want to give you today in this video will be to sum all the numbers between m and n, which are the numbers that our user defines. And the first thing that I want to show is we will solve that problem using loops, which is a solution that you should already be familiar with. And if you don't understand loops, you can find videos on loops in my C++ for Beginners playlist, so you can watch that. And then after we solve that problem using loops, I want to show you how you can solve that same problem using recursion. So if you want to skip directly to the recursion part, I'm going to leave the link to that part, the timestamp, in the description of this video, so that you can navigate yourself directly to the recursion part if you want. Now, as I already said, the problem that we want to solve in this video is going to be to sum all numbers between number m and n. So let's write the text of our task here. I'm going to say sum numbers between m and n. Okay, so this is going to be our task. And then here, as I already said, I will first solve this problem using loops. So considering that we have to sum numbers between number m and n, I will create two variables, so int m and n, which are two variables to hold the numbers that our user enters. You can do that part. I'm going to hard code those values here. So let's say that my number m, that my variable m holds value of 2, and then n holds the value of 4, for example. And one thing, if you are going to ask your user to enter the numbers for these two variables, what you should do is you should make sure that your user enters smaller number in your variable m and then greater number in your variable n. And if that is not the case, there are a few ways to solve that problem. So you can swap the values in these two variables. If your user enters bigger number here and then smaller one here. And if you don't know how to swap the values in two variables, I'm going to put a link which contains the explanation for that here. And then you can as well just ask your user to enter again and again and again until this number is smaller and then this one is greater. And as I already said, I'm just going to hard code these two values here. Okay, so now that we have our number m and our number n, what I'm going to do is I will write a loop which is going to solve this problem here. And the easiest way to solve this problem here is going to be using for loop. So I will say for, and then I will declare a counter, int I, and that counter should start at the value of our variable m, so I is equal to m, and then it should count until it comes to the value of n, so while our I is less than or equal to n, so while our I is less than or equal to n, and then in each iteration I'm going to increase the value of my counter by 1. Okay, so what I should do in this for loop here is I will just sum all the values that my counter holds in a specific iteration. So I will create a variable here which is going to be of type int, and I will call it sum, and initial value for our sum will be 0 because 0 is neutral when it comes to adding. So here I will write sum is equal to whatever our sum was previously holding, and then to that I will add the value of my I counter, like this. So this should be pretty much it to solve this problem, and at the end of this for loop we should have the sum of the numbers between 2 and 4 in this variable here. So let's write that out. I will say cout sum is equal to, and then write out the value that our sum variable holds. And if you're not familiar with this code here, you should watch my video related to for loop, and I'm going to link it here or leave it in the description down below. So let's run our program and test this code here. Okay, it says that our sum is equal to 9, so 2 plus 3 is 5, plus 4 is 9, so that is the correct result. So this approach here will solve this problem using loops. And this is something that you should already be familiar with. And now I'm going to show you how you can solve this same problem using recursive functions. So let's comment this code out because I don't need it anymore, like this. And then what I want to do is I want to create a function of return type int, and I will call it, let's call it recursive sum, like this. Okay. So this recursive sum function will receive two parameters, and those two will be integer number m and then integer which is called number n. So we will pass these two values to our recursive sum function. And what should we do inside this recursive sum function? Well, the same way that we do not want this for loop to be an infinite loop, we do not want our function to be an infinite recursion. So here we specify the condition when our for loop is going to stop to execute. So here, when our counter I reaches the value of n, that is the point when our for loop stops running. And then here in our recursive sum function, we will have to define a base case which is going to break this recursion. So as I already said, it is called base case, and for this recursive sum function, our base case will be following. So I will say if our m is equal to n, in that case, what I want to do is I want to return from this recursive sum function value of our m or n. So I will say return m. It doesn't really matter which one you return because here we have checked that they are equal. Okay, so this here is our base case, something that is going to break our recursion so that we do not end up with an infinite recursion. Okay, and then what I want to do here is I want to do that recursive part. So that part where the function is invoking itself. And what we should do here is the following. So I will say return And here I want to return the value of m, so the current value of our m parameter, and then I will add to that the following expression. So I will invoke again our recursive sum function, but this time I will pass to this recursive sum function the value of our m plus 1 and then the value of our n variable. Okay, so what this code here is going to do? The same way that here we have increased the value of our I counter in each iteration, here I'm increasing the value of our m parameter in each recursion, so that at a certain point we are going to reach this condition here, so our m and our n will be equal, and at that point our recursion is going to stop. So how is this code here going to behave? Well, let's write out invocation of this function here, and then we are going to go line by line through the execution of this program so that you can understand how this recursion is going to work. So let's say cout sum is equal to, and then I will invoke this recursive sum, so recursive sum, and here I want to pass the value of m and n, like this. So when we come to this 14th line of code here, what is going to happen is we will pass values of 2 and 4 to this function here. So I will write that my m holds the value of 2, and then n holds the value of 4. Okay, and then we come to this line of code here, and we check, is our m equal to our n? So is 2 equal to 4? The answer to that is no, so we do not execute this, but we go here, and what this line of code here says, it says, please return from this function the following. So return current value of my m, which is 2, and then to that I will add whatever this recursive sum function returns to me if I pass it m plus 1 and n. So here I will invoke function again, and I'm going to use these parentheses to indicate invocation of a function. So here we are invoking recursive sum function again, and this time we are passing it values of m plus 1, which is 3, and then n stays the same because our n is our upper limit, so that we can know when we are going to break this recursion. So here is the invocation of this function again, and then we have entered this function using these two parameters. So we go here again and we check again, is our m equal to our n? So is 3 equal to 4? The answer to that is no. So we do not execute this line of code, but we go here again. And what this line of code here says, it says, please return current value of m, which is in this recursion 3, and then add to that whatever this recursive sum function returns for these parameters here. So here I will invoke recursion again, and I will indicate that again with these parentheses. So we invoke our recursive function again with parameters of m plus 1, which is 4, and then n stays the same. So we go here again, and we check, is 4 equal to 4? And the answer to that question now is yes. So now we return the value of our m, which is 4. So here I will say that this recursion returns the value of 4, and then we go backwards. So here we have all the invocations of this recursive sum function. So the result, the end result of this recursion is going to be the result of this expression here. So let's calculate what this recursive sum function is going to return finally at the end. So this is one recursion, and that recursion returns the value of 4. So I'm going to delete these parentheses, and then the recursion prior to that returned the value of 3 plus 4, which is 7. And then if we come out this recursion as well, so I will delete these parentheses, the result of our recursive sum function will be the result of this expression. So 2 plus 7 will be equal to 9. So this is going to be the result of our recursive sum function. So if I run my program now, we should get this 9 as the result of executing this recursive sum function. So let's run our program. And as you can see, sum is equal to 9. And if I increase these m and n values, so if I say, for example, please calculate sum between 1 and 4, we should get 10 this time. So 10, okay, and then here if I add number 5, for example, we should get value of 15, right? So we get that the result is 15. And what you can do here now, of course, you can say, please calculate some of the numbers between 1 and 551, for example, but this is going to be hard to check. So if I run my program, as you can see, we get this very, very big number. Okay, one very important thing that you must have each time that you work with recursion is the following. So every time that you work with recursion, you must have this base case here, which will stop the recursion from happening again and again and again. So this base case here will stop invoking recursive sum function at a certain point when a certain condition is reached. And unless you have that base case which will stop the recursion, you will have that function invoking itself infinitely, so infinite number of times, and you will get an error. So in order to demonstrate that, I will remove this base case here. So let's comment it out. And if I run my program now, as you can see, we get a stack overflow error, which means that, as I already said, this recursive sum function is invoking itself again and again and again, infinite number of times, and this recursion never stops. And in order to stop it, you need to have a base case which will stop the recursion. So I'm going to close the program now, and I will return this code here, which is our base case. And if I run my program again, as you can see, we get the expected result and the error has disappeared. So that is something very important to remember. Each time that you use recursion, you must have a base case to break that recursion from happening infinite number of times. So I hope that you understood what is recursion and how it works. And in order to practice on your own, I will leave a task for you, and the task is following. So I want you to do the factorial of a number using recursion. Calculate factorial of a number using recursion, and if you are not familiar with what factorial is or how it is calculated, I will leave a video link here where I'm calculating factorial of a number using loops. And then what I want you to do is to do that same task using recursive functions. And you can paste your code in the comments down below. So I hope that this video helped you understand what is recursion and how it works. And if it did, give it a thumbs up and subscribe to my channel. And also, you can follow me on my other social media if you want. The links are in the description. Thank you very much for watching. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. Now, in this particular video, I want to talk about object-oriented programming. So what is object-oriented programming? Well, OOP, or object-oriented programming, allows you to represent real-life objects in programming. And those real-life objects are going to be represented together with their attributes and then their behaviors as well. One of the most important concepts of OOP are classes and objects. So let me explain the difference. What is a class and then what is an object? A class is going to represent a template, meaning a blueprint, and then an object really represents an example of that class, an instance of that class. For example, a class can be a fruit, and then an object of that fruit class can be an apple, a banana, a peach, or another example, a class can be a car, and then an object of that class can be a Volvo, a Ford, a BMW, and so on. And that car class, for example, has some attributes and then it has some behaviors as well. Now, what are attributes of car class? Well, a car has a name, for example. That's an example of one attribute. And then it has a price and max speed and color and so on. And then behaviors of a car can be drive, for example, and then brake as well, and then change color and so on. So here we are going to create an example of a class, and then we are going to create an object of that class. So the class that I want to create is going to be called YouTube channel. So in order to create a class, you write class, and then you give a name to your class. So here I'm going to say YouTube channel, like this, and then you put these curly brackets, and at the end you will have to put a semicolon. And now here you will put the members of this class. Now, one thing that I haven't mentioned is that class is user-defined data type. We have already talked about data types in this course, or in C++ for Beginners course, so if you haven't watched that, make sure to do so. I'm going to link it in the description and then here as well. So we have talked about basic data types such as integer, floating point number, and then Boolean, character, double, string, but a class is going to be a user-defined data type, which is going to allow you to represent a real-life object in programming. And in this particular situation, I want to represent a YouTube channel. So let's think of attributes of a YouTube channel. What is something that describes a YouTube channel? Let's say, for example, that each YouTube channel has a name. So that is going to be a string variable. Let's say string name, like this. So these attributes are going to be represented with variables. So one of the attributes is going to be name, and then let's say another is going to be string owner name, like this. And then let's think of another attribute. Let's say that each YouTube channel has a subscribers count. So int subscribers count, like this. And then let's as well create a list of published videos. So I'm going to say list, and let's call it published video titles. So that is going to be type string, and it is going to be called published, like this. Now, here it says that this list cannot be used because we haven't included it here. So here I'm going to say include list, and now this should be accessible. Okay, now we don't have that error anymore. And what I want to do here is I want to represent a YouTube channel that has 4 attributes. It has a name, then owner name, you can use email here or whatever, and then it has subscribers count and published video titles. Now here you can use another class. Here you can say, for example, list of videos. You can create another class that is called video, and then in that video class you can put all the attributes that describe a video. So that can be, for example, a title, and then a description, number of likes, number of comments, number of views, the duration of that video, the video itself, But for the simplicity of this particular example, I'm going to use just the title of those videos. So now, after I have created this YouTube channel class, what I can do is I can create an object of that class. So let's say here that I'm going to create an object. So how you do that, you say the type, so you put the name of your class, which is YouTube channel, and then you give a name to that variable. Let's call it YouTube channel, like this. Okay, now what I want to do is I want to assign values to these properties of my YouTube channel. And how do I do that? Well, you say YouTube channel, and then you put dot. And here is nothing available, but it should be. These properties should be available when you say YouTube channel dot. Now, why these are not available? It is because all the members of your class are by default private. And that means that these members, because they are private, they are going to be accessible only within this class here. And in order to make them public, in order to make them accessible outside of this class, you put public access modifier. So you say here public, okay, like this. Now, this public is an access modifier, and it is going to make all of these members of your class accessible outside of your class, which means that now if I press dot here, as you can see, name, owner name, published video titles, and then subscribers count is available for me now. So I'm going to say that the name of my YouTube channel is going to be, for example, Code Beauty, like this. And then owner name, let's copy this a couple more times. So owner name is going to be my name, so Saldina, like this. And then subscribers count, well, let's say this is an integer variable, so we don't need the quotation marks. Let's say 1,800 people. And then these published video titles, so let's add value to my published video titles list. So here I want to say that I have published, for example, C++ for beginners. Let's say video 1, okay, and then let's say HTML and CSS video 1, okay, and let's add as well this video. So let's say C++ OOP video 1, okay. Now after I have assigned value to these properties, what I can do is I can write out these properties. So I can say here, for example, cout, and then let's say name, and let's write out the name of my YouTube channel, like this. And I'm going to add an end line, and I'm going to copy this a couple more times, like this. So here I want to write out owner name, so let's put YouTube channel dot owner name, and then here I want to write out a subscribers count, so YouTube channel dot subscribers count, and then published video titles. Now this property here, published video titles, is not a simple property, meaning this property here is a list, and in order to write out a list we are going to use a loop. So I'm going to delete this, and then here I want to create a loop, and let's say that we will be using for each loop. So I'm going to say for, like this, and then here I'm going to write out the type of the value that I'm going to use in my list. So I'm going to say string, because this published video title is of type string, and then here I want to give it a name, so I'm going to say video title, like this, and then I'm going to specify the list that I want to iterate, and that list is going to be this one here. So it is going to be a list of published videos in my YouTube channel object, okay. And now in these curly brackets I am going to specify the block of code that is going to be executed in each iteration. So what I want to do with this video title is I want to write it out. So I'm going to say cout, and then let's write out video title, and I'm going to add an end line at the end as well. And one more thing that I want to write out before this list is going to be just cout videos, like this, okay. And let's add end line at the end so that it is formatted nicely. So now if I run this program, as you can see, it has written out information about this object that we have created here. It says that the name of YouTube channel is Code Beauty, and then owner name is Saldina, subscribers count is equal to 1800, and then this channel has published 3 videos, so C++ for beginners, and then HTML and CSS video 1, and then C++ object-oriented programming video 1. Okay, so I have created a class that is called YouTube channel. I have created 4 attributes, so 4 properties, and made them public, which means that these 4 properties are going to be accessible outside of this class, and we have accessed those properties here. So we have said that we want to assign the value to our name property, and then owner name, subscribers count, and then we have as well assigned value to this published video titles list. Okay, and then here we have written out information that is stored inside these properties. So that was an example of how you can create a class, and then how you can create an object of that class as well. And in my next video we are going to be talking about constructors and class methods, because there is a more simple way to do this that we have done here. So make sure to check that video out as well. So I hope that you enjoyed this video. If you did, give it a thumbs up, and also please subscribe to my channel and click that bell icon, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos on this channel. So if that is something that is of interest to you, consider subscribing and give this video a thumbs up as well. And in this particular video, I want to talk about constructors and class methods. So here I have some code that we have written in a previous tutorial of this course. So if you haven't watched that, make sure to check it out. I am going to link it here and in the description as well. And let's explain very quickly this code that we have here. So I have created a class called YouTube channel, and that class has 4 public properties. So 4 attributes. Those are name, owner name, subscribers count, and then a list of published video titles. And then here I have created an object of that class. I have assigned the value to these properties here. Okay, and then here I have written out information about this object that we created. And as I said, in this video I want to talk about constructors and class methods. And how am I going to explain these? Well, let me first introduce a problem to this approach here so that you can really understand the need for these two. So, what happens if I want to create another object of this YouTube channel class? How am I going to do that? Well, in this current situation, what I would do is I would copy this. So I'm going to copy it and then I'm going to paste it here like this. And let's give it a name. Let's say that this channel is going to be YouTube channel 2. And let's call it, let's say YouTube channel 2.name. Let's say that it is going to be called Amy Sings, for example, and owner is going to be a girl called Amy, and then she is going to have, let's say, 2,000 subscribers. Okay, and then the videos that she has published are going to be songs, obviously, because she has a channel named Amy Sings. So let's say that she has published, for example, let's say Johnny B cover like this. So that's one song, that's one video. And then let's say that another video that she has published is going to be, for example, Lorelei. So that's a song from Scorpions and she has made a cover of that song like this. Now these two are 2 of my favorite songs, and you can put whatever you want here in this list. And I'm also wondering, and you can write that in the comments down below, what are your favorite songs? So please write that in the comments. Just don't put links, because I think that YouTube has this policy of treating links as advertising or spam or something. So just write out the name of your song and then the name of a singer, I guess. And I'm really looking forward to reading your comments. So now that I have created this second YouTube channel, what I want to do is I want to write out information about this channel. But I noticed that I'm missing here this YouTube channel 2. So here I'm going to say YouTube channel 2.owner name, and then YouTube channel 2.subscribers count, and then YouTube channel 2.published video titles as well. Okay, now if I wanted to write out information about this second channel, what I would do is I would copy this. So I'm going to copy it and then paste it here, and here I will say that the name is YouTube channel 2.name, and then owner name is YouTube channel 2.owner name, and then here as well, and then YouTube channel 2.published video titles. Okay, now if I run this program, we should get information about these 2 channels. So the first channel is this one that we already had. It's Code Beauty, owner is me, and then this is subscribers counter, and then these are 3 videos that I published so far. I mean, I published more than 3 videos, but this is just an example. And then here is our second channel. It's called Amy Sings, and then owner is Amy. She has 2,000 subscribers, and then she has published 2 covers. Now, this here has a problem. If we wanted to create a third, a fourth, a fifth object, we would have to copy this code, and then each time that we want to write out information about those channels, we would have to copy this code. And this really collides with a principle called don't repeat yourself, meaning do not repeat your code if you don't really have to repeat it. And in this particular situation, we do not have to repeat it. So how we are going to solve this problem? Well, the first thing that I want to talk about are going to be constructors. And what a constructor is, it is a special method that is going to be invoked each time that you create an object of a specific class, meaning that method is going to be called on the construction of that object. So there are two rules when it comes to constructors. And the first rule is that constructor has the same name as your class. And then the second rule is that constructor does not have a return type. So let's create a constructor for this YouTube channel class. Here I'm going to say YouTube channel like this, and then I'm going to put these parentheses and I'm going to put these curly brackets as well. Now, what I want to do in this constructor is I want to receive two parameters. I want to receive two arguments, and those are going to be string name and then string, let's say owner name. Okay, now these are two parameters that I want to pass to my constructor, and what I'm going to do with these in my constructor is I'm going to assign these to these properties here. So I'm going to say that name is going to be equal to whatever my user has passed to this constructor. So name is equal to this name here, and then owner name in my class is going to be equal to this owner name that I have received in my constructor. Now, since this constructor here is invoked each time that I create object, each time that it is constructed, that means that at the beginning, when a channel is created, it has 0 subscribers. So I'm going to put here 0 like this. We do not even have to pass this value in our constructor, because when you create your YouTube channel, you do not have subscribers. Okay, now what am I going to do here is I do not need to write this code like this anymore. So I'm going to actually comment this code here. And as you can see, this is underlined. It says that no default constructor exists for class YouTube channel. Now, what we have to do is we have to use this constructor here that I have just created. And how you do that? Well, you put parentheses here, and then inside these parentheses, we are going to pass these two parameters. So the first parameter is going to be the name. So that is the name of our channel, and that is this name here. So code beauty like this. And then a second parameter, as you can see here, is owner name, and that was this value here. So I'm going to pass that here like this. And now, after I have created this YouTube channel, we do not need this code anymore. So I'm going to delete it. Okay. And what we can do is we can do the same with this second channel. So with this YouTube channel too. So I'm going to really comment this code for a moment. And then here I want to invoke a constructor for this YouTube channel class and pass it as first value the name, because we are receiving name as our first value in our constructor like this. And then the second value that we need to pass is going to be owner name. So I'm going to copy that as well. And now we have successfully created this second YouTube channel. Okay, so now I can delete this code here as well. Okay, and now if I run my program, as you can see, it has written out information about my two channels. The first one is code beauty, owner is me, and then I have 0 subscribers because I have just created my channel and we have assigned that here. And then our second channel is Amy Sings, owner is Amy, and she has 0 subscribers as well. And as you can see, both of these videos, published videos lists, are empty because we haven't really added any videos. Okay, so how do you do that? I'm going to delete this from here and then move it here like this. So now we have both of our objects being created at the beginning here. So what I want to do now is I want to add a couple of videos to this channel here. So how do you do that? Well, you say YouTube channel like this, and then I'm going to put dot, and here in this published video titles list, I'm going to invoke a method push back, which is going to add at the end of this list another element, and that element is going to be of type string, because this published video titles is a list of strings. So here I'm going to add a string, and I'm going to call that video C++ for beginners like this. So that is one video, and then let's add a couple more videos. Let's say HTML and CSS for beginners. And then let's say OOP for beginners. Well, no, let's say C++ OOP, like this. Okay, so we have added 3 videos for this first channel, and then this second channel does not have videos yet. So if I run my program again, you can see that this first channel has 3 videos, and then this second channel does not have any videos yet, because we have deleted those that we previously had. Okay, now that was the example on how you can create a constructor and how you can use a constructor. So this here is the constructor of this YouTube channel class, and we have passed 2 parameters, 2 arguments to this constructor, and then here in our constructor we have really assigned initial values to these properties here that we have in our YouTube channel. And then this here is the way that you use your constructor. So you put these parentheses, and then you pass the values that your constructor has to receive. And here we have created 2 objects, and we have done that without repeating code. Now what is going to happen with this here? So this here and then this here is repeating code as well. And in order to solve this particular problem, we are going to use class methods. So class method is going to describe a behavior of a class, and since here we are writing out these attributes of our class, since we are writing out information about our YouTube channels, what I want to do is I want to create a method that is going to be called getInfo, for example. So that method is going to be of type void. Let's call it getInfo, like this. And what I want to do in this particular method is I want to copy this code here. So I'm going to cut it and then paste it here. And in this particular method, in this getInfo, I want to say, please write out name and then the name property. We don't need this YouTube channel object anymore because we are in the class itself. Okay, and then here as well, I'm going to delete this here and then here. And now this code should work. So whenever you invoke this getInfo method on your object, it should write out all of these properties of that object. So now I can remove this code here as well. So this information about our second channel, and how am I going to invoke this method? Well, I say the name of my object. So for example, YouTube channel dot, and then as you can see, I have this getInfo method available here because it is public. So I say getInfo and I invoke it like I would invoke any other function. And let's do the same for our second YouTube channel. Let's say YouTube channel 2 getInfo, like this. And now if I run my program, as you can see, it has written out information about my 2 channels. So Code Beauty, Saldina is owner, and then subscribers count, my videos, and then info about my second channel as well. So I hope that you understood the concept behind a constructor of a class and then behind a class method. Here we have demonstrated how you can create an object using a constructor, and then here as well. So you don't really have to repeat your code each time that you create an object. And then here we have invoked a method of these objects, which we have implemented here, so you do not have to repeat that code as well. Each time that you need to get information about your object, you just invoke this getInfo method. And now our main function looks much cleaner, and all the implementations of the construction of our objects and then this getInfo method are in this YouTube channel class. So I hope that you enjoyed this video. If you did, give it a thumbs up and also subscribe to my channel. Don't forget to hit that bell icon, and I'm going to see you in my next video. Bye! Hi everyone, my name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. And in this particular video, I want to talk about encapsulation. Here I have code that we have written in the previous videos of this course, so if you haven't watched those, make sure to check them out. I'm going to link them in the description of this video. And I'm going to go over this code very quickly so that you can understand what we have written here. So here I have created this YouTube channel class, which has 4 public attributes, and those are name, owner name, subscribers count, and then list of published video titles. And then here we have a YouTube channel constructor, and then this getInfo method as well that just writes out information about our YouTube channel. And here's the code of our constructor. Okay, and then in our main function, we have created an object of this YouTube channel class, and we have assigned it these 2 values for our name and our owner name. And then we have as well added 3 videos to this published videos list. And here we have written out information about our channel. So if I run this code now, as you can see, this is how it behaves. It writes out information about our YouTube channel. Now, what I want to talk about in this video is encapsulation. And what does this principle of encapsulation says? Well, encapsulation says that these properties here should not be public. These should be private, and then the way to change the value, the data that you store inside these properties, should be really using methods that you expose, and then you give access to those methods to your user, and then using those methods, obeying the rules of those methods, your user can change the value of these properties. Okay, so let me introduce a problem here so that you can really understand why we need encapsulation. So what happens if I say, for example, that YouTube channel, so this that we have created, has, let's say, 1 million subscribers. Okay, this is 1 million. Now we have assigned 1 million subscribers to this YouTube channel, and this should not be allowed. If I run this program, you can see that this YouTube channel has 1 million subscribers now, but this is not the natural way to gain subscribers for your YouTube channel. What you should do instead is you should give your user the ability to invoke subscribe and unsubscribe methods, and then using those methods you are going to increase or decrease this subscribers counter. So let's do that. Let's first hide these properties from our user, so from whoever is going to use this class here. So how do you hide these? Well, you make them private. So here, instead of using public access modifier, I'm going to use private access modifier. So I'm going to say private, like this. And then these should stay public. So I'm going to put public here, like this. Okay. And then, as you can see, we have a problem here. It says that this subscribers count is inaccessible, and then this published video titles as well is inaccessible, meaning that we cannot access these private members of our class. These private members can be accessed only within this class itself. So how we are going to give our user the ability to change this subscribers counter? Well, as I said, we are going to create methods. So let's create 2 methods. The first one is going to be void subscribe, like this. And then what this method should do, it should increase this subscribers counter. So here I'm going to say subscribers counter, like this, plus plus. Using this increment operator, we are going to increase the value that we store in this variable by 1. And then we are going to have as well unsubscribe method. So I'm going to copy this, paste it here, and let's say unsubscribe. And then here I'm going to say that this subscribers count is going to be decremented. So now if I will have to comment this code here, and then I'm going to delete this code here. And now if I want to increase or decrease subscribers for my channel, what I will have to do is I will have to invoke one of these two methods. So let's say, for example, YouTube channel dot subscribe, like this. Okay, and let's invoke this method 3 times, for example. And now if I run this program, as you can see, my channel, so Code Beauty channel, has 3 subscribers. And then let's say, for example, that I haven't published videos in a while, so people decide to unsubscribe. So I'm going to invoke this unsubscribe method, like this. And if I invoke this get info after that, I should have 2 subscribers. Well, oh, as you can see, I have 2 subscribers now because 3 people have subscribed and then 1 person has unsubscribed from my channel. Okay, so we have this code here as well that was underlined, meaning that it has compile time error, and it says member published video titles is inaccessible, meaning that now we cannot access this published video titles list anymore because it is private now. So I'm going to expose a method that is going to publish videos for me. So here I want to create a method of type void, which is going to be called publish video, like this. And then here I want to add a video to my published video titles, like this. So I'm going to say published video titles, push back. And then what I want to do is I want to pass a value here. Which value? Well, we are going to receive that value as a parameter in our function. So here I'm going to add an argument, a parameter, and that is going to be of type string. And let's call it title, like this. And now we are going to use this title here. So we are going to push this title in our published videos titles. Okay, like this. Now, if I want to invoke this method, I'm going to invoke it like this. So I'm going to say YouTube channel dot publish video, like this. And then I'm going to do the same thing here, and then here, and here as well. Okay, so now we have created these methods that we invoke, and then using these methods, we change these properties, and these properties should be private, meaning these should be encapsulated. Okay, and now as you can see, we have a channel called Code Beauty, and then owner is myself, and subscribers is 2, and then these are videos that I have published so far. Now, if you look at this unsubscribe method, you will notice that it has a bug. What is that bug? Well, let's delete these 3 lines of code. Let's delete these subscribe method invocations. And if I run my program now, what is going to happen? As you can see, it says that my subscribers count is equal to -1. And that does not really make sense. So you cannot have -1 subscriber. And we are going to fix that problem if we put here inside this unsubscribe method a check. So we want to check if our subscribers count is greater than 0. And only in that situation, if that subscribers count is greater than 0, only then we can decrease this subscribers count value. So if I run my program now, as you can see, we have invoked this unsubscribe method, but we still have 0 subscribers. And now we have fixed that bug that we had, because if no one has subscribed to our channel, then no one can unsubscribe from it. Okay, so that was a bug that I wanted to fix. And then what you can do here, because here we have exposed these three methods that really manipulate the values that are stored inside these properties, and then these two properties, there is no way to change them outside of this class. So what you can do for them, for example, is you can create a getter and a setter, meaning a method that is called, for example, getName, and that method is going to return you the value that is stored inside this name variable, and then a setter method, meaning setName method, that is going to receive parameter which is going to be called name, for example, and inside that setName method you are just going to change the value that is stored inside this name property. And then you can do the same for this owner name as well. So you can create a getter and a setter method. So let's go over this encapsulation rule one more time. So encapsulation rule says that all of these properties should be private, meaning they shouldn't be accessible outside of this class, and you do that by making them private. So you put this private access modifier here, and then how do you change the values that you store inside your properties? Well, you expose a public methods that are going to change the data that you are storing inside your properties. And here we have created these three public methods that are going to change the data stored inside our subscribers count property, and then inside our published video list property here. So you can, for these two properties, again, you can create getter and setter method. And if some of you do that, please put that code in the comment section and I'm going to review it. So if you enjoyed this video, give it a thumbs up. And don't forget to subscribe to my channel and hit that bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, my name is Saldina and I make IT and programming related videos on my channel. So if that is something that is of interest to you, consider subscribing and give this video a thumbs up as well. And in this particular video, I want to talk about inheritance. So here I have my Visual Studio, and here I have some code that we have written in the previous tutorials of this course. So if you haven't watched those, make sure to watch them. And now I'm going to go very quickly over the code that we have here. So I have created a class that is called YouTube channel, and that class has 4 private properties: name, owner name, subscribers count, and then published video titles. And then we have a couple of public methods as well. We have a constructor, which just initializes these variables here. And then we have getInfo method that just writes out information, the values that are stored inside these properties here. And then as well, we have subscribe and unsubscribe methods. Our subscribe method increases our subscribers counter, and then our unsubscribe method decreases that subscribers counter. But first we have to check if that subscribers count is greater than 0. So those would be subscribe and unsubscribe methods. And then we have this publish video method as well that just adds a new item, adds a new title to this published videos list. Okay, now what is going to happen if I want to create another type of YouTube channel, a specific type of YouTube channel, which is going to be, for example, cooking YouTube channel. So I should copy these properties, right? Well, that can be one approach, but the quicker and better approach is going to be to inherit this YouTube channel class. So let's do that. Let's create another type of channel. So let's create another class. Let's say class, and then let's call it cooking YouTube channel, like this. Okay, now I have created a class that is called cooking YouTube channel, and in order to inherit this YouTube channel class, what I'm going to do is I'm going to put this column sign, and then I'm going to say public YouTube channel, like this. And in this way, my cooking YouTube channel is going to inherit my YouTube channel. And that means that my cooking YouTube channel is going to have everything that my YouTube channel has. Now, this public access modifier means that whatever is public in this class here, it is going to be public here as well, so in this derived class. And one very important thing is to know that this class is called base class, so the one that you inherit from, that is base class. And then the derived class is going to be this one here. So the one that inherits from the base class is called derived class. And in this particular situation, our cooking YouTube channel is derived class. Now, what is going to happen if I want to create, for example, an object of this cooking YouTube channel? So I'm going to say cooking YouTube channel, and let's call it YouTube channel, like this. Okay. Now, as you can see, it says that default constructor of cooking YouTube channel cannot be referenced. Now, that is because we do not have a constructor for this class here. So let's create one. Let's create a constructor. So I'm going to copy this name and then add these parentheses. Okay. And now, if I hover over this, it says that the constructor is inaccessible. So we still have an error, but we have a different error, which means that we are making progress. So because this constructor is inaccessible, I will have to make it public to make it accessible outside of this class here. So I'm going to say public. Okay, and now my constructor is going to be accessible. But there is another thing that we have to do, and that is going to be inside this constructor, we have to receive properties that we are going to initialize in our constructor. And those are going to be these two properties, name and owner name. So here I'm going to say that my constructor receives two properties. So string name and then string owner name. So the owner of that channel. And what I'm going to do when I receive these two properties, I'm not going to initialize them here in my constructor because I'm inheriting from a class that already knows how to construct, how to initialize these two particular properties. So I'm going to call the constructor of that class. So I'm going to call the constructor of this YouTube channel class. So here I'm going to put this column sign, and then I'm going to invoke its constructor. So I'm going to say YouTube channel, and then I will pass these two parameters here. So I'm going to say name and then owner name, like this. And now our base class, our YouTube channel class, is going to construct, to initialize actually the value of these two properties. And as you can see here, we have an error that asks us to pass these two values to our constructor. So we are going to pass two parameters. The first one is going to be the name of our channel. So let's say that that is going to be, for example, Amy's Kitchen, like this. And then owner is going to be girl named Amy. Let's put that here as well. Okay. Now, after I have created an object of this cooking YouTube channel, what I should be able to do is I should be able to access all of these public methods that my base class has. So all of these methods from my YouTube channel class should be available for my cooking YouTube channel. So here I'm going to say YouTube channel dot. And then, as you can see, these are available. So get info, publish video, subscribe, unsubscribe. Let's write out info about my channel, like this. And if I run it now, well, you can see that we have Amy's Kitchen channel. Owner is Amy. It has 0 subscribers and it has no videos as well. So let's publish a couple of videos for Amy's Kitchen channel. So here I'm going to say, okay, before this get info function, I'm going to say YouTube channel dot, and then let's say publish video of, for example, apple pie, like this. And then let's publish another video, let's say, for example, chocolate cake, like this. And now if I run this program, as you can see, we have two videos. And let's as well say that people like these videos, so they decide to subscribe to Amy's Kitchen channel. So I'm going to say YouTube channel dot subscribe. So for example, 2 people decide to subscribe to her channel. And if I run my program again, you can see that now we have 2 subscribers as well. So we have been able to invoke all of these methods that are implemented in our base class. So here, from the object of our derived class. So from the object of this derived class here. Now this derived class, this cooking YouTube channel, can have its own members, meaning things that are specific for this class only. So let's say, for example, that we want to create a method that is going to be called, for example, practice. So I'm going to say void practice, like this. And then what this method should do, it should just make our user that has this cooking YouTube channel, it should say that this user is practicing cooking and then learning new recipes and things like that. So I'm going to say cout, like this. And then let me copy this part of the code because I don't want to make a typo, like this. So it says that our YouTube channel's user is practicing cooking, learning new recipes, and then experimenting with spices, because I guess that's something that you should do if you have a cooking YouTube channel. And let me add end line here as well, like this. So now if I decide to invoke this method is going to be available only for objects of this cooking YouTube channel. So I'm going to say YouTube channel, like this, and then let's say practice, like this. Now, let me very quickly change the name of this YouTube channel object because I want to create another object that is going to be of this YouTube channel type, and I want to call that YouTube channel. So here I'm going to say cooking YouTube channel, and I'm going to paste that name here, and then here, and here as well. Okay, now we have named this object cooking YouTube channel, and if I run this program, you can see that at the end it says practicing cooking, learning new recipes, experimenting with spices. Now, as I already said, this practice method should be available only for the objects of this cooking YouTube channel class. So that means if I decide to create an object of this class here, this base class, that class is not going to have this practice method. And let's prove that very quickly. So here I'm going to create an object of YouTube channel class type, and let's call that object YouTube channel. That's why I changed the name of this object, like this. And let's say that that is going to be my channel, for example, code beauty, like this. And then let's say that owner is my name, Saldina. So now if I try to access this practice method on my YouTube channel, so I press dot, you can see that that method is not available for this base class. It is available only for this cooking YouTube channel class, because this practice is very specific method, meaning this Code Beauty channel, which is oriented to programming and IT, does not really benefit from learning recipes and experimenting with spices, practicing cooking and things like that. So this channel should probably have some other way of practicing because it is different type of channel. So I'm going to delete this code here. Okay, and let's repeat this one more time. So we have created a derived class which is called cooking YouTube channel, and we have inherited everything that our YouTube channel class has by saying public and then the name of our base class, and this public access modifier is going to allow us to have whatever is public here to have that public here as well. And then we have created a constructor for our cooking YouTube channel. And in that constructor, we receive two parameters, name and owner name. And since our base class constructor knows how to initialize those two, we have here invoked this base class constructor. And then here we have created as well a method that is called practice, and that method just says that our user is practicing cooking and he is learning new recipes and experimenting with spices. Now there's one more thing that I want to show you, and that is going to be let's create another object of this cooking YouTube channel, and that is going to be let's say cooking YouTube channel 2, and let's call it John's Kitchen, like this, and owner is going to be, for example, John. Now, what is going to happen if I say, for example, that this second YouTube channel, so this cooking YouTube channel 2, John's YouTube channel, is practicing? I'm going to comment these two because I don't need them. And if I run my program now, you can see that it says 2 times practicing cooking, learning new recipes, experimenting with spices, and then the same line here. So you cannot really differentiate between which one is Amy's channel and which one is John's channel. So in order to make that a bit more understandable, I'm going to add a property here. So here I want to add the name of the owner of this channel. So here I'm going to say, let me copy this property like this. So owner name, and then let's say that that owner is practicing cooking, learning new recipes, experimenting with spices, and so on. But as you can see, this property here is not accessible. It says that member owner name is inaccessible. And why is that the case? Why is it inaccessible? Because it is private, and if you remember, private members can be accessed only within that class, and then public members can be accessed from outside of that class. But what happens if you want to have, for example, a certain property to be accessible in the derived class? Now there is an access modifier for that as well. So that is going to be protected access modifier. So I'm going to say here protected, like this. And then I'm going to move this owner name to my protected area, like this. So now this owner name property should be accessible in derived classes as well. And as you can see, the error has disappeared. So now if I run my program, you can see that it says that Amy is practicing cooking, learning new recipes, and experimenting with spices. And then this second line here says that John is practicing cooking and learning new recipes and experimenting with spices. So now we have made a difference. We have specified the name of our owner of the channel, and we can understand what the code is doing a bit more. I hope that you understood what is inheritance and how it works in C++. And if you did, please like this video. Don't forget to subscribe to my channel and click that bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. And in this particular video, I want to talk about polymorphism. Now, the first thing that I want to do is I want to explain what is polymorphism. Polymorphism describes the ability of an object, for example, to have multiple forms. Now, that means that you can have 2 or more objects that inherit from the same base class. Those objects can have the method that has the same name but different implementation, meaning different behavior. And I'm going to demonstrate that on an example. Now here I have some code that we have written in my previous courses, so if you haven't watched those, make sure to do so. The links to those videos are going to be in the description. And I'm very quickly going to go over this code. So here I have created a class that is called YouTube channel. That class has 3 private properties: name, subscribers count, and then published video titles, and then it has one protected property, which is owner name. Now, this private properties, these are available only in this class, and then these protected properties, these are available in derived classes as well. And then here we have public methods as well, and this here is our constructor, so it just initializes values of these properties. I'm going to collapse that. And then here we have getInfo method, which just writes out information about our YouTube channel. And then these subscribe and unsubscribe methods, these just increase or decrease the number of our subscribers. Let's collapse that. And then publish video method, it just adds another video to this published video titles list. So that would be our YouTube channel base class. And then here we have cooking YouTube channel, which is a specific type of YouTube channel that inherits from this base class here. And that cooking YouTube channel has its own constructor, which is this one here. And here we have just invoked the constructor of our base class. And then here we have implemented a method which is called practice, and it says that when you practice and you have a cooking YouTube channel, you will have to be practicing cooking and then learning new recipes and experimenting with spices. Now, what I want to do is I want to create another derived class. So I'm going to copy this. Okay. And then this derived class should be called, for example, let's paste the name here. So Singer's YouTube channel, and I'm going to paste the name here as well on my constructor. So this is going to be a YouTube channel about singing. Now, as you can see, this Singer's YouTube channel has this practice method as well, but this implementation is not right for my Singer's YouTube channel, because if you're a singer, you are not going to benefit really from practicing cooking and then from learning recipes and experimenting with spices. But what you should do instead is you should practice something else. So I'm going to copy that so that I don't make a typo like this. So someone who is trying to make a singer's YouTube channel is going to take singing classes and then learning new songs, and then he should as well be learning how to dance, because I believe that singers should know how to dance as well. Okay, so now we have implemented this Singer's YouTube channel, and as you can see, as I already demonstrated, it has this same method, which is practice, but this method has different implementation than this one. And as you can see here, this is the implementation of our practice method on our cooking channel, and then this here is the implementation on our Singer's YouTube channel. So what I want to do now is I want to create this Singer's YouTube channel. Here we already have cooking YouTube channel. So it is a video, it is a code from one of my previous videos. And then what I want to do is I want to create Singer's YouTube channel. So let's call it Singer's YouTube channel. And let's say that it is going to be called, for example, John Sings, like this, and then owner is going to be a guy named John, like this. Okay, now after I have created this cooking YouTube channel and then this Singer's YouTube channel, you can probably call it singing YouTube channel or something like that. This is the best name that I could come up with. Okay, so now what I want to do is I want to invoke methods on these two classes, and the methods that I want to invoke are going to be these two, so practice and then this practice method as well. So here I'm going to say cooking YouTube channel dot practice, like this, and then let's invoke the same method for my Singer's YouTube channel, like this. And now if I run my program, as you can see, it says that Amy is practicing cooking, and then John is taking singing classes and learning new songs and learning how to dance. I can imagine that. Okay. Now, after I have invoked these two methods, you can really see, oh, I have stopped my program, I'm sorry. So here you can see that this cooking YouTube channel has invoked its own method. So this cooking YouTube channel has invoked the method that has been implemented in this cooking YouTube channel class, which is this one here. And then this invocation, so this singer's YouTube channel, when you invoke practice method on that, this method here is going to be invoked. So this method that is implemented in singer's YouTube channel class. Now let's add another thing, and that is going to be here in this practice method, and then in this practice method as well. What I want to do is I want to say that each time that our user practices cooking and then practices singing, what is going to happen is the quality of that YouTube channel is going to increase. So in order to track that quality content rating, I'm going to create a property, and that is going to be here in this YouTube channel, in this base class. So I'm going to make that property protected because I want to have it accessible in my cooking YouTube channel and then in my singer's YouTube channel as well. So I want that property I want to access that property from my derived classes, and because of that, I'm going to make it protected. So here I'm going to say int, and let's call it content quality, like this, okay? And initially, I want to set the value of this content quality variable. In this constructor here, I want to set it to 0, like this, because I want to say that when you create your YouTube channel, this constructor here is going to be invoked, and you are going to have 0 subscribers, and you are going to have a 0 knowledge about content quality. So your rate, content quality rate, is going to be 0. So let's close that. And then what I want to do here in this practice method is I want to say each time that you practice, your content quality should increase. So let's increase that variable. Content, where is it? Content quality plus plus. So I'm going to increment that content quality, and then I'm going to do the same here, like this. Now let's say, for example, that my this singer here, John, he is going to practice a lot. So he has practiced 5 times more than Amy did. So if I run my program now, you can see that John is practicing, and then again and again and again. So he is practicing a lot, and Amy is not really. So what do I want to do with this content quality property? Well, let's say that I want to implement another method, and that method is going to be as well implemented here in this base class, and that method is going to be called check analytics, because that check analytics method should be available for all YouTube channels. So that is not something that is specific for this cooking YouTube channel only, or for this singing YouTube channel, so singer YouTube channel, but that method should be available for all YouTube channels, and because of that, I'm going to implement it in this base class. So let's say void check analytics, like this. Okay, and now what I want to do in this check analytics method is I want to use this property, this content quality property, in a following way. So I want to say if content quality is less than 5, I want to write out a message to my user. So I want to say cout, and then let's write out the name of this YouTube channel, like this. And then let's add a message which is going to say, let me copy that. Okay, this is going to say that this channel has a bad quality content because this content quality has a rating that is less than 5. And let's add end line. And then what is going to happen if this content quality is not less than 5? So if it is equal to 5 or greater than 5, I'm going to put else block here. And what I want to say here, okay, is that this channel has a good content, great content actually. Okay, like this. Now, what am I going to do with this check analytics method? Well, I'm going to try to invoke it here. But the way that I want to try to invoke this method that we just implemented is going to be in a following way. So there is one very interesting thing when it comes to polymorphism, and that thing is related to pointers. At this point, I haven't made videos about pointers on my channel, but if you're watching this video sometime in the future, then those videos are probably available on my channel, so make sure to look for them on my channel and then in the description of this video as well. So let's create a pointer, and that pointer is going to be a pointer of our base class. So a pointer of type YouTube channel, okay, like this, and let's call it YouTube 1. And what I want to do is I want to assign to this pointer here address of this cooking YouTube channel. And you can do that. You can assign to a pointer of a base class an address of derived class. So I'm going to say here, please, to this pointer, assign address of this cooking YouTube channel class, like this. And then what I want to do is I want to create another pointer. Let's call it YouTube 2. And then to this YouTube 2 pointer, I want to assign the address of my singer's YouTube channel, like this. So one more time, a pointer of base class can point to a variable of derived class. Now, what I can do using these pointers is I can invoke method that I have just created, which is this one here. So check analytics. So let's do that. Let's say YouTube channel 1, and then let's invoke this method. Let's say check analytics, like this. And if you just noticed, it has changed my dot to this symbol here because this is used when you want to invoke methods using pointers. So I'm going to copy this again for my second YouTube channel, like this. And now if I run my program, as you can see, our John has been practicing a lot, and then Amy has been practicing only one time. So here, after I have invoked these two methods, this first method says that Amy's kitchen has bad quality content because she hasn't been practicing enough. And then after this YouTube channel 2 check analytics, you can see that it writes out this message that John Singh's channel has great content because he has been practicing a lot, as you can see here. Okay. So here we have used polymorphism in order to implement this practice method in our cooking YouTube channel and then in our singers YouTube channel. So implementation of our singers YouTube channel practice method is here, and then for our cooking YouTube channel our practice method looks like this. And we have done that thanks to the polymorphism, so different implementations but the same method name. And then I have demonstrated here how you can use pointers to point to an object of derived class, and you can store that in a pointer of base class. And then we have invoked this check analytics methods using these pointers of base class. So I hope that you enjoyed this video. If you did, give it a thumbs up, and don't forget to subscribe to my channel, click the bell icon as well, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video I want to talk about pointers, so I will go straight to the point. Pointers are a very important concept in C++, and they have many uses in C++. Now, pointers are not limited only to C++, they exist in other programming languages as well. But in most of those programming languages, they are really hidden. They work behind the scenes, so you cannot see them and you cannot use them yourself. But in C++, you can use them and you can create your own pointers, and they can be pretty powerful if you know how to use them. But they can get quite confusing as well if you don't understand them well. So the first thing that I want to explain is what are pointers. So we already have explained the concept of a variable, and you should be familiar with that. So we said that a variable is just a container, so a container that stores certain value. Now a pointer is container as well, but instead of storing value, pointer stores an address, so a memory location. And let me show you how pointers work in Visual Studio. Let's create a variable of type int, and I'm going to call it n and assign it a value of 5. And let's write out this n like this. So nothing new here, we are already familiar with this, and if I run my program, as you can see, we get this value of 5, so that was expected. Now, as I already said, this n is a variable, and that means that it is a container which is storing certain value. Now, because it is a container, that means that it has its address inside memory, so it has its physical location. So how can we get that location? How can we check which address this n has? So in order to do that, you use this ampersand symbol like this. So you put it before your variable name, and that should give you the address of that variable. So if I run my program now, as you can see, now we have an address, and this is the address of our n variable. So this is its physical address where this value of 5 is stored. And because this is pretty hard for humans to remember, this is just a random numbers and characters. Because of that, we use meaningful names, and we access these values that we store in our memory using these meaningful names, which are our variables. So I'm going to close this now, and what I want to show you here is I want to show you how can you create a pointer that is going to hold this address of our n variable. So in order to create a pointer, you give it a type first, so you say int, and then in order to indicate that you are creating a pointer, you use this star symbol, and then you give it a name, so let's call it PTR pointer, and I'm going to assign it the address of our n variable. So I'm going to copy this and paste it here. Okay, now our pointer is holding the address of our n variable, and in order to prove that, I'm going to write out the value of my pointer like this. So as expected, we have this first line here, which is writing out the address of our n variable, and then this second line of code is this line here, and as you can see, we have written out the value of our pointer, and that is the same address as this one here, which means that our pointer really is storing the address of our n variable. Now, you may ask, how can I access, or can I access the value that is stored on that address using pointers? And the answer to that question is yes, you can. And in order to do that, in order to access the value that is stored on this address that your pointer is holding, you have to dereference your pointer. So how do you do that? Well, let me copy this. So as you already have seen, this line of code here is going to write out the address, and in order to write out the value on that address, you dereference the pointer, and in order to do that, you add this star symbol before your pointer's name. So if I run my program now, as you can see, in this last line of code, we have the value of 5, which is actually the value that is stored on this address here. So let me show you one more thing. What I want to do is I want to change the value that is stored on this PTR address, so on this address that our PTR pointer is storing. So how am I going to do that? I'm going to say, again, star symbol and then PTR, and this here means please access this memory location. So whatever I'm going to assign here is going to be stored on that memory location, and what I want to assign is, for example, value of 10, like this. So now if I copy this line of code and then paste it here, and if I run my program again, we have this value of 10 stored on this address here. And one interesting thing as well is that if we try to write out the value that our n holds now, like this, if I run my program, as you can see, our n holds the value of 10 as well, even though we have never said that n has the value of 10, but we have stored the address of our n in our pointer, and then we have dereferenced our pointer, meaning we have changed the value on that address here in this 11th line of code here. So that's why our n holds value of 10 now. One very important thing to keep in mind is that your pointer has to be of the same type like the variable that it is pointing to. So let's close this. So as I said, this integer pointer is pointing to an integer variable. So our n is of int type. And the same way would be if we created a float pointer, it would have to point to a float variable, and then char pointer can point only to a char variable, double, bool, and so on. So pointer and the variable that that pointer is pointing to have to be of the same type. Okay, so that means that if I try to change the type of this n variable to float, for example, like this, so if I say float, immediately we get an error here, and the error says a value of type float pointer cannot be used to initialize an entity of type int pointer, meaning you cannot assign address of a float type to pointer of int type. Okay, so that is the error that we have here, and I'm going to return this to int. Okay, and as you can see, that error has disappeared because now our pointer is pointing to the same type, so to the variable of the same type that that pointer has. So int pointer pointing to an int variable. One thing that beginners very often try to do is the following. So they say, okay, let's create a pointer. So int, let's give it a name ptr2, so pointer, like this. So I have created a pointer, right? So let's dereference this pointer and assign it a value. So I'm going to say, please dereference ptr2 and assign it a value of 7, for example. Now this code here has a problem, and if I run it, if I say build solution, actually, as you can see, it says uninitialized local variable ptr2 used. This means that this ptr2, so this pointer 2, does not have an address. So where should it store this value of 7 if it does not have an address? And the easiest way right now to solve this problem is going to be to create a variable and to give the address of that variable to our ptr2 pointer. So I'm going to say int v. This variable has to be of the same type as our pointer, as we already said. And then I'm going to say here our ptr2 is going to hold the address of our v variable, like this. And now we shouldn't have this problem anymore. So if I build my code again, as you can see, one succeeded, so the problem has disappeared. And let me write out the value of this v variable. So I'm going to say v is equal to, and then let's write out the value of this v. And if I run my program, as you can see, it says that v has the value of 7 because we have assigned it here by dereferencing our pointer that is holding the address of our v. So you may say now, okay, Saldina, I understand this, but this seems a little bit too much. Why would I create a pointer just to assign a value to a variable? And the answer to that question is you don't. This is not the type of problem for which pointers were created in C++. So there are different problems that pointers solve in C++, and this here is just a demonstration of what are pointers and how can you create your own pointers. Now, examples of some of these other problems that pointers solve is you can use pointers in order to pass values by a reference to a function, and then you can use them to return multiple values from a function, which is an interesting one. You can use pointers in combination with arrays as well. You can use them for dynamic memory allocation, and then if you're familiar with OOP, object-oriented programming, you can use a pointer of a base class in order to access an object of derived class. And then there is this concept of smart pointers, which we are going to cover in the future. So I believe as well that I have mentioned some of these things in some of my videos, but I plan to make a dedicated series to pointers where we are going to talk only about pointers. So stay tuned, subscribe to my channel, hit that bell icon as well so that you are notified when I publish my next video. And if you like this one, give it a thumbs up. Thank you for watching, and I'm going to see you in my next video where we will be talking about pointers. Bye! Hi everyone, welcome to my channel. In this video I want to talk about void pointers. Now in the previous video of this playlist I introduced you to pointers in general, so I explained what are pointers and how you can create your own pointers, and I said that a pointer is a special variable that can hold an address, and I said as well that a pointer can hold only the address of a variable that is of the same type as that pointer, which means an integer pointer can hold the address of an integer variable, and then a character pointer holds the address of a character variable, float pointer of a float variable, and so on. But there is an exception to that rule, and that is a void pointer. And a void pointer is a special type of pointer that can hold the address of a variable of any other data type. So a void pointer can hold the address of a float variable or an int variable or a char, bool, struct, whichever one you pass to that void pointer. But a void pointer has a limitation as well, and that limitation is that you cannot directly dereference a void pointer. So in order to demonstrate this, I'm going to create an example with the knowledge that we already have, so using only integer and character and float pointers that we are already familiar with, and then I want to introduce a void pointer in order to solve that problem so that you can see how void pointers are used. So let's jump into our Visual Studio. Here I want to create a variable, and let's make it of int data type. So I'm going to say int, and let's call it number, like this, and I'm going to assign it a value of 5, for example. Now what I want to do with this number variable is I just want to write it out, and because we are working with pointers, let's play with pointers some more. So I want to write out this variable using a function that receives a pointer. Let's do that. So that function is going to be of return type void, and let's call it print number, like this. And then here this function is going to receive an integer pointer, and we are going to call it number ptr, so number pointer. Okay, now what this function here should do is it should just print out the value that this number pointer is storing. So actually the value that is stored on the address that this number pointer is holding. So in order to do that, we have to dereference this pointer. So I'm going to say star symbol and then put the name of this number pointer, and let's add an end line as well. Now this function is finished, and it is writing out the value that is stored on the address that we pass to it, and we have to pass it the address of an integer variable. So if I invoke this print number function, let's say print number, as I said, since it is receiving a pointer, we have to pass it an address, and that is going to be the address of this number variable. So let's say ampersand number. So this here is going to give us the address of this number variable. Okay, and now if I run this program, as you can see, this function here has printed out value of 5, which is the value of our number. Okay, now what happens if I want to create a character variable and then print out a character variable as well? So let's do that. I'm going to say char, let's call it letter, and let's assign it a value of a letter A. Okay, and now in order to print out this character using this same approach, I will have to create another function, because this one here receives an integer pointer, and in order to print out a character, we would have to create a function that receives a character pointer. So let's copy this function here, and I'm going to call it print letter, like this, and then this function is going to receive a character pointer. Okay, and that pointer is going to be called char ptr. And then here, I just want to write out the referenced value of that char ptr. So let's invoke this print letter function. Let's pass it the address of this letter variable that we have created here. And now if I run this program, as you can see, we have 5 for this first function and then a for this second function, which means that these two functions are doing its job. But what happens if I want to print out a floating point number and then a double and then a Boolean value and a struct value? In order to do each one of those, I would have to create a function that receives that specific data type pointer. But we can solve that same problem using a void pointer, because as we already said, a void pointer can point to a variable of any data type. So let's do that. Let's create a function that is going to print out any data type. So that function is going to be of return type void, and let's give it a name print. Because it is generic, it is going to work with all data types. I'm going to give it name of print, and as we said, that function is going to receive void pointer, and let's call that pointer ptr. Okay, now because this void pointer can point to a variable of any data type, we will have to keep track of which data type we have passed inside this void pointer. And in order to do that, I'm going to use another parameter here, and that parameter is going to be of type char, and I'm going to call it type. So how this type parameter is going to be used? Well, in a situation where we pass an integer pointer to this print function, here this type parameter is going to have a value of I. In a situation when we pass a character pointer to this void pointer here, in this type parameter we are going to pass a value of C. And then if we pass a float pointer here, we are going to store an F. And then if we pass a double pointer here, this type variable should store a letter D, so that we can know how we are going to dereference this PTR pointer. So the first thing that we have to do is we have to check what this type variable is holding. So in order to do that, I'm going to use switch case like this. You can use if else as well if you want. So here I'm going to switch on this type variable like this. And what I want to do here is I want to say, in the case that this type variable is holding the value of I, that means that this here is an integer pointer. So here I'm just going to leave a comment for now. So I'm going to say handle int pointer like this. And then the other situation is going to be, in the case that this type variable is holding the value of C, that means that here we have passed a character pointer. So I'm going to leave another comment as well. So here I'm going to say handle char pointer. Okay, now let's explain how we are going to handle this integer pointer and then this character pointer as well. Well, as we already said, since a void pointer cannot be dereferenced directly, but we first have to cast it into a specific data type, so into an integer pointer or into a character pointer in this particular situation, I'm going to do that. So here I'm going to say, in the case that our user has passed an integer pointer here, I will have to cast this void pointer into an integer pointer first. So how do you do that? Well, you say, please, this pointer here, so this PTR, cast that into an integer pointer. So this expression here is going to cast this void pointer into an integer pointer. So in these parentheses here, we are going to have an integer pointer. And in order to access to the address that an integer pointer is storing and write out the value that is stored on that address, we dereference that pointer. And for that, we use this star symbol. So now here we have the value that is stored on this integer pointer. And I'm going to write out that value like this. And let's add end line as well. So this here writes out the value of an integer pointer. So let's copy that and then paste it here. And here what I want to do in this C situation is I want to cast this void pointer into a character pointer, so char pointer, and then after I have character pointer here, I dereference that, and then this line is going to write out the value of our character. Okay, so now if I invoke this print function, I should get the value of this number and then of this letter as well, using only this print function. So let's comment these two for now, and let's invoke our print function. So I'm going to say print, and then the first thing that it receives is going to be the address. And in this particular situation, considering that this is a void pointer, we can pass it the address of any data type. So we can pass it the address of a integer variable or of a character variable or of a floating point variable. And in this situation, we have integer variable and then character variable. So let's use these two. So let's pass here the address of our number. That is going to be the first parameter. And then the second parameter is going to be the type. And considering that we have passed the address of an integer, let's pass the value of I as our second parameter here. Okay. And then I'm going to copy this function one more time. And this time I want to pass it the address of our letter variable. And considering that that is a character, here as a second parameter, I'm going to pass C. Now I've just noticed that something is missing from our switch case, and before I say what it is, please write your idea, write your answer in the comments down below. So what we are missing in these two cases is break at the end. So here I'm missing a break, like this, and then here as well. Okay, so now we have completed our switch case, and if I run my program now, as you can see, for this first line, we get the value of 5, which is our integer. So this print function has printed the value of our integer. And then in this second line, we have printed out the value of a character. And we have done that using this print function, which receives a void pointer, and then it receives a char variable which is called type, and we use that char variable in order to differentiate which data type we are storing inside this void pointer. Because, as I already said, a void pointer can point to a variable of any data type, but it cannot be dereferenced directly. So for that, we are using this type parameter to check which data type is stored inside this pointer here. So now you have an idea on how to use void pointers, but I would actually advise you to be very careful when using void pointers. Why? Because your compiler in this particular situation does not have a way to tell you, hey, you are trying to cast a void pointer, which is actually an int pointer, into a character, or vice versa. If you're doing that, your compiler in this situation here does not have a way to know if you are making an error or not, because inside a void pointer you can store the address of any variable, so of a variable of any data type, and then you can try to cast that void pointer into a pointer of any other data type, which means, for example, in this particular situation, here we are passing an integer. So this number here is an integer, which means that here for this line of code, we are receiving an integer pointer. Okay, and then in this case here, we are trying to cast that into an integer pointer, and that is okay. But if we accidentally make a mistake here and we try to cast that into a character pointer, for example, like this, our compiler now does not have a way to know that we are making a mistake here. And if we run our program, look at this. We get this undefined symbol here, which is, what is this? You know, this is not the expected behavior of our program, and we did not get a compile time error, which means that this here is completely valid, so your compiler is not going to tell you that this here is an error, but it actually is a logical error. And those type of errors, so logical errors, are much harder to find inside programs. And this here is a small program, and it is kind of easy to find an error in a program that has 20 lines of code. But if you had a logical error in a program that has 20,000 lines of code, for example, you would have a very, very big problem. So again, I strongly advise you to be very careful when you are using void pointers, because as you see, compiler is not reporting an error for this situation here, but this actually is an error. So I'm going to return this to an integer pointer. Okay, so I hope that you enjoyed this video and that you learned something new. And if you did, give it a thumbs up, subscribe to my channel, and thank you for watching. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video, I want to talk about pointers and arrays, and if you watched the first video of this playlist, you remember that I said that one of the common uses of pointers is using them with arrays. So in this video, I want to demonstrate how that works. So let's jump straight to our Visual Studio, and let's create an array of type int, and I'm going to call that array lucky numbers. Like this, and let's say that I have 5 lucky numbers, for example, and those are 2, 3, 5, 7, 9. Oh, that's 5 numbers already. Okay, so these here are my lucky numbers, and now I want to show you one thing. So what is going to happen if I say, for example, cout lucky numbers, and let's add end line. So what is going to be written out if I write out just the name of my array? Let's check that. If I run this program, as you can see, we get an address. But what is this address? This address here, so the name of our array is actually the address of the first element of that array. And in order to prove that, let's write out the address of the first element of this array to check if these two are going to be the same. So here I want to write out the address of the first element, which is the element with index 0. So now if I'm telling the truth, these two should be the same. So if I run my program, as you can see, indeed, we get the same address, which means, again, the name of the array is the address of the first element of that array. Now, that means that this lucky numbers name behaves as a pointer, and these square brackets here are behaving as a operator for dereferencing. So if I say, for example, cout lucky numbers of 2, I'm going to get the element that has index 2. So this here is going to be the first address, and then it is going to add 2 more addresses to that element, and we are going to get the value that is stored there. So lucky numbers name is the address of the first element. It is going to add 2 more addresses to that, so 1, 2. So this line of code here is going to give us the value of 5. Let's add end line and run our program in order to demonstrate that. And as you can see, indeed, we get the value of 5. Now there is another way to do this same thing here, and that is going to be the following way. So I can say cout, please write out this lucky numbers, which, as we already demonstrated, is the address of this first element. So I'm going to put that here. And then I can use arithmetic operators on this. So I can say, please add to this lucky numbers 2 more address spaces, and then dereference this. So we use star symbol for that. And then I'm going to add end line and these 2 lines of code. So this one here and this one here should behave the same. So if I run my program now, as you can see, we get the same value. So these 2 lines of code are doing the same thing. which means that this line of code here is using these square brackets in order to dereferentiate the element with that index, which is index 2. And we know that the indexing starts with 0, so 0, 1, 2, and we get the value of 5. And then this second line of code here uses this star symbol in order to dereferentiate this expression here. And what this expression here says, it says lucky numbers, which is the address of the first element, as we demonstrated here. So please use the address of the first element and then add 2 more address spaces to that. So the address of the first element, if I add 2 more to that, it's going to be the address of 1, 2, so the address of this one here, and then if I dereferentiate that, I get this value which is stored on that address. So these 2 lines of code are writing out the same thing. So let me very quickly show you how you can enter the values for this array and then write them out, because here we have hard-coded values. So I'm going to delete this, and I'm going to comment these 2 lines of code as well. No, actually I'm going to comment all of these because we don't need them anymore, but I'm going to leave them for you so that you can see how these are used in order to dereferentiate your array. So as I said, we want to enter values for our array now. So in order to do that, I'm going to use for loop. So I will say for, and then our for loop starts with I equal to 0, because that is the index of our first element. And then, considering that our array has 5 elements and the last one has index of 4, we are going to run our for loop while I is less than or equal to 4. And in each iteration, we are going to increment the value of our I. Okay, and in order to enter values for our array, let's write out a message. So I'm going to say cout number, so please enter a number. That is going to be the message for our user. And then I'm going to input a value from my console into lucky numbers of I. So this here means please enter the value into our lucky numbers array to element that has the same index that our I holds in that iteration. So in the first iteration, index 0, in the second iteration, index 1, and then in the third iteration, index 2, and so on. So this for loop here is going to help us to enter the values into our lucky numbers array. And in order to show that, I'm going to put here a breakpoint, and that means that our program is going to stop its execution when it comes to this line here. So if I run my program, as you can see, it asks me to enter a number. So I'm going to say 2, 5, 7, 9, and 13. So those were 5 numbers that we had to enter for our lucky numbers array. And if I press enter one more time, as you can see, our program has been stopped in this line of code here. And if I hover over my lucky numbers, here we have values that we have entered for our array. So value of 2, 5, 7, 9, and 13, which are the values that we have entered here. So I'm going to stop my program now. Please stop. Okay. And now what I want to do is I want to use this other approach to write out the numbers that this lucky numbers array is holding. So let's use another for loop. I'm going to copy this one. Okay. And then what this second for loop is going to do, it is just going to write out these numbers. But, okay, let's use this approach for now. So I'm going to just change this to cout and then use these other redirection signs. And after each number, I'm going to add an empty space. Okay, like this. And instead of using this approach here, so instead of using these square brackets in order to dereferentiate the element on that position, let's use this approach here. So I'm going to say, please use lucky numbers, so which is the address of the first element, and then to that I want to add the value of my I, so plus I, like this, and this is going to move. Okay, So this expression here is going to help us to access all of the elements of this lucky numbers array. So from the one that has index 0 until we come to the one that has index 4. And because we don't want to write out addresses, because this here is going to give us the address, but we want to write out the values that are stored on those addresses, we will have to dereference this expression here. So for that, I will use star symbol. And I'm going to remove this breakpoint now, and I'm going to start my program to see what is going to happen. Okay, and let's enter 2, 3, 5, 7, 19. And as you can see, we get values of 2, 3, 5, 7, and 19, which we have entered. Okay, let's stop this program now. And there is one more thing that I want to show you. What is going to happen if I change this max value from 4 to 5, like this? So what is going to happen in this particular situation? Let's run our program and enter numbers again. So 2, 5, 7, 13, 15. Okay, as you can see now, here we have these 5 numbers that we have entered. So 2, 5, 7, 13, 15. Those are the ones here. And then the last one is something that we do not recognize. What is this? This is some junk number that we definitely have not entered here. So this number here is something that does not belong to our lucky numbers array. And here we have accessed someone else's memory space. So we have this result because we changed the max value from 4 to 5 here. And as we already know, our lucky numbers has 5 elements. The last one having the index of 4, which is this one here. And then here we added one more iteration. So now we are trying to access the element with index 5. And that element with index 5 does not belong or does not exist in our lucky numbers array. So this element here, this is memory location that belongs to someone else, and we accessed that trying to dereferentiate the pointer to the element that is 6th element. So we have 5 elements in our lucky numbers array, and then if we add one more address space to that, we get this here, which is memory location that belongs to someone else. And if we just randomly change and access memory locations that do not belong to us, we can cause very, very big problems. So I advise you to be very careful when iterating through your arrays and to access only memory locations that belong to that array that you are iterating. So in the case that your array has 5 elements, those are going to be from 0 to 4, so indexes from 0 to 4. In the case that your array has 10 elements, for example, those are going to be indexes 0 to 9, and so on. So again, be very, very careful to not access memory locations that do not belong to you. So I hope that now you have an idea on how pointers and arrays go together, and as well we have seen some of the potential problems that can happen if you are not careful enough when working with pointers and arrays. So again, I advise you to be very careful when working with pointers and arrays and not access memory locations, memory addresses that do not belong to you. So thank you for watching this video. If you enjoyed it, if you learned something new, give it a thumbs up and subscribe to my channel, hit that bell icon as well. You can follow me on my other social media if you want. Links for those are going to be in the description of this video. Thank you for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video, I want to explain how you can use pointers in order to return multiple values from a function. So I said in the first video of this playlist that using pointers to return multiple values from a function is a very common use for pointers. So in this video, I want to demonstrate how that works. So here we are going to create an array of numbers, and then first I want to create 2 functions, and one of those 2 is going to return me the smallest number in that array, and then the other one is going to return me the largest number in that array. And then in the second part of this video, I want to show you how you can use pointers in order to get both smallest and largest number using one function only. So you can return both of these numbers, so min number and max number, using only one function, and that is going to be with the help of pointers. So let's start with this example. As I already said, I'm going to create an array of numbers. So those are going to be numbers of type int, and let's call this array numbers like this, and it is going to be array of 5 numbers, and let's assign them values of, for example, 5, 4, minus 2, 29, and 6, for example. So those are going to be my numbers. Okay, and now let's create a function that is going to return the smallest number of this array. So I'm going to create that function here, and let's give it the return type of int, and I'm going to call it get min, like this. And what I will need to pass to this function is going to be array, so this array here. So I'm going to say int numbers array. So this is going to be the first argument, and then the second one is going to be the size of this array. So I'm going to say int size, and we will use this second parameter here so that we know how many iterations we have to make in order to go through all of the elements of this array. So let's define this function. The first thing that I want to do is I want to create a variable of type int, and that variable is going to be called min. So this is going to be the variable that is going to hold the minimal value, so the smallest number in this array. And initially I want to assign to this variable the first element of this array. So I'm going to say that the smallest element initially is going to be the first one. So I'm going to say numbers of 0. And then we are going to iterate through all of the other elements, and each time that we find an element that is smaller than the current value of our min, we are going to store that value in our min. So let's do that. So I'm going to say for, and since we have already stored the value of our first element in our min, we do not need to iterate through that. So I'm going to say that my int initially has the value of 1. Okay. Oh, int I is equal to 1, like this. And then our for loop is going to iterate while our I is less than the size of this array. So in this particular situation, while our I is less than 5. And in each iteration, we want to increment our I, like this. So as I already said, if we find a number on a specific position, which is in this current situation the position with the index of I, if we determine that that number is smaller than our min number, like this, we are going to store that number in our min variable. So I'm going to say min is equal to numbers of I, so that at the end of this for loop, in our min variable is going to be the smallest number of this array. So at the end of this for loop here, we can return our min, like this. Okay, so now in order to test this function here, I'm going to invoke it. Let's say get, actually I'm going to write it out. I'm going to say cout min is, like this. And then let's invoke it. Let's say get min, like this. And this get min function receives array, so let's pass it numbers array, and then it receives the size of this array, and this array has 1, 2, 3, 4, 5 elements, and you can check that here as well. So we are going to pass 5 here. Okay, and if I run this program, as you can see, it says min is -2, which really is the smallest number in our array. So that is going to be the first function. And then the second function that I want to create is going to be the one that is going to return the largest number in our array. So let's copy this function. I'm going to copy it and then just modify it a little bit. So the name of that other function is going to be get max, like this. And then that function as well will receive numbers array and the size. But here we are going to have a variable which is called max instead of min. And again, we will assign it the value of our first element. So then we iterate through all of these elements. So starting with the second element, because first, the value of the first one we already have inside this variable, so we do not need to check that. But if we find in these remaining elements, if we find element that is larger, so bigger than our max, let's copy this here, we are going to store the value of that element in our max variable, like this. And then at the end, we will return our max variable. Okay, so now in order to test this function, I will invoke it as we did with this previous one. I will just say max is, and then invoke get max, like this. And I'm going to add 2 end lines here so that we have output which is formatted nicely. And if I run my program now, as you can see, it says min is -2 and then max is 29, which is correct. So let's explain one more time the algorithm that we are using here in order to determine the biggest number of our array. So here in this first line, I say that the biggest number is the one with the index 0, so the first one. And then here we iterate through all of the remaining elements, and that is from the one with index 1 until the last one. And if we find that any of those remaining numbers is greater than our max number, then we say that our max number is equal to that number. So at the end of this for loop, we will have in our max variable the largest number of this array here. Okay, and we have accomplished to get our min number and then our max number using these 2 functions. Oh, I'm sorry. So using this get min and then get max function as well. So now what I want to show you is how you can use one function only to get both min and max number. So let's do that. Let's create a function which we will name void get min and max, like this. And this function is going to receive, like these 2 previous functions, our numbers array and the size of the array. And then, considering that we want to return 2 values from our function, we will have to pass those 2 values by a reference, which means we will have to pass the addresses of the 2 values, and then this function here is going to change the value that is stored on those 2 addresses. And this function here, our main function, is going to have the access to those 2 addresses as well. So once this function here assigns the value of min and max numbers to those 2 addresses, our main function is going to be able to access those values. So as I said, let's pass to this function as well int min, like this, and then int max. So we are receiving here pointer to a min number and then pointer to a max number. Okay, so the job of this function will be very similar to the jobs of the 2 functions that we just created. So I will just copy this and then paste it here. And once more, we are iterating through all of the numbers of our numbers array. And then here we say if you find any number which is greater than our max number, and here we have an error which says operand types are incompatible, so int and int pointer, which means that here we have to dereference this pointer using the star symbol. So if you find any number which is greater than our current max, please store that number inside our max, like this. And then I'm going to copy this code one more time for our min number. So I will say if you find any number which is smaller than our min number, like this, please assign that number to my min number, like this. So this is going to be the work that this function will do. And considering that this function is receiving these two, so min and max, as pointers, this means that this function is directly going to modify the values that are stored on these addresses. And those same addresses are going to be available in our main function, which means that once this function changes the values that are stored on our max and our min address, this main function here will be able to access those changed values. And using pointers, in that way we have achieved to return multiple values from our function. So let's invoke this get min and max in order to test what I just said. So I'm going to comment these two lines of code because we do not need them anymore. And because here we have to pass min and max, we will have to create those two variables here as well. So I will say int min, and as we did before, I'm going to assign to this min the value of my first element, like this, okay? And then I will create max variable as well and assign to my max variable value of my first element as well. And now let's invoke this get min and max function. So let's say get min and max, and let's pass it parameters that it needs. So the first one is numbers array, so I will say numbers, and then second parameter is size of that array, so 5, and then it expects to receive two pointers, so min and max, and we will have to pass addresses of our min and then address of our max as well, like this. And this here is called passing a parameter using a reference. So that means pass an address of a variable to your function rather than passing variable itself, because then if you don't pass an address, your function is going to create a copy, and whatever changes your function makes with that copy, you will not be able to see those changes in your main function. So in this way, we are passing addresses, which means that this function here is operating on the original addresses, which this function here is accessing as well. So when this function here changes the values that are stored on those addresses, this function here will know. So that means that now if I try to write out, I will need to add semicolon here at the end. Okay, so that means now if we try to write out our min like this, min is, and then min, and then if we try to write out our max as well, max, we will get values of -2 and 29. At least we expect to get those two values if this function is working correctly. So if I run my program, as you can see, we really have values of -2. Let me just collapse this. So we really have values of -2 and 29 as the smallest and the largest number in our array. And we have achieved that using this pass by a reference. So by passing addresses of our variables to our function, which our function then changes the values that are stored on those addresses, and since this main function as well has the access to those same addresses, that means that our main function can see the changes that have been made on those addresses. So I hope that now you have an idea how to return multiple values from a function using pointers. So if you enjoyed this video, if you learned something new, give it a thumbs up and also subscribe to my channel. And I will be publishing more videos related to pointers in the future, so if you don't want to miss out on those, press the bell icon as well. Thank you for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. And in this video I want to talk about dynamic arrays. So you should already be familiar with the idea of arrays and the concept of fixed arrays from my previous videos. But for those of you that really want to understand the need for dynamic arrays, I will go through some of the advantages and disadvantages of fixed arrays so that you can really understand where the need for dynamic arrays arised. So we said that an array is type of collection which stores elements in continuous memory. Now that means that it stores elements one after the other. So if I do this, for example, if I say let's create an integer array of 5 elements and let's call that array my array, like this, your computer in the background will do the following. It will give to this array here 5 containers of type int, and those containers will be one after the other in memory. So that means because the array stores data in a continuous memory, so one after the other, accessing that data will be very, very fast. So because the name of the array is the address of the first element of that array, when you specify the name of the array and then you give it the index of the element that you want to access, it is going to be very fast to move from that first element until that position that you specified, so until the element that has that index. Whereas if you use some other collection type like linked list, for example, which stores data in non-continuous memory, which means in a random places in memory, and then each element contains a pointer to the previous one and to the next one, accessing elements in those type of collections would be much slower. So if you wanted to access 5th element of linked list, you would have to traverse the first 4 elements and then get to the 5th one, because they are stored in non-continuous memory, meaning they are randomly in your memory. So, as I already said, accessing elements of an array is a very, very fast operation. But because your array stores data in continuous memory, this has certain disadvantages as well. So, what happens if you want to insert or delete an element in the middle of the array, for example? So how can you insert or delete an element in the middle of the array without breaking that continuousness, if I can say it like that? So you get the point. That means that the operation of inserting and deleting elements in an array is going to be much slower than inserting elements in a linked list, for example. And if you want me to do a video which is related to differences between linked lists and arrays, for example, write it in the comments down below and I will make it in the future when I find time. So again, if you are not familiar with the basics of arrays, I recommend you to watch my first video, which is related to arrays and pointers, which I will link here, and then you come back to this one. So those were some advantages and disadvantages of arrays, and it will be up to you to decide which collection you want to use. However, here I want to give you the biggest disadvantage or the biggest obstacle that we encountered so far when working with arrays, and that is the following. So the size of the array had to be constant, which means that the size of the array had to be known before we even started our program. So we always kind of wanted to do this. So we wanted to say int size, and then we wanted to ask our user to enter the size. So please enter the size for the array. And then after our user enters the size for the array, we wanted to create the array that is of that size that our user specified. However, we get the error. As you can see here, it says expression must have a constant value, which confirms what I just said, which is that the size of the array had to be known at compile time. So the size of the array could not be changed once we declare it, and we had to declare it before we even started our program. So this problem was without solution so far, but surprise, surprise, if you know how to work with dynamic arrays and dynamic memory, you can very easily create an array in runtime. So in C++, there are 2 keywords or 2 commands which allow you to allocate and deallocate dynamic memory, which means to get yourself dynamic memory when you need it and then free that memory once you don't so that it can be reused. That is what allocate and deallocate means. And those 2 commands are new and delete. So new allocates memory, as you may guess, and then delete deallocates that memory or freeze it once you don't need it. So let's see how we can use this information that I just gave you on our example. So instead of doing this here, I will comment it because we do not need it. Instead of doing this, what I will do is I will create a pointer like this, and let's call that pointer my array. And what I want to assign to this pointer will be the following. I will say, please make this pointer point to new integer array, and the size of that array will be this size that our user entered, like this. Okay, and as you can see, our compiler is fine with this expression here. We do not have an error. So this new keyword has allocated an array of this size that our user has specified. And that array, the address of the first element of that array, is stored in this myArray pointer. So if I build this code, as you can see, we do not have compile time errors. So what I want to show you now is how we can enter elements for this array and then how we can write them out. And this is array, again, this is array which is created at runtime. So our user will specify the size of this array, which is something that we were not able to do before we learned how to use dynamic arrays. So in order to enter elements for this array here, as we already know, we will be using for loop. So I will say for, please iterate from the element which has index 0 until you come to the element that has the index of this size. Okay, and then in each iteration, increase our counter by 1. And what I want to do is I want to write out a message for my user. So I will say array, and then let's add index of the current element, index that our user is entering. So I, like this. Okay, and then what I want to do is I just want to enter an element on that position that we are currently iterating. So I will say my array of I, like this. So using this code here, we should be able to enter elements in this array here. And then in order to write these elements out, what I will do is I will use another for loop. So I will just copy this one and then paste it here. And in this particular situation, I just want to write out. So I will use cout command and then these other redirection signs. So I just want to write out all the elements of the array, and I will add a few empty spaces after each element so that we have nicely formatted output. So this loop here should write out the elements of our array. And if I start this program now, as you can see, it asks us to enter the size of the array. So let's say 5, for example. And now we are entering element with index 0. So let's say 2, 5, 7, 9, and let's say 11. Okay, and as you can see here, we have the elements of our array written out. And we wouldn't be able to do this if we didn't know how to work with dynamic arrays. So let's stop this program. And there is one more thing that I want to mention, and that is following. These square brackets here are only one way to dereference your array. Another way to dereference the array or to access the element on a specific position is the following. So the other way to access the element on a specific position would be using this asterisk symbol, and then here you say my array plus I. Now, because the name of the array is the address of the first element, here you have the address of the first element, and then when you add a certain number to that, it will move that many spaces in memory and then access the element on that position. And when you dereference that, you will get the value of that element instead of its address. So here is one way to dereference your array, and then here is another way to dereference your array, and you can use whichever one you prefer. And if I run this program again, just to demonstrate that it works the same, let's say 3 and then 1, 5, 10. Okay, we get 1, 5, 10 as the elements of our array. One very important thing that I mentioned at the beginning is that we have two commands for working with dynamic memory. And one of those two commands is new. So we said that new is a command which will allocate memory for us when we need it. And then another one is going to be delete. And delete is a command which will deallocate that memory when we do not need it so that it can be reused. Now, using dynamic memory comes with a responsibility, and that responsibility is the following. Each time that you allocate memory when you need it, you will have to deallocate that memory once you don't, so that that memory can be reused. So that means that each time that you write new command, you will have to write delete command once you don't need that memory anymore. So I will demonstrate how can you deallocate the memory that we have allocated for this my array. So let's say that here in this line of code, we do not need our array anymore. So how can I deallocate the memory that I allocated for this array? Well, using delete keyword. And I will say, please delete the memory that I allocated for my array, which is called my array, like this. And you have to specify these square brackets because that is the way that you allocated memory. So here you said, I want new array. And then here you have to say, please delete that array. And a good practice is to do the following as well. So you can say my array is equal to null, like this. And let me collapse this. So this here is going to assign the value of null to your array. So your array will not point to anything, to any address at this line of code. So why do we do this? Because in the previous line of code, we have deallocated this array here. And now in this line of code here, your array will point to a location in memory which does not belong to you, so it does not belong to your program. And because of that, because we do not want to cause some accidental crashes or problems in our program by having this array pointing to memory locations which are not ours anymore, it is a good practice to say that our array is now equal to null, which means that it is not pointing to anything. So, as I already said, and I repeat again, when you use dynamic memory, each time that you write new, you will have to write delete that corresponds to that new. So here I have allocated an array, and here I am deallocating that array. So I hope that this video was helpful and that this video helped you understand what are dynamic arrays and how they work. And now that I have explained this, it opened the whole world of new possibilities and new things that you can do with dynamic arrays. And I will leave to you to play and discover those new things until my next video, of course. So thank you for watching this video. Give it a thumbs up if you liked it. Subscribe to my channel, click the bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if you're interested in those, please subscribe to my channel and give this video a thumbs up. And in this video, I want to talk about a topic that confuses many students, and that is the topic of multidimensional dynamic arrays. And the topics like this one are the reason why many people step away from learning C++, and they believe that learning C++ is hard. But what I think is that many of those people never actually had the opportunity to have this explained in a very simple way. So that is what I will try to do in this video. So with the help of Excel, I will try to draw what are multidimensional dynamic arrays and how they work. And I hope that at the end of this video, you will have it pretty clear and you will be able to create and work with your own multidimensional dynamic arrays. So what a multidimensional array is, in simple words, it is an array of arrays. And in this video, you will learn how to create two-dimensional dynamic arrays And in order to be able to understand this topic, you should be familiar with the topic of dynamic arrays, which is a video that I already did on my channel, and I will link it here. So make sure to watch that video before watching this one. So I will very quickly remind us all of how dynamic arrays work, and then we will see how we can use that knowledge to understand multidimensional dynamic arrays. So let's create a visual representation of a dynamic array in our Excel sheet. So let's say that it will be an array of 4 elements, like this. This is our array, and the indexes of these elements start with 0 and then 1, 2, 3. So these are the indexes, and then the address of this first element will be, for example, 0000AA, like this. And this address here, it is the address of the first element, but it is the address of the array itself as well, and you should be familiar with that. So this here is our dynamic memory, and then on our stack, which will be here, let's create our stack. So this here will be our static memory. Here we will have to create a pointer variable which will hold the address to this element here, or actually the address to the array itself. So I will create a variable, let's call it ptr1. So this is going to be our pointer 1, and as we already said, that pointer will hold the address of the first element of this array. Let's copy that address like this, and then we will store that address in our ptr1. Now, if we wanted to create more arrays, by the knowledge that we have so far, we would have to copy this, and then let's paste it here, and let's create one more array like this. So now we have 3 dynamic arrays, and the first element of the first array has the address of 0000AA, and then this one here, let's say that it has the address of BB, for example, and then this one here has the address of 0000CC. And to be able to access these arrays, we would have to create on our stack 2 more pointers. So let's do that. Okay, so our pointer 2 will hold the address of the second array, which is 0000BB, and then our pointer 3 would hold the address of our third array, which is 0000CC, like this. Now, with this, we have created 3 dynamic arrays, and in order to create those 3 dynamic arrays, we had to create 3 pointers. So those are these 3 here, and this is something that you should already be familiar with. So you should already know from my previous video how to create a dynamic array. Now, one thing that I see here, and that is a problem, is that if we wanted to create 4 or 5 or 100 of these dynamic arrays, we would have to create that number of pointers on our stack, which means that this part here is not dynamic. Only this part here is dynamic, because here our user determines how many elements this dynamic array will have, but for each of these dynamic arrays, we have to manually create a pointer on our stack which will hold the address of that array. Okay, now what happens if I want to move this part here to our dynamic memory as well? So let's do that. Let me cut it from here, and then I will paste it here, for example. So now I have moved this part to dynamic memory as well, and as you can see here, this kind of looks like an array as well. So that means that this first element, if we look at this as an array, the first element will have index of 0, and then second will have index of 1, and then third will have, oh, this won't move. Third will have index of 2. Okay, so this is an array that has 3 elements, and the first element, for example, has the address of 00EEEE, like this. So now this part here is dynamic, and then this part here is dynamic. And in order to be able to access this array here, what we have to do is on our stack, which is this part here, we will have to create a pointer which will hold the address of this first element. So let's do that. Let me just, okay. Now, as I already said, on our stack, we will have to create a pointer which will hold the address of this first element. So let's call that pointer table, for example, and this table will hold the address of this element here, which is 00EEEE. And this table, because it holds the address, it should be a pointer. But one thing to keep in mind is that this variable here is not a simple variable, but this here is a pointer as well, which means that this table will not be a simple pointer, but it will be a pointer to a pointer. And you indicate that using two asterisk symbols, because one is just a pointer, and then two mean a pointer to a pointer. Why? Because this table holds the address of the element, which is this one here, and that element is pointer as well. Okay, now if we look at this here, as you can see, we have one array that represents the number of rows that our table will have. Okay, so 1, 2, 3, and then for each one of the elements of this array here, we create a separate dynamic array like this. So this here will be our table that has the number of rows that our user defines, and then however many columns our user defines as well. And in this particular situation, it is a table that has 3 rows. So these are 3 rows, and then 4 columns. So let's now translate this to our C++ code. And because we said that now our user defines how many rows this table will have and then how many columns as well, that is the first thing that I will do. So I will create 2 variables. Let's call them int rows and columns. And then I will ask my user to enter how many rows and how many columns he wants this table to have. So let's do that. Cin rows, and then columns, like this. Okay, now after our user has entered how many rows and columns he wants, what I want to do now is this part here. So this part here, this is our first step, and then this here is going to be our second step, and this part here will be the third step. So this part here will be the following when translated to C++ code. So here, as I already said, I create a pointer to a pointer, which I will call table. So I will say, please create an integer pointer to a pointer, because here we will store integer values. You can create a character or a double or float, whichever one you want. I want to create integer pointer to a pointer and call that table like this. Okay, so we are done with this first part here. And then what this table pointer to a pointer will point to is going to be this array here. So I will say, please create a new integer array that has this many elements. So the number that our user has entered for this rows variable, because this rows variable holds how many elements this array here will have. But as you can see here, we have an error, and that error is happening because this here, which is this array here, is not just a simple integer array, but it is an array of pointers. So here you will have to indicate that. So you will have to say, please create an integer array of pointers. And as you can see, now our error has disappeared. And with this line of code here, we have created this array here. Now, our third step is going to be that for each element of this array here, we would have to create a separate dynamic array. So this first element will hold the address of this dynamic array, and then this second element holds the address of this array, and then this third, the address of this array here. So what I will have to do is I will have to iterate through all the elements of this array, and for each one I will have to create a separate dynamic array. So let's do that. So I will say for int I is equal to 0, and then I is less than the number of rows that our user entered, and in each iteration increment I. So in this particular situation, our number of rows is equal to 3, but you can have as many as you want. So what I want to do in each of these iterations is I want to create for each one of these elements a separate dynamic array. So I will say table of I is equal to new integer array that has this many elements. And that is the number that we stored in our columns variable, like this. And with this code here, we have successfully created these dynamic arrays. Now, how do you access elements on a specific position of this table here? For example, this one, or this one, or this one. So in order to do that, let's say, for example, table of row 1 and then column 2 will have the value of 88. Now, what this code here, what this line here will do is the following. So this part here, it says, please give me the table variable, which is this one here, and it is a pointer to a pointer, which holds this address here, so 00EEEE, and that address is the address of this element here, so the address of this array. And here we say, please give me the element of that array that has index 1, which is this element here. So it is the element that stores the address of 0000BB, which is the address of this array here. And this second part says, please give me the element of that array that has the index of 2, which is this element here. So here we will store the value of 88. So that is what this line of code here will do. It will store number 88 to this position here. So this line of code here will store this number at the element that has row index 1 and column index 2 of this table. So this here is a row with index 0, this here is a row with index 1 and then 2. So we are storing at this row. And then column index 2 is this one here. So here we store number 88. One thing that we said as well in my previous video is that each time that you allocate dynamic memory, you have the responsibility to deallocate that memory when you don't need it, which means each time that you use new keyword, you will have to use delete keyword when you don't need that memory anymore. So now is the question, how do we deallocate all of this memory that we have taken? So in order to do that, what I want to do is I want to show you something. If for some reason we lose this address here, so the value that is stored in this table pointer to a pointer, we will never be able to access all of these elements that we have created in our dynamic memory. So that means that we will not be deallocating this first. And then if we for some reason lost this, the value of our 0000AA, for example, that means that we would never be able to access this array here. So we would never be able to deallocate this memory. So that means that this is not going to be deallocated first as well. Now, allocation of this memory here went as follows. This was the first step. So this was the first thing that we allocated, and it is this code here. And then we allocated this. So that corresponds to this part here. And then the last thing to allocate was these arrays here, and that corresponds to this part of the code. And the allocation of this memory will go the other way around, which means that first we will deallocate this, and then we will deallocate this, and then this will be the last thing that we will have to worry about. Now, in order to deallocate this, the process will be almost the same as the one when we allocated it. So I will copy this for loop and then paste it here. But what I want to do in this particular situation, so when deallocating, is instead of creating a new dynamic array for each table of I, is I want to delete that array. So for each element of this array here, I want to delete the corresponding dynamic array. So I want to delete these 3 arrays. And in order to do that, I will say, please delete the array that my table of I is pointing to. Now, what this code here will do is for this element here, it will deallocate this array here. So let's delete that. And then for this element here, it will deallocate this array. And then for this one, it will deallocate this array here. So now we have successfully freed this memory that we have taken here. Now, after we have done this, after we have successfully deallocated our first step, which was here, this part here will be our second thing to deallocate. So here I will say, please delete the array that my table variable is pointing to. So this line of code here will deallocate this part here. So I will say, please delete that. We do not need it anymore. Okay. And then our third step, which is the last one, will be to null this value here. Why? Because we have just freed the memory that was here, so we have deallocated that. Now someone else might be using this memory here, and we really shouldn't keep the address of someone else's memory. So we should make this a null value like this. And in order to do this in our code, I will just say, now my table will hold the value of null, like this. And this will prevent some potential crashes and problems in your application. So I hope that this video helped you understand multidimensional dynamic arrays a bit better. And if it did, please give it a thumbs up and subscribe to my channel, because that helps me to reach more people and hopefully make programming a little bit easier for them as well. Thank you very much for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina. I'm a software engineer and I make IT and programming related videos here on YouTube. And in this video, I will be doing something that I haven't done before, and that is reviewing your code, and we will see some errors that you guys have sent me. So I get a lot of messages, a lot of questions on my Instagram, on Twitter, and then here on YouTube as well in the comments, where you ask me for an opinion or for advice on certain errors that happen to you in programming. And I try to answer as many of those as possible, but it's just not possible to answer to all of you, and I'm very, very sorry. But I thought that it would be a good idea to make a video related to that so that all of you can see it. So here I am, I'm making that video right now. So in this video, I will be reviewing some code, and we will see some errors that can happen and that do happen very often. And I'm going to do that both manually, and then I want to show you a very cool tool which is called PVS Studio. I'm going to leave details in the description down below so that you can check it out for yourself. But what PVS Studio is, it is static code analyzer. So it is basically a tool that reviews your code and helps you detect bugs and errors and security weaknesses in your code. So in the case that you need another pair of eyes to look at your code and give you a few tips and recommendations, it is a great tool to use. And you can get it as a team license for teams up to 9 people, or you can get an enterprise license for bigger companies, bigger departments, or you can even request a free license if you are a student, if you are working on some private projects or on some open source projects. And then one very cool thing is that it is not only used to analyze C++ code, but you can use it for C and then C# and Java as well. And I am wondering, guys, which team are you in? Are you team C++ or are you team C# or Java or C? I'm very curious to read your answers, so please write me in the comments down below. And if you ask me, I'm definitely team C++ and then team C#. Those are just two of my favorite languages ever, but I am very curious to read what you will answer to this question. So I'm going to leave all the details about PVS Studio in the description of this video so that you can check it out for yourself. And let's jump into the coding part right now, because I am very, very excited to do this. Here I have created a new project and I have this program that does basically nothing. So what I want to do is I want to check if everything is okay with this code so far. So if we have made any errors so far. So I'm going to click on extensions and then PVS Studio, and here you have multiple options. You can check your current file, you can check open files, or you can check your project, selected items, solution. I'm going to select this first option, so I'm going to check this current file, and you get this window here. And as you can see, we have one error, and that error is that my license will expire in 5 days. Okay, so that is not error which is related to our code, so we are just going to ignore it, so we don't have code errors so far. And let me show you how you can install this tool very quickly. So you click on extensions and then manage extensions. Okay. And then here you can search for PVS Studio like this. Okay, great. It is this one here. So PVS Studio is a tool for detecting bugs and security weaknesses and so on. Okay, so you will click download here and your download should begin. I'm not going to do that right now because I already have it. But once it is downloaded, the installation is pretty simple. So it's basically next, finish installation. So that should be simple. Okay, now let's close this window here. And as you could see, we don't have any errors with this code so far. So let's write some code and let's create some errors now. So let's create an array of type int, and I will call it saved money, and that will be an array of 5 elements, and I want to initialize those elements here. So the purpose of this array is following. Let's say that I want to save some money each month, and I want to store that data in this array here. So I'm going to save money for 5 months, and I will store how much money I have saved each month inside this array here. So for example, the first month I have saved $100 or euros or whatever, and then second month I have saved 200, and then 300 and 400 and 500 fifth month. Okay, so this is our array. Now what I want to do with this data here is I want to sum it. After 5 months I want to know how much money I have saved in total. So I'm going to create a variable of type int, and I will call it total like this, and I will initially give it a value of 0, and then I will iterate through this array here. So I will say for int I is equal to 0, and then I is less than or equal to 5, and then I plus plus. And what I will do inside this for loop is I will say that my total will hold whatever my total was previously holding plus current value of how much money I have saved in that month. So saved money of I. Okay, now after I have done this, I will just write out how much money I have in total. So I will say total, and then this value that is stored inside this variable here. Okay, now if I run this program, let's see what will happen. Well, it says that in total I have minus 8 billion something, very big number. So I have tried to save each month, and then at the end I have minus $8 billion, so that does not make any sense. So here we have a logical error. Okay, so let's see what is this error that is happening. So let's click on extensions and PVS Studio, check current file to see what kind of error PVS Studio sees. And it says array overrun is possible. The value of I index could reach 5. And if I double click on that, it will take me here. And this part of code here is underlined, and this is actually our compiler. Our compiler is underlying this, and it says that, okay, it says index 5 is out of valid index range of 0 to 4. So this situation here says that this I is out of range of valid indexes that this array here can have. And if you are familiar with arrays, you know that indexing of an array starts with 0. So the first element has index of 0, and then 1, 2, 3, and 4. So valid indexes for this array here are from 0 to 4, and here we have accidentally written that this I is less than or equal to 5, and that is making a problem. So if I delete this part here, so if I say that my I is just less than 5, this error should disappear. So if I click on PVS Studio and then check current file, the error should disappear. Okay, it has disappeared now. So if I run my program, this program is behaving as expected. So this is one thing that very often happens. You can accidentally write less than or equal to, and then you can get a very big logical error. Another thing that can happen is if you're typing very quickly and if you lose concentration for a moment, and here instead of incrementing, you decrement this counter. So you say I minus minus, you should get an error as well. So if I try to build this program, let's see what our compiler will tell us. So here in this error list, it says ill-defined for loop counts down from minimum. So that's kind of helpful information. And then another, let's read this other warning. It says reading invalid data from saved memory. The readable size is 20 bytes, but minus 4 bytes may be a read. So this is not really helpful for someone who is just starting. And then this third message, it says index minus 2 billion something is out of valid index range 0 to 4. Again, this is not really helpful for someone who is just starting. So let's see what our PVS Studio has to say. So I'm going to click Extensions, PVS Studio, check current file. Okay, and this first error here says the condition I less than 5 of for loop is always true. So this is actually a helpful message, and if I click on this, I will be taken here, and it says that this condition here, I is less than 5, is always true. But why is it always true? Because we have started counting at 0, and then we try to decrement that value in each iteration, and doing that, we can never reach this condition here. This condition here will never become false. So that means that here we have created an infinite loop. And here our PVS Studio says, consider inspecting this for operator. So consider inspecting this for loop here, because it will not be executed at all, or it can be executed incorrectly. And in this particular situation, it is going to be executed incorrectly. So it is going to be an infinite loop, which we don't want in this particular situation. So I'm going to correct this error here. So I'm going to return it to I++. But that is sort of a help that you can get from PVS Studio. And this here is a pretty simple program because it has just a few lines of code where all the bugs can potentially happen. But imagine working on a very, very big project and then something like this happens. So imagine something like this happening on a program that a bank uses. So you are trying to save money for a couple of months, and then the program says that you are in debt, that your balance is minus 2,000 or 20,000 or something like this. So this can create very, very big issues. And in this particular situation, if you have a bug like this, you will want to have all the help that you can get. And sometimes that can be just the help that you get from your compiler, or if you have a very, very big problem, you will definitely benefit from tools like PVS Studio, which will give you some additional information on that situation that is happening and on that problem that you are having. And then there are other situations where you can have very, very big problems, but your compiler will not be helpful at all, because your compiler will not be able to see those potential bugs that you are creating inside your code. So in order to demonstrate that, let's delete all of this code here, because I will not need it anymore. And what I do need is to create a function here. So let's create a function of return type void, and I'm going to call it my function, like this. Okay, and what I want to do inside this function is I want to create an integer pointer, PTR. So if you're not familiar with the topic of pointers, make sure to watch the playlist that I will link here. It is the playlist where I explain pointers in C++, because it is one of the most important topics in C++, and it is the example that I will be using here. So I have created an integer pointer, and I'm going to say, now you will point to a new array of integers, and that array will have 5 elements, like this. Now, what do I want to do with this array? Well, let's do something very simple. Let's say ptr of 2 will hold the value, okay, it will hold the value of 10, like this. And then let's just write out something. Let's say, hi, I am equal to, and then ptr of 2. Okay, so this here is pretty simple example that does basically nothing important, nothing useful, but I will use it to demonstrate a very, very big issue that can happen in this situation. So I'm going to invoke this function here. So I'm going to say my function, like this, and I have successfully invoked this function. So if I run this program, it says, hi, I am 10. So nothing unexpected happened. Or did it? Okay, if I inspect my errors list, it says that I don't have any errors. So if you ask a compiler, it will tell you that everything is perfectly fine. So let's now ask PVS Studio. Here it has already detected 2 potential issues, but you can click PVS Studio and then check current file just to be sure. Okay, and it says visibility scope of the PTR pointer was exited without releasing the memory. A memory leak is possible. So what we have done here in this program is we have created memory leak. Where? Here. So here we have said, please give me, in my dynamic memory, give me array of 5 integers. And this is going to be done in dynamic memory. So once this function is finished, once this function ends, we are going to lose this PTR. So we are going to lose the address of the first element of this array here. So here, if I try to do something like PTR, I cannot access this variable here anymore. This variable has its scope, and that scope is inside this function here. And once this function exits, we are going to lose the address of this array here, which means that we will not be able to deallocate this memory here. Now let's delete this. Okay, here, as you can see, this memory leak is not a big memory leak. Here we are leaking 5 integers. So we are leaking an array of 5 integers, and that is not very big problem. But usually what happens in real life is that you are not creating an array of 5 integers. Usually you are creating things that require much more memory than just an integer array of 5 elements. So here, as I said, we are leaking 5 integers, but imagine a situation where you are creating an array of 5,000 or 50,000 and not integers, but objects of type user, like this. And this user has some pretty heavy data in it. For example, it has some images and things like that. So here you are creating 50,000 users. And to make things worse, imagine not invoking this function only once, but imagine invoking this function in a for loop, for example. So invoking it 100 times or 1,000 times or 100,000 times. That is going to be a huge memory leak. So what this line of code here does is it asks your operating system for dynamic memory. So it says, please, can you give me new memory? So can you give me dynamic memory that I need to store this data here? And your operating system gives that memory to your program. So it allocates that memory for your program. And then once this function here finishes, you will lose all the variables that you have created inside that function. And that is this PTR variable here. So that means that the address of this array here, which was stored inside this PTR variable, is lost now. And now you will not be able to deallocate this memory here, which means that you will not be able to say, okay, now I am done with this memory, which is a lot of memory, and now I'm going to return that back to my operating system because I don't have unlimited amounts of memory, and my operating system maybe would like to give that memory to some other program. So once this function here ends and you don't deallocate this memory here, you are leaking that memory. And that is exactly the error that you have here. It says a memory leak is possible, whereas your compiler here said expected a type specifier, which is error that we have here because it does not know what is this user. So I'm going to return this back to int. Okay, now that error has disappeared, but your compiler does not know that you are leaking memory here, whereas your PVS Studio analyzer here says that a memory leak is happening. So how do you fix this error here? Well, for each new, you need to have delete. Again, you need to watch my C++ pointers playlist in order to understand pointers if you don't understand this already. So as I said, for each new you need to have delete. So I'm going to say delete, and let's delete this PTR. Let's see what is going to happen now. So if I click extensions and then PVS Studio check current file, it says the memory was allocated using new array type operator, but it was released using delete operator. And then it gives you a recommendation here. It says use delete array pointer instead. So here we are trying to allocate memory for an array, but we are not deleting that entire array. So here we are leaking memory again. So here I'm going to use these square brackets in order to indicate that I want to delete this entire array that I have allocated in this line of code here. So now we shouldn't be leaking memory anymore. So let's check that out. I'm going to say PVS Studio, check current file, and let's see. We have that error that we previously had, which is your license will expire in 5 days, but we do not have memory leaks anymore, which is great. So errors like this, memory leaks, are very common when you work with pointers in C++, and these memory leaks can create huge problems if you have them in your code. And as you could already see, in most cases you cannot really count on your compiler to tell you that you are leaking memory, because in most cases it will not even be able to see that. So tools like PVS Studio can be very helpful in those situations. You could see all those little tips and recommendations that we had from PVS Studio that helped us to fix issues that we had related to leaking memory. So those were some topics that I wanted to address in this video, because many people, when working with pointers, will come across problems that they will not be able to fix, or they will not even be aware that they have those problems, that they have memory leaks, until it gets to the point where it is unmanageable and they have very big problem, they have huge problem. So if you have any more questions that you would like me to make video on, please leave those in the comments down below. And if you like this type of video, please give this video a thumbs up so that I can know. And I will make more videos like this in the future if you want me to. So thank you very much for watching this video, and I am going to see you in my next video. Bye! Hi everyone. Well, okay, so hi everyone, welcome to my channel, welcome to another Hi everyone. Hi everyone. Welcome to my channel. So this here is the initialization step of our initialization
Initialization.
So it is the